Good day, people. You are watching part 6 of the series called How to Create a Horror Game. My name is Igor Aherne, and I'll be your guide for today's lesson. Even though this is just the 6th tutorial, we managed to get through a lot of knowledge. This is why expect today's one to be quite intense. One of the most important aspects in game creation are characters. Overall, 3D-wise for games, this subject is the most hardcore. It is the peak of 3ds Max difficulty, so you gotta be prepared. Please make sure to go thoroughly through the previous 5 parts before approaching this one. By the end of today, you will know how to create a professional custom rig of any kind of creature you would ever think of. Couple of things that I would like to add before we begin. First one is that you gotta turn on the annotations. Later, sometime after the release of this video, I might add extra notifications to provide extra explanation. For best learning experience, ensure that they won't be missed. Also, please ask questions in the comments below. Most interesting ones will be included, and I'll go over them in the following parts. It is a long lesson, and I've spent a lot of effort to compress a 20-hour session into a reasonable time full of juice. On top of that, you'll cover the content in one go. You won't have to worry about traveling from part to part. Character rig, here we come. My name is Igor Aherne, and believe me or not, I've already got my tea and cookies. Let's get started. Before we start learning how to rig, let's examine our character that I've created for this purpose. As you can see, it's some kind of creature with many wounds, inside of which there are parasites sitting. And those parasites are spreading their veins to other parasites, and that way infuse the whole body with tentacles. This is a mutant, as I call him, because he'll probably be mutating along the gameplay, and this is one of the versions that he'll represent. There probably will be one more variant for the character, that is, the transformed version. However, for now, let's focus on this creature. If you look further on, you'll see that it has very big wounds, and actually you can see its bone below the knee on the front side, and also a piece of the bone on the back side, over there. The parasite modified the body, and now it has claws sticking out of the back, or spikes. And of course, his trousers are all ripped, and the veins are crawling through the trousers and out of the wounds. So it's quite scary, to be fair. The guy has 5 fingers and 4 claws in the feet. I also made the head for the creature, but you won't see it there. I will only show it to you in the final retopologized version. So the process of creating this character was to make a high polygon mesh in ZBrush, with all the details and stuff, out of Z-spheres. Then shape them out and keep on drawing. The body was shaped out in a general way in the beginning, and then the minor things such as those veins, their detailization, the parasites, their heads and eyes, because each one has little eyes that you can't see here, but you'll see on the texture, those details were added at the very end, including this kind of roughness of the skin and little veins that belong to the character. You might want to look at the anatomy lessons just to see the basic flow of muscle, but I know simple location of muscle, especially on the hands and the chest, because that's what's exposed at the moment. Learn general position of the bicep, the muscles that come into the hand, brachialis that connects tricep with the bicep deltoid, etc. There are plenty of tutorials on YouTube, the best one of which I think is Ryan Kingsling. He makes some excellent tutorials on anatomy, so search for him. At the end, I want to recap the stages that I've been going through as I was creating the character. So first of all, I've created in ZBrush a high representation of body for the creature, and also at its early stage inside ZBrush, I actually unwrapped the character, before bumping the polygon count up with divide, just so that later on when I decide to polypaint it, I won't have to bother unwrapping a model with huge number of polygons. So, just unwrap it at the beginning, and then doesn't matter how much you bump extra polygons on top of it, with Division or Dynamesh, you'll still have your UVs laid out. Then I exported the model and brought it to 3ds Max, where I've created its 2 little brothers, the retopologized versions of high body and the high head. Inside of 3ds Max, I unwrapped those models, went back to ZBrush, then polypainted my creature. It already had its UVs laid out, because I did it in stage 1. I didn't have to worry about unwrapping this huge polygon count model in ZBrush. It was already done before by me. I then created a texture out of this polypaint, just like I've explained to you in the 5th tutorial. Went back to 3ds Max, remembering that I have to project the normals from high polygon representation to a low poly, the retopologized version. That way, of course, I created the normal texture, the one that I've been talking about in part 3. I want to make sure that you understand 2 differences. We have the high polygon model and the low polygon model. The first one was unwrapped in ZBrush, it has totally different UV layout. The low polygon version, the retopologized one, was unwrapped in 3ds Max, and was unwrapped to its best ability. We ensure that we cover almost all the area of our UV layout table. This is because for our first high polygon representation, we can afford a big texture, for instance a square with dimension of 2000 by 2000. In the retopologized version of the creature, that we are actually going to be using later on in the game, we can only afford to have a 1024 texture, in which we hope to fit both the body and the head. So that's already a difference between a big texture and a 1024 one. When we were creating normals, we were baking them in the favor of our low polygon object. So we have a texture which fits under the UV layout too. That is the normal texture. And we use the high polygon version of the model to achieve this. We can't of course take the polypaint texture and throw it on our retopologized version because the UV layouts are different. That's why I did something similar to normals, went through the projection like I've taught you in the third tutorial, but instead of normals, I worked with diffuse map. My high polygon model had a diffuse texture, so I lined it up with my low polygon model, and using the cage I projected diffuse from high polygon's mesh polypaint, that is, from its material, to a low polygon's version material. What I've done is I've taken this texture, shoved it into the retopologized version's UV layout, which is much more tightly packed than the high polygon's version. However, this is 1024, and this one is something like 2K. That is, I've done the projection from a high polygon's material to a retopologized version's material. At this stage, I already had two textures that I could stick into my retopologized character. I already had a normal map, and I also had a diffuse map, both of which were modified via the projection to fit into the UV2. I ensured that there were no seams both from the normal maps and diffuse maps on the character. I've done this by going into Tools, Viewport Canvas, just like we've been looking in tutorial number 5. Or actually, the alternative to this would be to dilate the pixels on the edges of the UV patches. Long story short, just get rid of the seams, and of course, do this for both the normal map and diffuse map. If you want to create a specular map, we will have to glance at this now, as well as later on, as we will be working in Unity, but it requires you to create a texture that will have an alpha channel specifically to hold the transparency. PNG is the most optimal one, of course. Unity will not show any kind of shine on the parts of the models that sample from an area of the texture that is fully transparent. On the other hand, parts that sample from an area of a texture without transparency will have most of the shine. Of course, transparency only applies when we're talking about PNGs. If you're working with targas, you'll have to supply a fourth channel, that is black and white, and then export your texture at the highest settings. If you look at both file sizes, you'll see that targa is nearly 1.5 times bigger than PNG. So stick with transparency instead of the alpha channel. To quickly show you what I mean, here is my diffuse texture. And of course it's half transparent, and actually its transparency mask is not simply via the reduced opacity of the layer, but I was actually going around and brushing in and out those transparency patterns, simply erasing parts of the texture. Where you see a completely transparent picture, such as for example near the wounds, that is where the shine will not occur when the texture is laid on the model inside of Unity. But where it's a solid color, for instance right here, that's where it will shine the most. For targa, you have to have a fourth channel, black and white, which is kind of similar to working with PNGs. But for PNGs, just apply the mask, and then Alt-click on the mask and start painting with black and white, or paste your black and white version from your desaturated texture. Then, with this mask active, you want to press Ctrl-Shift-Alt-S to save your PNG 24 with transparency under a name that you want to, for example, Mutant Diffuse. This diffuse texture will be in the form of PNG, and because of its transparency, you'll be able to do a specular map, which will look quite amazing in Unity. That way, in Photoshop, improve the diffuse texture, so that with it you can emphasize the shiny areas of the model, that is, stick a specular channel into your diffuse map. This can be used then in Unity. Because this mask is a black and white representation of transparency for your diffuse, which, when we go into diffuse, is going to be overlaid on top of it, because it's black and white, save this black and white version into a JPEG format, go back into 3ds Max, apply material with this black and white pattern to your character, remove the seams using the viewport canvas, save this black and white version as a JPEG, grab it and import it back into the Photoshop. Finally, paste this modified pattern into your mask in here. That way, when it's applied to character, it will show no seams. So it's active and you would save your diffuse texture, which has a specular map description without the seams in it. As for your comparison, for example, if you save this texture in a Taga format, its file size will be 4 megabytes, which is very big. But for the character we can afford something like 2.5 megabytes, which is actually pushing the boundaries too much. But still, for the character we can use that size, and this is exactly what PNG24 will provide us with. So save your version of diffuse specular in a PNG format 24. What do we have at the end? A retopologized character with its own UVs, and we also have two textures, normal map and diffuse map, inside of which there is actually a specular map sitting in one of the channels. Having obtained those parts, you will proceed to rig your character. As always in such case, make sure that your model is correctly built. You want to have a look at polygon count, and actually this is a quite big amount. Usually you wouldn't want to go above 3000. However, because the character has so many wounds and little bumps on the body, the best way, of course, to outline them is geometry. But geometry is the most expensive resource. That's why you are using sometimes normal maps and specular maps instead of using geometry. So some of the polygon count went for the wounds on the body, also for the face. You can see that it's quite detailed, and probably fingers as well. It also has minor details such as bones, and on the other side from the back as well. If we turn it around, you can see what happens at the back. Several horns. Probably we could reduce polygon count on horns, since everything that horns are representing is this kind of shape. It has loops, which if removed, will be fusing those polygons in a one piece. Of course, after deleting those two loops, the geometry will look different, and we won't be able to preserve this nice flow of curve. So instead we'll have a kinky shape, something like this. And if we're really neat, we can actually get rid of those lines, the vertical ones. But then notice how it gets fused onto the body. If we would be removing those lines, that would mean that we have to change the surrounding topology of the creature so that the horn sticks correctly onto it. Notice once again, as mentioned in tutorial number 4, the whole creature is built with quads. If you use triangles when deforming your mesh, when working with its rigged version, when moving bones, your geometry will be deforming incorrectly. Triangles, pentagons, and something else is bad. Only work with quads. As you can see, they create nice rings around the hand and the body in general, and you can see and trace the flow of each curve individually. As always, I have two different objects making up my monster. The first one is the head, and the second one is the body. Keep in mind that if you want to do facial animation on the character, it's going to be easiest for you if you keep head as a separate object, because then you can work with morpher modifier. Also, when texturing, because you have two different objects, make sure that UV layout for the body provides space for the body parts, but then has an area for the head to go as well on the same texture. You can do this by following the instructions of the 4th tutorial. Have a look at most important joints. First of all, you want to ensure that the toes are able to bend. That's why you'll need at least 2 loops adjacent over here in the toe area. You also want to have several of the loops on the ankle to allow a nice deformation of leg in this area when the foot moves. Also, in the knee, make sure you have several of the loops, but not too many. Of course, the more polygons you have in this area, the harder it will be to animate it, because we have to tie it to a skeleton first of all. I'll be describing everything to you later. Keep in mind that you need a toe area, an ankle, a knee. Also, you must have a loop which goes inside of the body like this, connecting 2 legs. So make sure that there is a nice loop in here between 2 legs. You also want to have several of the loops. Keeping this in mind, also make sure that you have loops on the legs in this area, the loops on the main part of the body where the hips and the first spine join together, so a loop in here, and then sets of loops as the body progresses further. This is the most difficult joint to rig. It's the arm, or the armpit and the shoulder. Make sure that as the arm goes towards here, you have several of the loops, and especially a few loops in here. The arm should be able to move forward and backwards in this joint along the vertical axis. It also has to rotate, as well as rise up and down. The neck should also have several of the loops, but it's much simpler than the armpit. There has to be several of the loops going through the body like this, so that you can bend the chest in and outwards. A loop on the elbow, or 3 loops at least on the elbow. On your wrist you should have loops as well. And then for each of the finger you want to have loops, nearby loops at the joints of the fingers. For every single finger. Make sure that the arm is built in such a way that you have a loop which goes between the fingers, above and below the arm. Like this. Like so. And like this. If we recap this once again, in particular I have several of the joints. One for the toes, second one for the ankle, third one for the knee, a nearby pair in the bum area, so let's say 4. Few joints that go through the body. One very important joint for the shoulder, one joint for the elbow, another one for the wrist. And since each of the fingers has 3 parts, and there are 5 fingers, it's going to be 22. Also keep in mind that there is a second half, and you should duplicate parts that are sitting here, on the other arm, and also the shoulder. Of course, if your character has a tail, then you should consider joints for the tail as well. Using your experience, try to tell which is going to be more detailed. Our widow character, the way we were making it back in the 4th tutorial, or this creature. Which one will have the most details expressed through the texture? The answer is widow. This is because that character had a symmetrical body, and so in our UV layout we were allowed to describe just one half of the character and let the other half sample from here. But here, as you can see, the body is not really symmetrical. It has different wounds at different places that have different geometry and require specific approach. As well as that, the legs aren't symmetrical. There is a straight leg in here, which in fact has a bone crack in the front part. In this one, you can see that the bone is on the back side, so the legs aren't symmetrical. This of course adds a variety to our character, and it doesn't look as boring as the symmetrical one might. Because of that, we don't really have to add any kind of attributes such as armor that would make it look interesting. It already has enough of details on its body that entertain the eye, or in this case scare it. But the head, in this case, is symmetrical. Because many parts of this character look different, they can't sample from the same area of the texture, like the widow would. However, I still made it in a way that it has similarities. For example, this arm is exactly the same as this one. And also the head is symmetrical. The feet are as well, but the rest isn't. Well, if you have an excellent skill of unfolding model on the UV table, and if you manage to avoid any white spaces between the patches, for example in here, if your pieces are perfectly stitched together, you can actually go ahead and sample the horns from one single horn, which has its area of texture somewhere in here, for example. And then all of the 6 horns could be sampling from this area. But in my case, I still had white places, and all of the 6 horns were small enough to fit in them. When developing this layout, I of course provided some space for the head to go, and because head is a different object, I had to use the example from the 4th tutorial. However, then I can use one single texture, both for the body and for the head. Not only this reduced the texture size and improved our performance in that way, it also allows for the process named draw call batching, which happens in Unity. That way, this approach greatly improves the performance in that aspect. This was a very tricky detail right here. You can see that the bone is like a separate object. It's a 3D stick sticking inside of his leg. In my original model, it actually sticks up way higher, somewhere up to here. As follows, I had to reduce its height down here. Now my knee can bend correctly around this area. Watch out for details like this and try not to put them in your joints area. As I told you many times before, having characters that are skinned and rigged properly will raise your game at a new level. Correct rig allows for easier manipulation of bones and mesh in general. It is somewhat similar to tutorial number 5, where I show you how you can open gates via altering parameters. You can make rigs for any sorts of things: robots, items, or characters. Rigging is preparing a character for further animation. They have to fit in the overall gameplay, and to create realistic movements of body parts, you need a correct skeleton and a correct structure within this character. Rigging consists of several parts. The first one is the mesh overview. In it, we inspect how well the character is modeled, what kind of texture he has, where the seams align, is he modeled with quads, and how the rings are positioned. It's as simple as looking at the topology of character. We also need to ensure that he is scaled correctly, and that every body part is named properly. At stage 2, we'll start to build the skeleton for the character inside of his body, so that later we can force it to affect the mesh. This process is called skinning. Then we'll start to build relations between the bones. Add different controls to simplify the life of an animator. Each one of those sections has different sub-levels, but those are the general ones through which we will go. Keep in mind that if you haven't rigged a character before, you will have many fails, at least 3 or 4. We are in a very responsible part of our learning, that's why you shouldn't hurry. This is a stage where you should carefully watch for your mistakes, because any simple mistake or forgetting to do something might make your previous work go in vain. I want to stress this. Make sure you save your work as different files between the stages that you're working at and their sub-levels. It's going to be much easier for you to fix the problem if you make mistakes somewhere closer to the end, whereas if you do something wrong at the first 2 stages, it's much more likely to become a mess. We're going to be working on this mesh from 3 different views. The front one has the shortcut F, the left one with the shortcut L, and the top T. When we switch between those views, you see that they bring us to an orthographic mode. Exactly what would happen if you would press U. To go back to perspective, of course, press P, and you can always center on the model by pressing Z. This is just a revision from previous lessons. You cannot rotate around model in orthographic mode because it disappears straight away as soon as you start to rotate your camera. If you find this problem and you want to rotate around the character, probably you should switch to perspective. Then center on the character and start rotating your camera around him. If you go down to create, and so far we've been working with geometry, shapes, and lights, today we will make an explicit use of helpers and we'll be working with bones. Bones is a geometric structure which has some sort of hierarchy. So for example, you see that I created 4 bones by left clicking at different places and then right clicking to create this end nub at the end of the last bone. After this, let's right click once again to exit the tool of creation, and you can see that if I'm going to be rotating this bone, it's clearly affecting other children. If I switch to this one, we can rotate and affect the different children. If I press G, you'll see that it's actually located on the flat plane, and that's exactly the way it's created, but it still can be rotated in all 3 directions usually, unless you lock it. If you unlink the bone from its parent, you can then move it freely, and rotating it will still affect its children, but the parent bone will not have any grasp on any of its grandchildren or this bone that we detached from it. If we create bone in perspective mode, it's always going to be located first at the ground plane. However, if we switch to front, left, or top view and create bones from there, they will be actually built on the vertical plane. However, it doesn't always work if you switch to perspective mode. Let's say you want to click left on the view cube and then press U to go into orthographic mode. You cannot create bones in this mode because you're still going to be creating them on the ground plane. So left in orthographic mode isn't the same as pressing left on the keyboard. Have a look at which axes are facing which directions when we create it in the, say, left mode. Let's click on this bone, go into its properties and rename it to left. This one to left 2. Next one left 3. And its child, the end, we will call left end. Now we will switch to front view. Here is our left bone, right in the center. From the front view, we'll go into create once again, systems, and create bones in the front view. Double right click at the end to cancel creation and to exit bones. When we go into local, keep in mind that green is Y axis, X is red, and the blue one is the Z. When we switch back to perspective, go into hierarchy view, affect pivot, you can see the direction the pivot is facing at. This structure was created in the front view, and so the Z-axis is pointing towards the front view that we've created it in. It's the case for all of its children. That's why we'll be referring to Z-axis as the main one for our rotation, as to the main axis. Just to underline this example, have a look at this bone and notice that its Z-axis is pointing in a different direction. If we exit the pivot point, we can then rotate around the Z-axis using the blue circle. You can increase the circle size or the actual gizmo by pressing plus and minus on your keyboard. And if you want to hide it, simply press X, or in 3ds Max 2014, you have to press Ctrl-Shift-X if I'm not wrong, or Shift-X. However, the last time I checked, 3ds Max 2014 was so buggy that I actually decided to roll back to 2013. You can always change the pivot point of a bone, or the direction it's facing at, but make sure you do this with caution, since such manipulation is very tricky and might cause severe problems. As we create bones for this character, we'll be doing it in different views, since major rotations should occur around the Z-axis, the main one. You will see this in a second, but for now, we are on stage 1. Select the body, it should be called mutant body, and the head should be called mutant head. Now this is the most important part, and if you miss it, you are doomed to have troubles when importing your animated character later on in Unity. You need to ensure that you are working with correct scale. Go into Customize, Units Setup. Make sure it's in metric centimeters, the units with which Unity works. By default, it's generic units, and so our character should be scaled correctly relative to this system of measurement. If we go into the left view, you can go into Tools, Measure Distance, and measure a height of a character by clicking first at the toes and then next to the head. The distance is 227 centimeters, so our character is quite high. Let's go into perspective mode. Before resizing the character, let's first ensure that its pivot point is placed correctly. It should be at the lowest part of the body, centered between the feet. That's why I select the mesh, go into Hierarchy, Effect Pivot Only, center it to Object, go into Left View, and bring it down to the lowest part of the feet, and slightly further, so it's sitting somewhere here. Then deselect this option and you got your pivot relocated. For the head, the pivot point should be centered, and should be somewhere around this area where the neck joins the head. So center to Object and relocate it in the YZ plane. Deselect this option. Ensure that the character is zeroed out in the world, and for that let's link our head temporarily to the body. Select the body, press W to go into the move, go into Gimbal or World, zero out the coordinates by either selecting them and entering 0 or simply right-clicking on the spinner. After this, let's unlink our head from the body. Since our body is too big, let's rescale it slightly. Press R, click on this button, enter the absolute mode, and from the world's center, rescale both objects altogether by a factor of 10%. Go into the left view and check the distance once again. Tools, Measure Distance. Click on the toes and then click on the head. Follow the grid, by the way, because you might do it diagonally and then your distance will be increased. Check it over here. Now it's 2 meters. It's still quite high, so we'll select the body once again. In the absolute mode, we're going to enter a size which is 10% smaller than this one again. Tools, Measure Distance. This looks more right. Press P and go into perspective mode. Make sure that you reset X-form on this character, or anything that you've been rescaling. Go into Utilities, apply Reset X-form to your selected objects. You can then right-click and convert to Editable Poly to collapse all the stacks altogether on both of the objects, instead of going into Modify, selecting each object and right-clicking, collapsing all for both the head and the body. Instead, if you don't want your character to have Editable Poly modifier, then click Collapse Selected. Because we want to ensure that the main rotation always happens around the Z-axis, that's why we will be creating those bones from different views. Since everything below the knee rotates backwards, it's going to be happening in the axis parallel to our arms. As follows, that axis should be Z. As explained before, we need to create this in the left view, so that the Z is pointing towards our left view, and is parallel to our hands. Let's go into the side view, the left one, go into Create, Systems, Bones. There'll have to be one for thighs, another one for the shin, and then you might think that there should be one bone in here, but in fact you'll need 2 bones here. One to allow the rotation happening from the ankle in this area, as well as another one to allow the heel to be lifted slightly, but have the base of the foot remaining on the floor. As follows, there are going to be several of the joints. The main one is the knee, and the easiest one, then the ankle, the one between the ankle and the base of the foot, and later we'll add a joint in here to fuse it with pelvis. Let's press F3 and enter orthographic mode. And actually everything is too light, so I'm gonna press Ctrl A because I have just the body and the head. And I'll change the wireframe color to black. If you want to turn off the grid, you can do this by pressing G, but in my case it's okay. Clicking on the bones, I'm going to start it from the top of my foot and left click anywhere where I want to put a joint and start drawing a second child of this bone. The base of the foot should be at the lowest level of the feet. Then left click and right click. I want to modify the sizes of those bones, but to simplify my life, let's go into the enclosed selection mode, press Ctrl A and then press Alt and left click and drag to enclose the bones from our selection and exclude them. Now we have our body and the head selected. Let's right click and freeze the selection. That way, no matter how hard you try to access the body, you won't be able to select it. First, you'll need to unfreeze all. For each of our bones, let's increase the width to about 3 and do the same thing with height. You can reduce the tapper if you want to have a more square bones, so put it down to 0. Do the same thing for all of the children. To quickly switch between those input areas, you can simply press Tab after entering your number. Make sure you don't forget the end. Also select your bones once again and change their color to a green one. But this one isn't bright enough for me, so I'm going to add a custom color from the very top. Select it and press OK. If you didn't position your bones quite correctly, don't worry because you'll change their length later on. For now, go into the front view and notice that your bone has been placed right in the center of the screen. Press W, select the parent, and if you double click you're going to select the whole chain. You don't want this. Just select the parent, get out of this mode, the absolute mode, and in the X-axis, using the spinner, relocate your bone to the left side. Now it sits right in the center of our leg, but this is the typical problem. The modeler, me in that case, created a model in a way where its feet are at an angle to each other. We don't need this. We want it to be straight. Let's unfreeze our mesh, select the character, go into the vertex mode, and having the feet selected, let's go into the soft selection, then click edge distance and grow out your selection upwards. Play with the settings. In my case, make edge distance 15, make sure you enable it. For the fall off, I'll set 70, and for the pinch, I'll set 0.7. Then I'll grab my leg, and here is the trick. Using the world's axis, we need to move it to the right in a positive direction of X-axis. Go into the X input, delete whatever you have there, and write R4. With the same settings, select those vertices, select whatever you have in X, and put R-4. Because my legs aren't really symmetrical, I can afford myself to relocate different body parts. You want to ensure that your legs are straight. Now our bone is exactly in the center of our leg. Let's give each of the parts the right name. The top one should be called mutant thigh left, and then add underscore bone, just to make it easier to identify which objects are bones. Let's copy this name and switch to the next bone. Having the bone in the center of our leg, let's freeze our mesh once again. Press Ctrl A and with enclosed selection mode, press Alt and deselect the bones. Right click, freeze the selection. And if it turns into gray color and you don't want this, you can go into Objects Properties and make sure that Show Frozen in Gray is deselected. Freeze the selection. Let's rename each of our bones correctly. Select the top bone, call this one mutant right thigh, and then add underscore bone just to make it simpler to identify which objects represent bones in the scene. Copy this name, switch to the next bone, enter the name and rename thigh to shin. The next one should be called mutant right ankle bone. The last one, mutant right foot bone. Now we have our bone sitting in the right leg. I don't really think that I've positioned the joints correctly right here. I need to pay slightly more attention to them. That's why, let's go into Animation, Bone Tools. This is a new window, which you probably haven't seen before. Of course, it allows us to edit bones. You can enter the bone edit mode and select each bone specifically in the left view, then reposition it in the YZ plane. Make sure that you recreate this ending bone, so delete it, select its previous parent, and from the Bones Tools menu, create end. Rename the end to mutant right toe end bone. If you go into the front view, you don't want to break this relation in here. Vertically, you want the structure to be straight. Back to the left view, let's reposition the ankle. The end bone should be ending where the claws start. After this, select your chain, go down and reset stretch and reset scale. Then go out of bone edit mode. We now have a chain that is sitting in the right leg. Let's duplicate it to the left side so that there are bones for the left leg as well. To do this, you'll have to select the whole chain, and from the Bone Tools menu, select Mirror. Mirror the whole thing in the X-axis. Press OK. Readjust the position of the whole chain to fit in the left leg. Click on the right thigh bone and copy its X position in the world representation. Go into the newly created thigh bone and in X, enter the same amount that you've copied, but with a different sign. With that, we ensure that the bone is displaced by the same amount in the opposite direction, and that the structure is kind of symmetrical. Let's go into the front view, and we'll see that the leg needs slight adjustment. I will readjust the position of vertices on this leg to wrap around the bone correctly. I can do this specifically for each leg, only because their geometry isn't symmetrical. If it would be, then I would have to pay great attention when moving those vertices, and I probably would only allow myself to work in this area. Select those vertices and displace them by equal amounts with the same settings for fall off. Our character looks like a soldier ready to march because it's standing so straight, but it doesn't matter. Our job is to rig it, and then the animator can reposition it in the way he wants later. If you look at the newly created bone chain and pick any of the bones inside of it, look over here and see that it's called mutant right, although this is the left chain, thigh bone, and then you have the mirrored suffix. You can go ahead and fix all of the names in each of the bones one by one. However, it's going to be much quicker if we use a special tool for that. Go into Tools, Rename Objects, deselect the base name. For the prefix, enter mutant left. Then remove first 12 digits, since those are the characters making up our mutant right on all of the bones. Deselect the suffix, but remove last 10 digits. This will remove both the brackets and the mirrored suffix from all of the bones. Make sure you select the newly created chain and click Rename once. Then check the new name of each of the bones. As you can see, we got rid of the mirrored suffix, and each of the bone now says left. Select your bones once again, enter the bone edit mode, and reset stretch, as well as reset scale. Exit bone edit mode. We've been creating legs in the left view to favor the rotation around the Z-axis. Because of that, the Z-axis will pass like this, towards us. This is exactly the case for all of the joints. Now let's focus on the spine. We can either go into Create Systems Bones, or from our favorite Bones tool menu we can create bones. We will need a few spines in here. Keep in mind that the pelvis will go into this area, so we will not touch it for now. Instead, we'll create spine somewhere from here. And although in real life the spine of a human is located somewhere here, in our case we want to position it in the center of the mesh. We're going to have 3 spines going like this, and then the neck. This is going to be a separate system, separate one from the legs. Notice how this bone is longer than the previous ones. It is so because chest area doesn't bend easily. However, if you want to subdivide this bone into more, you can actually go and refine it. Click somewhere in the center of the bone to refine it. We are going to call our bones spines, and we will add numbers to them starting from the base bone. This one will be number 1, number 2, 3, 4, 5. We don't need the end, so we will delete it later. And actually, let's delete it straight away so that it doesn't bother us. The endings of the bones are quite important, since we're going to be using them in I-key solving. If you look closer, you can only affect the bone via its rear end. However, if you want to access the ending of the bone, you would automatically think about selecting the following child, because then you would be altering the joint at the end of this bone by moving the rear ending of the child. However, this bone doesn't seem to have one, that's why we're sticking there an ending. Let's go into each bone and increase the size to about 4, and let's not do any tapper. Maybe for the neck, let's set the width to be slightly smaller, 3. After this, we clearly need to readjust our bones, so enter the bone edit mode and alter the rear ends of the bones, changing the position of the joints that way. And actually I think we deleted the end bone slightly early, so let's create it and reposition it the way we want to. Select your chain, go down, reset stretch, reset scale, and exit the bone edit mode. After resetting the stretch and the scale, it's best to delete end bones and recreate them. Make sure to rename each of the spine bones correctly. For the end bone, call it mutant spine end bone. At this stage, save your work by going into Save As and save it in the designated folder specific to this character. Call it the name of your character, rigging, skeleton 1, and save your work. Now we got two systems of bones. We got the legs that originate from the pelvis, and we also got spine that goes upwards. The major parent to this chain is of course at the bottom of the spine, and the major parent to the legs is at the top of the legs. Both of them have the greatest influence on their respectful chain. By rotating this spine, we're going to be altering the whole further chain. And this is going to be happening from this point in here, the rear end from the first parent. The same story happens in here. As well as that, there should be one more bone between them, the pelvis. If you remember, bones are geometric pieces that are linked to each other, similar to this tool. This is why we're going to stick this main parent of the top chain belonging to the spine towards pelvis via linkage. Then the main parent for the legs will also be linked to the pelvis. Then this pelvis can be displaced in any direction, for example forwards, backwards, or to the side, up and down, and the chain will be moving with it respectively. The top one will be moving to the right with it. The same will happen with the legs as well. Let's enter the bone edit mode. Create new bone, left click to initiate its start, left click once again to finish it, and then right click. Right click once again to exit create bones mode, enter the bone edit mode, then reposition your bone in the right place. Actually, with this pelvis, while in bone edit mode, you can go into align and align it to the main parent of the top chain. Align it pivot to pivot, press OK, go into front mode, and align it to either of those two main parents on the legs. Keep in mind that we only want to align it in the YZ plane, so deselect X, that way it will stay centered, but if we check from the left view, it's going to be aligned with both of the parents from the side. Let's delete our ending, because we won't need it. To be fair, some of the people might prefer to have IK control over the spine, but if you don't care, we won't need this ending, because we won't be using IK solvers for the spine. The pelvis is one of the biggest bones, similar to head, in our skeleton. Let's go into its properties, change the width and height, or you can do this actually in here, but beware that this is using generic units. I'm going to make this 6, and 6 in here as well. Then rename the pelvis to a mutant pelvis bone. I want to change its color as well as change the color for the bones. Let's select our lovely green. It might seem strange, but the thigh bones should initiate from the center of pelvis. Select the first main parent on the right leg, reposition it to be somewhere in the center of pelvis, and actually let's quickly create end on the pelvis and bring our pelvis down slightly. Then delete this temporarily ending bone, go into the front view, select the left main parent of the legs, and then do align to the right main parent of the right chain. Once again, we only want to ensure that we are aligning regarding to the Y position and Z position of the right main parent for the right leg. Before we do anything, let's reset the stretch on the pelvis and the bottom chains, as well as reset scale. Then we can safely link it to our pelvis. So now we have all three chains uniting in one point. If we test it now, you will see that the pelvis is carrying all three chains with itself as we move it. Also, the rotation will affect them as well. As you look at the body from the front side, you might notice that it's slightly offset to the right side. But since the body part is not intended to be symmetrical, in this case it doesn't really matter, as long as the arms and the shoulders are in the equal distance from the main spine. We can check to see if that's the case. Our symmetrical arms are starting from this point of the shoulder in here and right there. Let's zoom in closer, go into Tools, Measure Distance. Then click at the start of the shoulder. Click on the spine at the same level as the shoulder. Test the distance, 17 centimeters. Then repeat this procedure once again. It is 17 centimeters as well, and we don't have anything to worry about. Keep in mind that this joint is going to be the most difficult one. We want to ensure that anything we do in those areas or the areas of the shoulders is going to be very neat. That way we will be able to avoid any kind of problems when working in this area. We need to create 2 shoulder bones, so let's do this now. This shoulder bone should be created in the top view to favor the rotation around the vertical axis when the character humps his back or arches the chest. So go into the top view, using create bones, make a new chain consisting of 1 bone. Perhaps let's change their size to 2. Then let's recreate the end bone. The tapper should be 90. While not in bone edit mode, select Align and align it to the rear end of this spine. Align it in all 3 positions, but not in orientation, and press OK. Go into the front view and in bone edit mode, grab its child, then extend the whole bone forward. Position it somewhere in the middle of the shoulder. We will adjust it later. From the top view, ensure that its end is sitting in the middle of the arm, somewhere here. Check this once again from the front view. Change the color of the shoulder bone to green and rename it to a mutant left shoulder bone. Do not worry about its end, since we will delete it eventually. Positioning this joint is crucial to a correct skeleton. If you misplace it, when your character drops down his arms, you will have huge shoulders that will look horrible. Try to trace a line parallel to your spine. Also trace a line parallel to your arm, going under the armpit. The joint has to be in the middle of this section, but we also need to decide how far in or out of the body it should be. From the intersection of the line going parallel to the arms and the line going parallel to the body, draw a ray that is between those 2 lines, but at 45 degrees angle between each one of them. So 45 in here, and also 45 right here. Having a look at the blue segment, from its middle, you want to draw a line and keep going until it intersects with this point. That's the place where it should be approximately. Now we will have to grab our end bone and reposition it to be in this place. Keep in mind that in my case, I don't have a symmetrical body, but I do have symmetrical arms. That's why, to simplify my workflow, I'll simply create this chain for the arm and then duplicate it to the left side. If that wouldn't be the case, you'll have to do your left arm manually if it wouldn't be symmetrical. Even though my body doesn't have left and right parts equal, the arms are still at an equal distance from the spine, so my shoulder bone is safe and I can duplicate it to the other side easily. Let's grab the end bone, then reposition it slightly lower, like so. Get rid of the end bone, since we don't require it. Before you exit bone edit mode, make sure to reset the stretch and the scale of the shoulder bone. Exit bone edit mode. Notice how we created this bone in the top view. This was done to favor the rotation around the Z-axis. The forward rotation as the character humps his back, and the backward rotation, the counterclockwise rotation, as the character arches his chest. You will be able, of course, to lift this bone upwards and downwards, but that's not the primary rotation. Remember that those 2 are the ones we care about. We will also have to create arms in the top view to favor this rotation. 1 for the upper arm, 1 for the forearm, and also wrist. Later on we will add palm to it. Wrist will be in the form of an end bone, that's why I drew it with a slanted line like this. We will have 3 joints in here. 1 right there, another one here, and a third one over here. For the arms we will be using IK solvers, so make sure you create them with caution. If you want to, you can save your work at this stage before proceeding to work with the arms. Save it as a character name, skeleton 2. Using create bones, click nearby of your shoulder end area, but make sure it doesn't snap to it, and click at the end of your wrist. Then right click. In the bone edit mode, reposition your arm so that it's closer to the end of the shoulder bone. Let's increase its width and height. Then delete the ending and recreate it. Go into refine. Then click somewhere in the area of your elbow and refine the bone. As I told you before, since we're using IK solvers, we need to create a little angle in here. This is why let's select the main parent of the arm, rotate it slightly, then rotate its child. Reposition your wrist bone in the bone edit mode, somewhere where the wrist joint occurs. Delete the ending and recreate it once again. Before you do anything, select the bones, reset the stretch and reset its scale. Go into properties and change the color to bright green. Rename your arms mutant left arm bone. The next one should be called mutant left forearm bone. The wrist should be called mutant left wrist bone, although it's an ending. Go into the front view and notice that your arm has been created at the bottom of the grid. Go into perspective mode and align it with the end bone of the shoulder.
From the front mode, center on it, and rotate the bone so that it sits inside of the arm. Just like the case with legs, you don't want to break this relation in here. You want this line to be straight. That's exactly why we refined the bone at the first place. From the front view, you can only allow yourself to adjust the length of the bone with the local representation of gizmos along the x-axis. Also, do not touch the wrist in the up and down axis because this will once again break the linkage. Similar to the situation when you work in bone edit mode and decide to align it to the end of the shoulder bone. This problem happens once again. You can only align while not in bone edit mode. This will snap the whole chain, but this is okay. Remember, you can only allow yourself rotations. Check it once again from the top view to ensure that it's located correctly, and also from perspective view. If you spot something to be improved, you can always go ahead in bone edit mode, in local representation of axis, extend, for example, the wrist further. Go into the top view and create a new bone. This will be a bone for our palm. Right click to finish it with the end bone. Reposition it to the right place, and perhaps increase its dimension to make it more flat. Reduce the tapper as well. Go into perspective mode and notice that it has been created on the floor. Grab your hand, exit bone edit mode, and align it to the wrist. Pivot to pivot in all three positions. Press OK. Go into top view once again, and adjust rotation. Its color should be green. And then create 3 bones for your thumb. Zoom in closer if you need to. Reduce the size of the bones if you need to, if they don't fit in the fingers. And the thumb bone was created from the top view to favor this rotation. Enter bone edit mode, and from the top using local y-x plane, readjust the rear end of the main parent from the thumb chain. Do the same for other 2 phalanges. Adjust the end bone, then get rid of it. Change the color. Call the bones as mutant thumb 1 bone. For the other 2 phalanges, simply change the number. Take a little break and try to tell me from which view we should create other 4 fingers. Is it top, side, or front? And explain why. The answer is you should create 4 other fingers from the front view. This is because the main rotation is grabbing. It is going to be occurring as the fingers curl inwards around this axis that is looking towards us currently. If we would be creating this from the top view, we would be then favoring this rotation when you extend the fingers. However, from perspective view, notice that your thumb bone was of course created on the grid. That's why exit bone edit mode, grab the main parent of the thumb bone and bring it upwards towards the hand. Zoom in on it, rotate it so that it fits inside of the finger. Check from the top as well, and ensure that the joints are positioned correctly. And in local y-x plane, readjust the links. Once again, do not touch Z because this will break the linkage. All you can afford in this case is rotating the main parent of the chain. As you guessed earlier, let's go into the front view and create other 4 fingers. Using the button Create Bones, start the 4th chain with 3 phalanges. If you have a humanoid character who has longer fingers and more phalanges, increase the number of phalanges accordingly, of course. From the top view, readjust the position of your first chain to go into the middle finger. In this case, watch out and don't break this linkage. However, it only really matters if you are doing IK chains. For the fingers, we won't be doing IK chains in this case, and it wouldn't matter so much if you did break it. However, it's a good practice not to do this. I stress this, make sure that you work in local. If there aren't enough of topology loops on the fingers, don't worry because we will enter the geometry later and adjust the number of loops to be greater or smaller if we need to around those joints. You cannot really see anything from the front view, that's why we will be doing this from perspective. If you want to, you can turn off the wireframe mode, unfreeze the geometry, and press Alt-X, or simply right-click, go into Object Properties, and set visibility to 0.3. Now you can freeze the geometry once again. Ensure that you place your bones in a correct position. The fingers should initiate from knuckles, and so you should place them towards the hand inwards. If you want to, you can even rotate the hand palm, tilt it slightly, so that it's fitting into the mesh correctly. You can do the same thing for the fingers, but watch out, don't overdo it. Always rotate from the local once again. Rename your finger bones following the convention of thumb, mutant, left, middle, F1, bone. Push this name forward through all of its children and just change the numbers. Delete the ending because we won't need it, since we are not doing any kind of IK solving for the fingers. Now you can simply press Shift and duplicate your finger, press OK, then readjust it. After this, simply change your color, like a chameleon, then rename all of the bones. This is thumb, that finger is called index, this is middle, ring, and pinky. In my case, I simply was selecting fingers and was adjusting this part in here. However, notice because I was shift dragging, now each copied bone, except for the middle one, has 002 or 001 ending. Let's get rid of it by selecting all of our chains that we need to rename. There are 3 of them. Go into Tools, Rename Objects, unclick base name and remove last 3 digits. Click Rename once. Now check your bones. Notice how the suffix is gone. When you think your bones are ready, select your chains, reset the stretch on all of them, along with the scale. Do the same thing for the thumb. If you lost your Bone Tools window, you can access it by going into Animation, Bone Tools. So, reset the stretch and the scale for the thumb. From Perspective mode, create a simple box to stand for your chest bone. Don't make it too big. Making this into editable poly, I'll select the front polygon and will create a little pointer by doing Inset, then Extruding. Go into Hierarchy View, Effect Pivot Only, then Center to Object. From the front, center an object by pressing Z, then in the local representation of your axis, drag it down to the side. Go into the side view by pressing L, then align your pivot point with this line, where the pointer begins. Exit Effect Pivot Only, go into Perspective View, and check where your pivot point is sitting. There is no point for our box to be so thick, so let's go into Polygon mode once again, and in the local representation of axis, make it more thin. It's also way too wide. Let's select the vertices, and in the world representation, drag them down to the left. Select those 2 vertices and bring them upwards like so. Select those 2, bring them down as well. Change the color of the box to green, and rename it to Mutant, Left, Chest Bone. From the local representation and using pivot point center, go ahead and mirror your object in the x-axis in my case. Rename this one to Mutant Right, Chest Bone, and remove the addition ending. Check that its axes in the local representation are looking in the different directions. Let's temporarily link our right chest bone to the left one, grab our left bone, then align it to the rear end of the shoulder bone in position, but not in orientation. Pivot to pivot, press OK. Let's then drag it outside so that it's nearly on the surface of the body, if not sticking out. Bring it down slightly. Go into Create, Helpers, and create a point helper. Change its representation to box and the color to the bright yellow one. If you don't have this color, go ahead and add a custom color of a brightest yellow. Rename this one to Mutant Chest Control. Align this one to the rear end of your shoulder bone, only in position. Now select your 2 chest bones and link them to this helper. Select your chest helper and then link it to the spine bone that's below it. As you rotate your spine bone, the chest will be moving with it. Notice that we didn't do any kind of linkage between the arms yet. If we double click on the shoulder, it will select only itself because there are no further children belonging to this bone. The same thing happens for the arm. It only goes up to the wrist. We didn't link the palm to the wrist, nor did we link each finger chain to the palm. In our case, we want to duplicate each of those chains to the left before we link them. To do this, go into Animation Bone Tools, then grab your shoulder bone and do Mirror Bones. In the x-axis will be fine. Press OK. Check from the top view. As you can see, their pivots are aligned perfectly. And because the first one's pivot is located at the rear end of this spine, its follower, that is mirrored now, is also aligned with this spine, so we don't need to reposition it. Go to the front view once again, double click on the first main parent of the arm chain, select everything up to the wrist, and do Mirror. Notice how their pivot points are aligned once again, It's 19 in the X direction for the main parent of the old arm, and it's also 19 in X for the main parent of the new chain. Because our character is of course centered, and we are measuring from the spine that is centered in the world, we can simply reverse X. Now do the same thing for the palm, and double click on each of the chain, mirror it, select its main parent, reverse the direction. You can do so from perspective view if that's easier for you. We can only do this because we got our symmetrical arms being equal once again. As for this end bone of the palm, we don't need it anymore because we only used it to readjust the position and the direction of the palm. So get rid of it. Then you need to rename your chains, and all you need to do for this part, for each of the bones, for example, in the chain for the right arm, is you need to change left to right, and then get rid of the mirrored ending. Because the lengths of the names are different for all the chains on the right arm, simply focus on this one for now. As always, from the Tools menu, click Rename Objects. Remove last 10 digits because that's going to get rid of the mirrored ending. Enable the prefix. Double click on the main parent for the right arm, then click Rename once. Now check the bones that they are renamed correctly. The wrist was renamed as well, but now we need to fix the palm and each of those fingers. In fact, I forgot to name the palm on the left arm as well, so I'm going to rename it here and then duplicate the name to the left palm. Mutant right palm bone. And it also should be the same in here, but it should be left palm. Taking into account that each of your chain begins with mutant left and then ends with mirrored, you can select all the chains at once, including the thumb, if it's following the right convention as well of naming. Then remove last 10 digits and remove first 13 digits and instead put mutant right underscore. Rename and check each of the fingers. In my case, I need to revisit thumb because I didn't name it correctly at the first place. Let's add underscore bone. Rename once. I will also check the naming for this thumb as well. Here the bone ending is fine, but I don't have mutant right or left, so I'll change it. As you can see now everything is good, even the palm was renamed. Check that each of the bone is aligned correctly in the arm, and if it isn't, readjust it. Or what would be better, readjust the mesh if you can. As you can see, the fingers are originating from the knuckles, and their main rotation is occurring as a grabbing. For the thumb, it's extending thumb outwards and inwards. Sometimes artists also create plates for the shoulder blades and position them behind right there, but we won't be doing this here. I also want to change the size of our head bone, but right now it's the end. From the left view, enter Create Bones and create a little chain next to your neck. Rename this bone to mutant head underscore bone. And actually this one should be renamed from spine 5 to neck. Mutant neck bone. Grab a hold of your head bone, go into Align, then align it to the end of the neck bone. Press OK, enter your bone edit mode, and readjust the position of the end for the head. It should be sticking somewhere on the back of its head. Exit bone edit mode, and get rid of 2 children. Those are the end bones, both from the neck and the head bones. Finally change its size to be the biggest one amongst the skeleton. Make it 6. We are almost done now. Before we do anything, let's select our bone chains that aren't linked to anything. That is our head, our arms and fingers. Then reset their stretch, as well as the scale. Ensure that they aren't deformed in any way. Then link the main parent for the left arm to the shoulder bone. Make sure you don't link it to something else. And of course your mesh should be frozen at this stage. Do the same thing for the right arm. Then link the shoulder bones to the spine one that is sitting below their rear ends. Link the head. Link the palms to the wrist bone. And each of the fingers should be linked to the palm. That is their main parents. Keep in mind that you also need to do the other arm. Tying the mesh to the bones requires one more process to be done. If you grab both of the thighs and test them for rotation from local and pivot point center, when you rotate the wheel, you will see that the legs are going in the same direction. However, this is not the case for all of the axes. For example, around the Z-axis, you see that they are going in different directions. Same thing happens for X. In order to fix this odd rotation, Select one of the chains with effect pivot point only from the local representation of the transform, pivot point center, grab your chain and rotate it 180 degrees around the x-axis. If you select your thighs now and try to rotate them, you will see that the legs are moving correctly in all three axes. Do the same procedure for the arms. You have to worry about the shoulder, the arm, forearm, and the wrist. Double-click on the whole chain, starting from the shoulder, deselect the palm and the fingers, effect pivot point, local, then rotate 180 degrees around the y-axis. We need to animate each of the bone in this skeleton through all of its possible ranges of motion. For that, let's have a look at the left leg first. Since we need to animate it, let's press N and enter Auto key. 5 frames later, let's move this part upwards, as if the character is tapping his toe, and then shift, left click and drag this key from frame 0 to frame 10, so that the foot bone returns back. At frame 15, bring it down. And you want to really push it to extremes, all of those bones. We really want to ensure that on the joints, when the mesh deforms really hard, the model will still look good. Of course, this bone wouldn't be bending that much, that would be an overkill, but really try to extend it even further. Grab a key from frame 10, at this instance, return your foot back. Because we covered all of the ranges of motion for this foot, let's move up a level to its parent. At frame 20, let's right click at the time slider and set a key for position, rotation and scale. Move 5 frames forward and bring your ankle to the left. From frame 20, copy the key and bring it to frame 30 so that it returns back nicely. On 35, let's rotate it to the right, outwards, then return back. Then upwards and downwards. So at frame 45, let's bring it up to a really extreme rotation. At frame 50, return it. And at 55, let's bring it down. Then return back once again. Move up a level and plant a key at key 60, because that's the one where all of the ranges have finished for our ankle bone. Plant a key there for all 3 parameters of transform. Move 5 frames to the right and perform bending up to a really high degree in the knee area. Grab a key from frame 60 and bring it to frame 70. Actually, I want to extend this angle to be straight. That's why at frame 70, let's actually make the leg really straight, like so. Consider this as an extreme, because you don't want to bring it here, since this wouldn't ever occur unless somebody breaks the legs of your monster in your game, if you're that cruel. This angle is fine. At frame 75, grab a key from frame 60 and bring it here, so that the leg returns back to its original position. Move up a level. Soon, I'm going to run out of frames on my timeline. That's why I'll press Ctrl Alt, right click and drag it to the left. If I want to scrub through the time, I can press Ctrl Alt and middle mouse click, then drag left and right and actually pan across all of the possible time ranges. You can even go to the negative time if you want to. At frame 75, I'll plant a key. Then at frame 80, this thigh bone can be lifted up to an extreme degree. And things will happen so quickly, each frame, that it might be hard for us to trace down. So let's extend the frames to the right. For the thigh bone, remember that you also have to extend it outwards from the body like so. After this, make sure you return it back. If our legs would be symmetrical in terms of mesh, then we would only need to animate one side of the bones. But in here, we really have to go and animate this side of the leg as well. Obviously do not animate the pelvis, because this is just going to grab all of your body and twist it around. However, animate the spines. Each spine will move in all 3 axes. Make sure you animate this range properly. It moves left and right, backwards and forwards, and it also turns around. For the spines, you want to rotate them locally. There are 4 more bones in our body structure to worry about. Those are the 2 shoulders, because my character is not symmetrical in the torso area, and the 2 bones for the chest. The shoulder one rotates up and down, forward and backwards. The chest bones should only rotate inwards, and you should animate them on the same time scale. That's a somewhat very strong curl, but it's good enough. As they rotate inwards, they should move towards the center. And as they move outwards, you guessed it, they should move out slightly, by a smaller amount than when inwards. We now have got a full range of animation. Let's have a look at it. But first, go into the time setup and do the speed to be quarter. Maybe set it up to be higher, so let's say 1/2. The way skinning works is it takes several objects. The mesh, which will be skinned, and then pieces of geometry such as bones or custom shapes, for example like boxes. As you know, mesh is made up of vertices, and what really happens behind the scenes is each of those vertices gets linked to a specific bone, or a set of bones. From that it follows that different bones will have different influences on each specific vertex. However, because there are no muscles and the joints are simply points in space without any kind of volume, there is a potential for interesting anomalies that could occur. Really, there are 2 modifiers with which people are used to work. The most famous one is skin, because it's so simple. That's the one we'll be using. And there is also one called physique, which is a slightly more complex, but essentially is the same thing as skin. Before we proceed further on, we need to add so-called roll bones. Those are the geometric pieces, such as boxes for example, which will be helping our mesh to deform properly on the joints areas. We will need a roll bone in this area, and then 2 roll bones over here. In reality, your forearms rotate, not only in a forward-backwards direction. However, our skeleton only allows this rotation. The rotation around the forearm will instead be done via the wrist. The main arm, along with the forearm, can only afford to rotate forwards and backwards. But our wrist, and the palm with it as well, can rotate around the forearm, forwards and backwards, with ease. That is, in all 3 axes. This joint can afford rotation in all 3 axes. This one only in the vertical one. That one, again 3. The same thing happens for the rear end of the shoulder. That's why the roll bones that are located in here will be responsible for controlling the mesh deformation properly, so that it seems that it's not the wrist that's rotating, but the forearm who is initiating the rotation from this area. For now you want to go to cylinder, reduce its height segments down to 1, and also size should be small as well, such as 5 for example. If we select it, you see that the pivot point is located at its bottom end, that is the rear end. It's positioned precisely in the center of its bottom part. In the local representation of the transform gizmos, its z-axis is looking upwards, and for the arm, the z-axis is looking downwards, the x-axis is looking to the left. We need to align this roll bone to our arm, in position and orientation, pivot to pivot. If we check our 2 objects now, the arm and the roll bone, from the local representation of the gizmos, you can see that their pivot points are pointing in the same direction. But I want my object to be facing this way, along with my arm bone. But if I do this, if we go to move, you can see that the axes are no longer aligned. That's why instead of rotating, I will convert this object to an editable poly. Press 5, and from element mode, I will go into rotation, select parent, and using the transform coordinate center, that is the last option, all I need to do is to apply a 90 degrees rotation around the y-axis like this, with the angle snap turned on. As you can see, when I rotate it around the x-axis, the bone behaves correctly. This wouldn't be the case if you tried to apply this 90 degrees rotation via the element mode and writing R90 into here. Because as soon as you exit your element mode, the object will be distorted, so you should only use angle snap in such cases. Let's select our roll bone, press W. While holding shift, let's duplicate this bone by sliding it in the local axis in the x direction, make a copy and rename it to mutant left wrist roll bone. This one should be called roll bone 2, so place number 2 at the end of the name. Click align and repeat the procedure just like you did before. Position and orientation. The roll bone is now facing in the same direction as the arm, and their axes are aligned. For this part it should be shorter, so let's go into the element mode Using the parent and the transform coordinate center, let's scale it in the x direction. Because we were rescaling it inside of the element, there is no need to do the reset x form, since we were working on the sub-object level. In the local representation, let's slide it along the forearm, along the x-axis, press shift and duplicate it once again. This one should be called mutant left wrist roll bone 1. Maybe their sizes are too big, so let's go into the element mode from the parent, and using the transform coordinate center option, let's rescale it in all 3 directions. Repeat the procedure for other 2 bones. A nice trick is that if you try to mirror some kind of geometry in the local representation of axes, that's just going to flip it, having their pivot points aligned. But of course their axis will be mirrored as well. But if you do it from the world, for example, and using the transform coordinate center, then your mirror is going to be positioned and regarded from this position. For example, if I select my roll bone using the world and transform coordinate center, try to mirror it, it's going to be positioned exactly at the place where I want it to be. I can do copy and repeat the procedure for all other 2 bones. World, transform coordinate center, and do mirror. In the x direction, of course. Do not forget that you need to rename those roll bones. Like explained before, you can go into Tools, Rename Objects, or do it manually, because there aren't so many of them. Of course, this is the left side, and that's the right one. This bone is called mutant left shoulder roll bone. That one, mutant left wrist roll bone 2. And this one, mutant left wrist roll bone 1. Since this is the left side, rename the mirrored objects to have their name beginning with mutant right, and also remove the mirrored ending. Just in case, select your roll bones, reset X form on all 6 objects. You can then right click and convert them to editable poly. After this was done, let's link each roll bone to their respective carrying bone. That is, the left shoulder roll bone should be linked to the left arm bone, and those 2 can be linked to the forearm bone. Repeat the same procedure for the right side. This one should be linked here. Those 2 should be linked to their forearm bone. Skinning implies that the mesh is going to be deformed, and of course there are some places where this geometry will be deformed especially. In such case, to those areas we need to provide more loops, so that the bending of the geometry can occur properly. As I go out from the shading mode, I want to apply a simple gray material to my creature. Obviously those critical areas are going to be on the joints. Following the idea expressed in the beginning of this tutorial, one of such joints, from the ones that I mentioned, is going to be the elbow, and also several of the joints on the fingers. You must ensure that you have enough of loops on the knee area, and also around the shoulder. But be very careful, because you don't want to mess up loops and change directions of them in this place, since this joint is very difficult to skin. You must have enough of loops in this place, on the ankle area as well, the elbows, the wrists, fingers, and other parts that are going to be bending. Let's select our mesh and center on it. Make sure it's in editable poly. Then in window crossing, unenclosed selection mode, let's select my favorite regime, drag through those edges, and select a nice ring. We can also press Ctrl and drag through those edges lying nearby to the ones on the left. Let's press connect. If you establish shortcuts from the previous tutorial, that's going to be a piece of cake for you, just one click of a button. That way, get yourself a nice ring, or a nice loop. Since our critical area is right there, and we got at least one loop here, and another loop on the other side, it's already safe. Plus, if something, we have even extra loops nearby, so this joint is totally fine. For my wrist, I have a feeling that the critical area is going to be right there, and if I unhide my skeleton, press F3 and go into the wireframe mode, the joint is occurring in this place. Clearly, we are lacking a loop in this area. We have 2 neighbors, but the main critical loop is not placed. Let's select the mesh, go into the edge mode. With my kinky selection, let's select the ring, or simply click on one edge, then shift click on the following edge, its neighbor, to select a whole ring. Use connect. Similarly, repeat the procedure for the fingers. Keep in mind that all of this is bumping polygons, so while adding those loops, if you've already unwrapped your character, make sure that you've collapsed all the stacks, and while adding the loops, you can actually remove some of the unnecessary loops somewhere else. Make sure that all of that removing and connecting will not create any kind of triangular pieces, otherwise this will have a bad effect on your geometry. Following our strategy, we understand that we need to skin this mesh to our bones. To do this, let's unfreeze the whole mesh, select our body and apply a skin modifier to it.
because skin is what we're going to be using. With this modifier, we are allowed to alter the mesh parameters via edit envelopes, but before that we need to add bones for it to understand with which structure to work with. For that, let's go into Bones, Add, deselect our geometry group, and select Bones from here. Also, let's go into Display, Expand All. Then click on the first bone, and then down there, hold Shift and left click on the last bone to select the whole range of bones. You don't want to select the endings, that's why let's go up and Control left click on anything that we want to deselect from our selection. That is, all of the end bones. You also don't want to select the wrist bones, so deselect them as well. Press Select to add all of those bones to your list. If we expand this rollout to be double, now we don't have to worry about scrolling huge amount downwards to see this area. You can grab one of the bones and test your mesh now to see how it deforms. And it's pretty good on this leg. However, for example, if we select this thigh bone and try to move it, you will see that the mesh requires further adjustments because it's not following the bone completely. To fix this, we need to go through the process called skinning. We can click on Edit Envelopes and then adjust all the vertices that we want to be affecting around all particular bones. You don't require cross sections, so turn them off. And also, if you go to Display Parameters, click Show No Envelopes so that you don't see the gizmos. And now if you click Vertices, you can go ahead and start selecting the bones that you want to work with. Those are displayed with the black lines that turn yellow if you click on them. With this modifier, each vertex of the mesh has a weight property towards each of the bones. If the weight or an absolute value of a selected vertex towards a selected bone is 1, that means that any change that will occur to the bone will have the biggest possible influence on the vertex. It's just going to follow it like a pet, as if it was kind of glued to a bone. Let's start from the mutant's right foot. As you could have guessed, this bone right here will be carrying all the vertices around it. To be specific, those ones. The bone that is here will be carrying those vertices. In here, the absolute effect of the green bone to the green vertices will be exactly 1. However, an interesting stuff happens on the joints, right there, since you need to weigh those vertices between two bones. That is, the purple vertices will have 0.5 value towards the green bone and a 0.5 value towards the red bone. Before we do that, let's first make ourselves familiar with this bone. If we select any of those vertices that are highlighted with red, we will see that their absolute effect is exactly 1. You can also go into the shaded mode by pressing F3, and notice that all of the polygons that are affected by this bone are highlighted with red. Let's move up a level. As you can see, there are some of the vertices that are highlighted with red. However, I have a feeling that those vertices must belong to this bone. And so with our curve selection from over here, let's select the range of vertices that we think should be affected by a factor of 1. With our bone selected, we can go ahead and add an absolute effect of 1. Now all of those vertices have an absolute effect of 1 towards this bone. Let's move up a level. All the vertices in this area should be affected by a factor of 1, that is, have an absolute value of 1 towards this bone. And of course, if they have an absolute value of 1, for example, on here, that means that towards any other bone, they have an absolute value of 0. If we move down a level, remember that we've created ourselves a little helper animation, so that we can scrub through it and notice how the body moves. Let's scroll towards the part where we moved the right leg. As you can see, when the toe is lifted, some of the geometry is actually pushed inwards, like right here, for example. This side is pushed inwards into the green geometry. And in fact, those are the purple vertices that we've been talking about before. Let's go into the object's properties, because we're currently working on the mesh, that is, we have it selected. Object properties, and increase the visibility to 1. If we select this bone, you can see that everything here is red, but then straight away it's a very abrupt change. So if we switch to this place, this bone will have its own part completely red, and there are no transitional parts between those two joints. To do this, let's select this loop of vertices. And then move back to its child bone. As you can see, the selected vertices have 0 absolute effect towards this bone, and when this bone moves, you can see that the red parts are clashing into those vertices, since the selected points are not affected by any means. To fix this, we already have them selected. Let's go to the part of animation where it's more explicitly explained, such as here, for example.
With the child bone selected and the new vertices picked up as well, let's increase their absolute effect or the weighting by a small amount towards this bone. If we move up a level, like so, towards the parent bone, we can select the vertices to the right of it. That is a loop that is to the right from the currently selected one. If we select two of the vertices, we can go up and click loop. This will loop through the whole geometry, like so, if you have nice quads. Then with our parent bone selected, we can now increase those new vertices absolute value to some higher amount, like so, for example. And also, perhaps, returning back to the child bone, we want to give it a slight influence on those four vertices, like so, for example, and also maybe this one. Now, as the foot is tapped, the problem is gone. However, I don't think that this bone, the first one, the child one, should have any effect on the bottom polygons and the vertices that control them. That's why I'm going to select the vertices at the bottom, go back to the parent bone, and assign an absolute value of 1, like so. They also behave correctly as the bone moves down. However, now I notice that this vertex should be pulled down by the child bone as well. That's why I will ensure that I have my child bone selected, and with my vertex picked up as well, I'm going to increase this point's weight towards this bone by a small amount. Also keep in mind that you want to avoid this kind of squashiness of geometry in here. This is really bad, and a better alternative to have is to allow it to crush inside. It's better than having this squash. Taking a look at the weighting of those vertices, I think that the red influence part should be greater for this bone. And so in here I'm going to make those vertices 1. Now you see the geometry crushing into each other, but we have avoided this squash anomaly. Also, taking a second look at this, I don't think that this bone should be affecting this vertex. That's why I'm going to go to the bone where it should belong, then set the absolute effect to 1. Check the leg in the ankle area as well. You can notice that you have a more severe problem in here. The shin bone should have some effect on the ankle area, and so should the ankle bone as well. Let's select the control for our shin bone, go to a more neutral place in animation. Then, like explained before, select a loop of vertices by selecting 2 to set the direction, then clicking loop. If we go to a place where we have this severe problem, such as this for example, we can now add an absolute effect to be greater towards the shin bone for those vertices, such as for example 0.5. Also select those two vertices and set a loop, then add a small absolute effect to those as well. Once again, you want to avoid the squash effect that might occur here. After all, it's better to have the crushing geometry. However, try to minimize this effect as much as you can. As the ankle moves upwards, I think that the ankle bone should be granted some of the control towards those vertices. So I will go to the ankle bone, select those vertices, and increase their absolute effect slightly. As said before, I want to avoid the squash effect in this area, and it will happen if I'll assign an absolute effect to be greater, like this for example is already squashy. The next part is the thigh bone. If we select it, you can see that it has some of the grasp on those vertices, and we don't want this. That's why with our thigh bone selected, we're going to select those vertices and decrease their absolute effect to 0. Or what's better, select a bone to which they should belong to, such as this one for example, and for those vertices increase the absolute effect by 1 towards the correct bone. If we return back to our old thigh bone, you will see that now it doesn't have any influence on those vertices. However, right here, it should have some of the control over those points. So let's select them with our back face cull vertices turned off, otherwise it's not going to select anything on the back. For this thigh bone, increase the absolute effect by 1 for those vertices. As you might guess, you will have problems in this area, since this loop belongs to the knee area completely, and we should steal some of the power from the shin bone of those vertices and grant some of this power to this thigh bone. Let's do this now. Using F3, we can actually select the whole loop of vertices that we want to control, including the end of the bones that are cleverly hidden inside of the mesh, and increase the absolute effect for the thigh bone to a greater amount. If we try to bend our bone now by moving an animation and finding the right time where a change occurs, you can see that actually this was a wrong decision. So let's set an absolute effect value to be 0 for the thigh bone. This is going to return it back to the original state of absolute effect for 1 towards the shin bone. If we roll back our animation slightly, you can see that we can select this loop of vertices that is above it, and for the shin bone, set it to be affecting those vertices. That's a quite tricky area to skin, and you will most likely have a crushing geometry in this part. That's okay. Over here, notice that the thigh bone should have some control on this vertex. Select your thigh bone and this vertex, and increase the absolute effect of the thigh bone towards this point. Go around your geometry and fix any problems. So for example, for a thigh bone, I'm going to select a lower region of vertices and make them listen to the thigh bone's changes slightly more. Those vertices should be listening to the shin bone. And I'll select other vertices and give some power to the shin bone over them as well. Let's switch to our thigh bone and increase the grasp over this vertex for the thigh bone. Also in here as well. Notice the general flow of shading. It's going from red to orange, then yellow, then blue for subtle changes, and then gray. As you can see, the problem is revealing itself over here. As the thigh bone tries to pull those vertices on the end of the bone towards itself, you can see that the bone opens itself, whereas it should stay inside of the geometry. I'm going to go back to the shin bone, where those vertices belong, and actually set an absolute effect of 1 for those endings on the bone. That way, thigh bone won't have any kind of effect on the vertices on the end of the bone right there, inside of the mesh. When the character moves his leg to the side, you can see that geometry starts to crush in this area. So the vertices over there should be weighed between this bone and the thigh bone. As well as that, the vertices that are marked with green should be pulled by this bone as well. And currently they are all pulled by the blue bone, that is our thigh bone. Let's select those vertices, select our pelvis bone, and assign an absolute effect for those vertices towards this bone to be greater. Let's select those vertices with our back face skull vertices turned off, and actually set an absolute effect to be greater for the pelvis bone over those vertices. And perhaps those ones as well. For our thigh bone, let's give it some influence over those vertices, of which it has no control currently. And also maybe this vertex right there. Check the area in the bum as well. Clearly those vertices should be belonging to pelvis as well as to the thigh bone, but currently they are all held by the thigh bone. Select them, switch to our pelvis bone. Check that it works correctly as the character moves his leg backwards as well. Right here you can see some of the crush occurring. From that we can deduce that we need to give some of the power to the thigh bone over those vertices. Do not worry about the middle line because it has to be weighed between the pelvis and the two thigh bones. First finish your legs, both of them. Then we will think about this middle line in the center and how we're gonna weigh it. Some of the crushing occurs in this area, but that's fine because as soon as I increase the influence for the thigh bone over the vertices that are on top of here, a squash effect will start to occur. Also, if your character would be totally symmetrical, you can actually go to the mirror mode. Then notice that the red part has green lines going through it, and the left side has blue lines going through it. If you enter mirror mode, you can actually paste from green to blue, or paste from blue to green, that is this direction. So if you've done some of the weighting on those vertices, or the whole leg, you can enter the mirror mode if your model is symmetrical, and then paste from green to blue. That's going to copy all the settings for those vertices to the vertices that are exactly to the right from them. Watch out so that you don't do it the other way. Since you might ask it to do the blue over the green one, this will paste over the new settings from the vertices that you haven't been working on to the ones that you've been improving. So watch out for that. Don't forget to exit the mirror mode when you're done. But this only works if your model is symmetrical. I want to mention this once again. When skinning and adjusting the rival forces between several of the bones for a particular vertex, let's say this one for example, imagine that we want to give all of the power towards this vertex for the left thigh bone. One way, which is a correct approach to do this, is to switch to this thigh bone and from it assign an absolute effect of 1. A wrong approach would be to select the other two bones and to set the absolute effect to be 0. So do this for pelvis and then switch for the right thigh bone. We already know that this vertex can only be affected by the pelvis bone and the left thigh bone. That is, if we want to make it 0 towards the pelvis bone, it has to stick to the thigh bone. Otherwise it's going to be left behind, and when reducing down to 0 in the pelvis bone, there is always a potential that this vertex might be left behind. So instead of lowering down the absolute effect to 0, switch to another bone which will grab this vertex from an old parent bone. As told earlier, we are going to work on the middle line. The vertices in the crotch area should be weighed between 3 bones, that is pelvis and 2 thigh bones. From the front view, let's center on them and select the middle section of vertices. Also, we're selecting them from behind, so make sure your back face skull vertices is deselected. While on the pelvis bone, let's assign a value of 1 to the pelvis bone for those vertices. If, for example, those points had some kind of tension towards the thigh bones, now the pelvis bone claimed all of the power to itself, and those points are only listening to the pelvis bone. If we select the right thigh bone, indeed you can see that they are highlighted with gray. As well as the absolute effect spinner, there is also a weight table. Let's click on the weight tool, and this will bring up the weight tool table. Right here you can see which bones are affecting those vertices. To add another bone, with our thigh selected, let's add a 0.5 influence to those selected vertices for our thigh bone. As you can see, the pelvis had to give half of its power to the thigh bone. Now if we select the left thigh bone, enter 0.333, click set weight, you will see that power is now shared equally between those 3 bones. If anything, you can always adjust the position and the relation of those vertices between the bones later on, but now you got the basis to work with. Of course, check the geometry's deformations as the animation progresses. With all of those adjustments, you want to ensure that all of those kinks in the loops are smoothed out. For example, this vertex should be brought over here. That way the loop will be straight, or more circular. A common sense way to do this is to select the pelvis and add more force towards this vertex for the pelvis. Here is another loop, and there's a second loop like this. We need to take this black vertex and make it be affected by the thigh bone by a greater amount. This vertex should be controlled more by pelvis. As you can see, the loop now is more circular. Right here you can see that the thigh bone, as it gets lifted upwards, is pulling all of those vertices downwards, creating this kind of kink right there. If we select our vertex, then select our thigh bone and start adding force over this vertex for the thigh bone, this will smooth out the curve. However, that's not really the right way to do it. Our thigh bone is already allowed too much. Its area of influence is just fine. If we push it out further, that's going to create strange deformations and squash effects in different positions. The correct way to do this is to instead use this point and lift it upwards using pelvis. This additional power, of course, will be drawn from both of the thighs. They will still have some of the power remaining, but most of it will be assigned to pelvis. That way, we've decided that we are not bringing this point down, but raising this one upwards. If we try to increase its absolute value towards the left thigh bone, nothing will happen because the left thigh bone is currently stationary, and so is vertex. It will not do any kind of great movement up or down. The same thing will happen to pelvis. The point will stay unchanged. But if we try to assign an absolute value to be greater for the right thigh bone, because right thigh bone is currently animated, it will have a greater pull, a greater effect on this loop. But that's not the way to do this. So grab this point, and with our pelvis selected, let's increase its absolute effect up to this amount. As promised earlier, now it's a smooth curve. Its so-called breaking point of smoothness is happening at this area, and not here. The spine bones are amongst the easiest ones to skin. Mostly it's due to the fact that they only have two neighbors at most, that is the spine above it and below. To set control over the first points for our first spine, let's select it, then from the front view, select the region of vertices that should belong to this spine, as well as everything above, including the arms and the shoulders area. To those points, for this spine, assign an absolute effect of 1. Go into perspective mode and focus on the intermediate areas, that is, the places of joints. This loop should catch your attention straight away. Let's select it, and we cannot, because the topology isn't clean enough for the computer. It doesn't know which path to pick, which loop we want to actually have selected. Is it this one that's going upwards, or the one that's going around? This is why we will have to do this manually. Switch to the pelvis bone. After that, judging by the situation happening in the animation, adjust your loop and the power of those vertices towards the pelvis. Move up a level. Of course, it's clear to us that everything that's gray above is belonging to the spine that we want to skin currently. And so by increasing the absolute effect over those vertices on the gray area for the pelvis means that we are stealing the power from the spine bone which is above it. We've been increasing the grasp for our pelvis bone over the spine. Let's return back to the spine bone and increase the grasp over the pelvis area. We really want to achieve a great and smooth transition, as well as avoid the squash effect in the areas of bending. This skin looks good. Let's move up a level, then work on a new spine. We didn't approach the shoulders area yet. That's going to be later on. That's why I repeat the procedure as for the previous spine. From the front view, select an area that should belong to this spine, as well as all of the arms. For this new spine, assign an absolute effect of 1. On the intermediate areas, remove any kind of problems, judging by the animation that you've prepared earlier. The spikes on the back of the character should be following this new spine. However, if I move the animation time slider, you will see that their endings are staying behind. To avoid this, let's select everything, including the horns or the spikes, then assign an absolute effect of 1 for this new spine bone. As we approach the neck area and start working on the third spine, we are getting closer to the shoulders area. For now, there is no problem. Let's go into the front view, then select all of the vertices that should belong to this spine, just like before. Assign an absolute effect of 1. Work on adjusting this area. You don't have to worry about the shoulders, and certainly not about the neck or the arms yet. Also keep in mind that this chest area is going to be controlled by 2 extra bones, which we will be adding later. However, for now, skin as if they aren't there. In my case, I want to keep in mind that the horns are pretty rigid. That's why they either belong to this spine or to that one. Points on them are not going to be shared between the 2 bones. That's because I want to avoid stretching out of my horns. As you can see, some of the points are left behind and don't belong to any bone. Let's select them. With this new spine, kick up an absolute effect to be 1 for those horns. Now they're following the spine correctly. With all of those wounds, it's pretty hard to tell where the kinks are occurring. Actually, this is quite a good thing. Notice how those 2 horns are staying behind, belonging to the previous spine, and don't move as the upper spine rotates. Of course, an animator will have to watch out for the clashing between those 4 horns when they're getting into each other, but apart from that, it seems good. Once again, notice the shading. Let's focus on the neck area and shoulders at the very last stage. For now, let's rig biceps and the forearm. For the arm bone, select everything that it's carrying and a bit of shoulders. As always, assign an absolute effect of 1 to that area. Do not worry about the shoulders area because this will be pulled out by the shoulders bone. For now, let's focus on the elbow. Let's select the forearm bone, then pick up everything on the mesh that should be following this bone. And assign an absolute effect of 1. Work on the intermediate areas to eliminate any kind of squashes or crushes. Here the topology is very clean, so we can use loops. With those points selected, let's pick up our arm, then increase its grasp by influencing those points with an absolute effect. Perhaps those as well, but watch out for the squash effect. The forearm bone should be grabbing those vertices from the back as well. Also on the bottom there is a small problem. Those 2 points belong completely to the arm bone. Let's grant some power over them to our forearm bone. I can see the squash effect happening here really badly. That's why I'll select inner points and return the power over them to our forearm bone. When working with the roll bones that are sitting on the forearm, consider them like additional bones that have to grab some vertices in their nearby areas. That is, the forearm should be grabbing vertices in this area, whereas roll bone should be getting the rest. This goes for this roll bone. The most further parts get to this one. Everything that's further on should be controlled by the hand, or in our case the palm. Because we already granted a full power for our forearm bone on this area of the hand, those vertices are belonging to the forearm. As said before, we should really steal those parts and put them to our roll bones from the forearm. Let's select our roll bone, then assign to those vertices an absolute effect of 1 towards this roll bone. After this, move up a level, select your next roll bone, and assign to those vertices an absolute effect of 1 towards this second roll bone. When this is done, you will be comparing your roll bone just as if it was the ending of a forearm. Later on, when working on the hand, we will be stealing some of the power for this loop. That is, the power will be drawn from the roll bone and will be granted to our hand. 4 vertices located in this loop. When animating my skeleton, I made my hand rotate in all 3 axes. You will see it rotating like this, but for now let's ignore it. We only want to consider up and down movement, and also rotation which occurs from left to right. This is due to the fact that our roll bones are not yet set up to follow the skeleton properly. Their sole purpose is to equalize the stretch on the model as the hand twists. They take out the unnatural squash from this area, then push it down through the arm, reducing the effect if not completely removing it. It also seems more natural, since it looks like this muscle is really driving the rotation. As told earlier, this rotation is fine, that one as well, but you shouldn't worry about this one. Selecting our palm, let's steal some of the power over this loop and grant it to our hand. The power will be drawn from the bone that's currently controlling it, that is the closest roll bone. Selecting those 2 vertices, let's press loop, then adjust an absolute effect to be greater. Let's also jump back to our closest roll bone. The topology is less obvious for the computer, but we're still able to select the loop in here. Let's steal some of the power from the hand and give this power over those vertices to our roll bone. As I said before, the topology is less evident because there is a visible break right there. It's going to be hard for computer to decide which direction you want it to go. Is it this one? Or maybe that one? But it's still taking this path, since the angle between those 2 segments is nearly straight. A good example is if you have this kind of grid and need to get from this point into here. You're going to advance straight towards this point, then there is a point of decision. Do you want to take a strange turn to the right? That diverts you by a great angle from the final destination. Or do you want instead to take this path? And so the loop selected will be this one. On the other hand, if you have a complex topology, getting from this point towards here will mean that computer will have to take a decision at this point. Does it have to go to the right or to the left? Both decisions are as equal in value, but none of them is straightforward. That's why in such case you won't be able to select loop. You want to watch out for squash effect in exactly this area, and if you see some problems in here, you want to select your hand bone, then assign a greater absolute value over the black vertices, so that they are pushed out towards their original position. As said before, skinning is finding a correct balance between the crush in geometry and a squash effect, which is really bad. In reality, of course, the matter would wrinkle up in this area, similar to an accordion. That is definitely possible to achieve with the skinning, but it will require much more loops in this area. Of course, we skinned our hand, similar to other bones. Select it and everything that its children are controlling, then assign everything to this bone. Each of the children will get its piece of geometry later on. For now, it's all going for parent. Having stolen some of the power from our roll bone, we've really ensured that this transition is quite smooth. Fingers have exactly the same story. For the thumb, select all of the geometry that should be around it, and also the geometry that its children are controlling. Then assign everything to the first phalange. This joint is similar to shoulder and might seem to be quite tricky to skin. However, all you need to do is to weigh carefully those vertices between the hand and the first limb of the thumb. As well as that, watch out for this bone. The vertices might also require some power towards this bone as well in this area. To test this, use your animation. Clearly, as the thumb is extended, we need to switch to our hand and reclaim some of the power from those 2 vertices. Let's increase our absolute effect. As well as that, mind this checkbox. Having this turned on, the vertices that are sitting on the back of course will not be selected. By pulling this displaced vertex, we are going to return it back to its original position, since we are working currently at the hand bone. As explained before, this is going to ensure that we achieve a great transition of loops. With that, we will remove any kind of sharp angles occurring here, since right now it's quite sharp. Let's select this vertex and pull it back towards the hand. If you're not sure which bones are controlling the vertex, go into the weight tools. Then inspect the power over the bones that control it. Even though the list might seem too big, right here there are only two bones that have grasp on it, the thumb and the palm, since everything else is 0 for other bones. When looking at this table, it's quite important for the vertex to ensure that the sums of power actually add up to 1. If they do not add up, the vertex will be pulled by the world to its original position. So make sure that those two numbers, when combined, form 1. In this case, we have two options. We clearly need to return those two vertices to their original position right here. We can do this by either selecting this bone and pulling it towards it, or selecting our hand bone and also pulling it towards this side to its original position. The hand option is better because when working with the index finger later on, points in this area will be drawn by the finger, and as it bends, this will create a kinky effect in this area, or the squash one. Another form of explaining is that index finger shouldn't have any grasp of vertices that are beyond this point. Clearly those 2 points are already behind the line and will be here. Granting some power from over here to our index wouldn't be correct. The more sensible bone would be the hand. Let's select our palm bone, then increase the absolute effect. You want to have smooth and round loops wherever you can. As I animate, you may notice that the thumb has some power over this vertex, whereas in reality it wouldn't have any. In my opinion, this is going towards a squash effect, so let's select this point, then grant some more power over it for our palm bone. This is adding up the potential for the crush effect to occur in there, but that's better than having a squash. Really, the thumb shouldn't have any control over that area, and if it does, it should be very minor. As well as that, of course, don't forget that there is a muscle or a series of muscles in here that are controlled by the thumb in some degree. I'm pretty sure at some point of your life you heard of fortune tellers that are looking at your hand and reading the lines from your palm. Well, this one clearly defines an area of influence for the thumb. However, if you see something unnatural, like here for example, perhaps you should go towards the palm. We are now done with the legs and with the arms, but still there is chest to do, as well as the head. For the head, there are two options of how you can do this. You know that there is a head bone in here and also a few of the neck bones. Keep in mind that we have two objects, the body and the head, which is a separate object. Of course, we tied this body via the skin modifier. We can either do the same thing for head, or actually grab our head object and simply link it to our biggest head bone. The second option is what we're gonna pick. It is so because we're not gonna be rigging the face. After it's linked, we can simply use the morpher modifier to switch between different animations and different facial expressions we've prepared earlier. That's why simply grab your head object and link it to the head bone. Now, as the bone rotates, it will carry the head along with it. However, we also need to tie the neck area to our skeleton, and especially the upper parts of neck, to follow the head bone, since if we look from the side, when the head moves, you will see that it actually detaches from our neck bone, since it's not yet tied to follow the head. When we were skinning our spine bones, we assigned everything to be above, belonging to this spine right here. After that, we were working on the arms, that got its tall, and this side as well was done by me. Now this whole spine controls this area. We need to break it down between the shoulders and the neck bone. After that, we will be doing chest bones. However, for now, let's rig those 4 bones. What I meant when I was saying that we need to rig the upper part of neck to follow the head bone is that we have a neck bone going like this and also a big head bone right here. Of course, our whole object for the head follows this head bone, and that's okay. But our neck, which actually sits inside of the head, is still being controlled by this spine right there. When we skin our neck, of course it's going to grab this area of the vertices, but the upper part of the neck should be pulled by the head bone. That way it will seem that the head and our body are actually one single piece. However, with that approach we can use morpher modifier on our head, which is still separate. With the morpher modifier we can animate character speeches, and we still can rig the eyeballs to move. However, in my case, those are the two parasites, each of which has two eyes actually sitting inside of his head, so those guys wouldn't be moving. But right now for us, it's task of rigging the shoulders, revisiting those two spines as well as the neck. Let's grab our body, go into Modify, Edit Envelopes. As we select the spine, here's what I was talking about. The shoulders obviously don't control anything, and we need to reassign some power to them. But this bottom area, which is in the neighborhood with this guy, is sorted out perfectly. If we look at our shoulders, when he lowers his arm, if we check our roll bone, you see that it has no control over the shoulder or the deltoid. It all goes for our arm. This is not good. Similar to our forearm, let's take out the ending from our arm and assign it to our roll bone. From the front view, I'm going to center on it, go into the wireframe mode, then with my favorite flexible selection, I'm going to pick this area which belongs to the deltoid and therefore to the roll bone. Let's increase our absolute effect for our roll bone towards those vertices by 1. As you know, there shouldn't be any of those abrupt changes from gray to red, so perhaps this should be orange. Let's go to our arm bone and steal some of the power over those vertices from our roll bone. For the arm bone and those vertices, increase the absolute effect to 0.5, for example, and we will adjust this later after the rig will be done. The roll bones are only required for the twisting motion when the arm twists, but we are already capable of creating a nice transition as the character lowers his arm like this. Let's adjust this area and work on the twisting after the rig was done. But before we do this, let's first assign the correct area, this one for example, to belong to our shoulder bone. Switching to our shoulder area, it requires us to grant it this area, as well as some of the control towards the armpits. The area in here is going to be controlled by our roll bone, everything else will be controlled by the arm, then the forearm, and the roll bones come into play later on. This part right here is going to be controlled by those two spines, this one and that one. The upper neck bone is going to be controlling it with the most power, and the spine below it is more minor. Coming back to our shoulder bone, let's select the appropriate range of points and grunt it to our shoulder bone in the ratio of 1. If you see some anomaly happening right here, for example when this bone turns, it pulls some of the vertices from here, that means that we need to extend our range of selection to that amount, then assign it to our shoulder bone to eliminate this problem right here. Notice what happens as the character points his arm downwards. That's exactly what we're going to be working on. This area should be pulled by the roll bone, as well as the arm, and also the shoulder bone. Later on, this part right here is going to be pulled by the chest bone as well. So it's a very complicated joint. So far the most complex out of what we were working on the whole time. Selecting my roll bone, I will add some of the pull towards those vertices for our roll bone, exactly by a factor of 1. Those ones can be weighed between the roll bone and the shoulder, and those ones as well as the rest. So working between the roll bone and the shoulder. A lot of attention should be paid to the area that is under the armpit, so that there is as less as possible of squashing and also of crash. As you can see, there is some of unnecessary control of the roll bone towards this vertex. Let's grab it and grant this power towards our shoulder bone, or maybe actually to the spine bone. As told earlier, don't worry about the twisting motion, this will be adjusted after we rig our skeleton. even though you shouldn't consider the twisting motion, you still might want to look for those arcs and the loops to be correct. That's why consider twisting motion, but don't worry about the arc or the squash that happens here as the arm gets twisted. Simply pay attention to the correct looping. And if you see something too abrupt, perhaps you should still pull it down by some other bone.
The reason why many artists prefer not to use this bone, but rather to have one single bone going through the chest, is that this particular spine is only going to be used for the upper backwards part on the body and also the front part of the body. That's all of its functions. Rest of the geometry is going to be captured by the shoulder bone and the roll bones, as well as the chest bones that are going to be controlling this frontal part. Shoulders are very important to us when talking about the back part of the character's geometry. As well as controlling the upper part of the torso, they are going to be guiding our shoulder blades in this area. As you could have seen before, I animated my shoulders to move forward and backwards so that the character can hump his back or roll his chest. As he's doing this, have a look at his back in this area. It stretches outwards from center. That's where we're going to be using our spine bone, this one, to pull the nearby geometry into this center, and also the spine that is below it. Let me show you how my shoulder looks like. For example, the right shoulder is controlling this part. The red one is, of course, where it's having the most influence. And you can see that this is exactly where the shoulder blade goes. Exactly the same story happens on the shoulder on the left. It gets orangey and yellowish here because their influence is falling down as we approach the center of the back. And if we look at our spines, they are doing all their work to gather those vertices and pull them towards the center. You can see here that the shoulder is pulling the vertices towards this direction. But the middle spine is doing all it can to keep some grasp on the nearby areas. Of course, the horns are completely belonging to their respectful shoulders. As said before, I'm doing this just so that the horns don't bend, because they are not stretchy. They are a solid piece of matter. Don't worry so much about the front part of the character, as this piece of geometry is going to be held by the chest bones. But the backside should be done to its best ability, since there is nothing else apart from shoulders that is going to be controlling it. Check your animation and adjust any vertices if you need to. Of course, just like I said before, you can use your mirror tools if your character is symmetrical. With that, you will only have to skin the left part of the character. Then you will be able to mirror blue to green, that is left side to the right side, and the vertices will copy their power from their respectful clones. As you can see, the vertex in this area is crushing into the geometry. Our first thought might be to pull this vertex towards the shoulder bone. However, if we look at the absolute effect, this value is nearly 1 and will have almost no effect. We should instead use this spine. To show you what I mean, let's click on this vertex, select our spine, and increase the grasp over this vertex for this spine. Increasing this value will mean that the vertex will return back to its position, since the spine didn't move. I sense that those two vertices must move backwards as the character rolls his chest. To which bone should we grant more value over them so that they are pulled backwards? Think for a second, because this is a little test for you. The answer is the grasp over them should be given to the shoulder bone. That's because the character moved his shoulder bone, and everything, for example the arm and the left shoulder blade, went backwards with it as well. So if we increase the value over those two vertices for the shoulder bone, they will be moving backwards with it just like anything else. Let's select our shoulder bone, and for those two vertices increase their value towards the shoulder bone. Maybe those ones as well. Once again, since there is no additional bones like on the chest that will be controlling the back, the shoulder blades have to be skinned properly at this stage. You want to look for nice loops and smooth curves within the body. If they aren't smooth,
perhaps you should fix something. However, in my case, I have so many wounds on the character, sometimes it's really hard to tell which part of the body requires fixing. That's when I look at the animation to understand what's going on. Here's another test. This vertex moved back with the shoulder, but I think it should be more towards the forward, so its original position. Which bone should I tie it to? Or towards which bone should I increase the grasp over this vertex? It is this spine bone. Since it didn't move, as we increase the value for this vertex, it's going to reclaim it to its original position, since the bone didn't move. Let's select our spine, select this vertex, then increase its value to be greater. Then let's go to the shoulder. With it, let's pull this vertex backwards. Here is a test number 3 for you. I feel that this vertex is going to the right as the shoulder bone bends forwards. The question is, how can I return this vertex backwards? Of course, it is the spine bone. As I told you before, the spines are keeping the grasp over the vertices next to the middle line. Let's grab this vertex, and perhaps this one as well. Select our spine, and increase their values towards this spine. We got 2 bones to consider right here, the neck bone and also the head bone. The upper vertices should be connected here, that is to the head bone. The rest should be tied between the neck bone and the nearby shoulders, as well as the spine that's below it. But as I explained before, this bottom spine is more controlling the vertices on the upper part of the back, as well as the center line between the shoulder blades. With our neck bone, let's select the nearby vertices, then assign an absolute value to be 1 for this neck bone. Those ones as well. And focus really on the back part, since very soon we will include our chest bones into our structure. Let's steal those 3 vertices from our shoulder bone and maybe from the spine that's below it, then grant some power over them to our neck bone. With that, we will also achieve a nice loop in this area. Select our head bone, then assign those vertices to be sticking to the head bone by a factor of 1. The nearby loop should also be weighed between the head bone, the neck, and the lower spine, perhaps later on with the chest bones as well. Here you can see me selecting the spine bone and actually pulling this vertex backwards to its original position, since that's the shoulders that are animated right now. You may as well unhide your head now. As you can see, when the neck moves, because we've attached the upper vertices to be following the head bone, the neck now seems to be attached to the head. You may want to weigh those vertices between the shoulder, the neck, and the lower spine to achieve this nice curve. When the neck is rotating, I don't think that those vertices should be moving at all. So let's fix them between the shoulder bones and the spine bones. What you can observe here is that the upper spine is rotating, however in reality it wouldn't be, since its sole purpose is just to bend the back. What I'm talking about is this bone right here. That's why you shouldn't worry about it rotating and pulling any kind of vertices. Actually, I shouldn't have animated this going left to right at the first place. It's only the neck in whose rotation we are interested. You can see that those vertices are following the head bone too much, so let's return them back by pulling them towards the spine bone. This vertex shouldn't be influenced by our neck bone at all, and it really shouldn't be influenced by our shoulder bone. That's why again we will tie it more strong to our spine bone. Actually, I'll delete rotation from this bone, that is, this spine, since it shouldn't be rotating at all. It's this keyframe, along with this one. Make sure to save your work regularly. Also, as told before, ensure that you are saving it as different files. It's much easier to roll back to a previous file if you did something wrong than if you have one single file for everything. Now let's add to our structure the bones for the chest. For that, of course, let's go into here, into the geometries modifier, and from this list make sure that you have geometry selected. Also go into display, expand all. Look for the lines which have this kind of sphere next to them. That means that we are looking at the geometry. And since our bones are made from boxes, they belong to geometry. Of course, bones are hidden in this section. We need to select those two objects. Click select to add them to our list. If you recall, those are just two boxes which have pivot point close to the center. If you rotate them, they're going to be moving along the line in the middle. Let's select our body along with the head, right click and hide temporarily. As we inspect our animation, let's ensure that the chest bones are rotating according and kind of synchronized with the shoulder bones. That is, as the character humps his back, like this, the chest bones should be moving halfway of this rotation. For example, a full rotation synchronized with the shoulder bone will mean that this chest bone will have to rotate exactly the same degrees as this shoulder bone did. However, we only want to make it rotate halfway of those degrees. That is, if the shoulder bone had to do 45 degrees of rotation, for example, from the center line, this one will only have to do like 20. Make sure to animate this change. Here is the center position or center line. Let's enter the auto key mode, right click, and plant a key for all three parameters. Of course, this should be done for both chest bones. We can then look and trace the moment of time where the humping reaches its maximum, that is somewhere here. Then grab each bone, and do not rotate the same amount of degrees as the shoulder bone, for example to this amount, but somewhere in between, like this for example. Also make sure that it's synchronized and kind of symmetrical on the sides. Make sure you return them back as well. Also, let's find a point where the character rolls his chest at its maximum somewhere here. And once again, you want to rotate this chest bone halfway of the shoulder bone rotation's amplitude. For example, somewhere here. Let's go into perspective mode and see what we have. Of course, the arms return back to their original position somewhere at this point of time. We should copy both of the starting keys from both of our chest bones and return them back at this point of time. We can then unhide all of our geometry, but you will see that the bones do not do any kind of change to the motion of the muscles within the body. That is because they are not controlling any kind of points at the moment. Chest bones are just intermediate bones. There are going to be almost none of the points which they control with an absolute effect of 1. Maybe somewhere in the middle there will be a few, but everything else will be weighed between the shoulder bone, the roll bone, the middle spine, this spine, the neck bone, but mostly the upper part is almost completely going to go for the shoulder bone. That is, we're going to be weighing between the shoulder bone and the chest bone. Overall, the whole area for one chest bone is going to be somewhere in this region. In my case, backface cal vertices won't work since my geometry hides some of the empty holes. For example, just in this case where the bone is empty and its empty end is hiding somewhere inside of the geometry, if I'm drawing selection across the character with backface cal vertices, some of them might be selected occasionally. That's why I'm not even gonna bother with backface cal vertices. However, you might consider it if your character is properly modeled. You can also go ahead and use a paint selection from this mode, just to paint out vertices on the front of the character, the ones that you want to select. Also make sure that you turn around and check if you have selected any kind of vertices, unwanted ones on the back of the character. I'm going to work with the flexible selection. That's much easier for me. Having done this, I'm going to select the region of vertices that is most likely going to be affected by the chest bone, and will deselect with Alt and left click and dragging across the vertices on the back that I don't want to pick. Temporarily, let's assign an absolute effect of 1. Select our chest bones, go into Object Properties and reduce the visibility down to 0.2. Also, let's check their color to black. Let's select our geometry, edit envelopes. Now we can see through the bones. Clearly, this area should be weighed between the shoulder bone and the chest bone to its best ability. Having selected those vertices, I'm going to switch for the shoulder bone and increase an absolute effect towards those vertices for our shoulder bone. If we select this bone, for example, I see that I need to pull this vertex towards it. So let's increase the absolute effect. Those two vertices clearly should have more obedience towards the chest bone. So let's increase their absolute effect towards the chest bone. Once again, just like I told you many times, you want to achieve a nice transition of loops and arcs. That is, by pulling this vertex, I'm ensuring that the angle on this loop is smooth. Of course, this is only possible if you have a nice topology with quads and stuff. As well as that, just like I mentioned at the start of the video, balancing out the distances between the stretched polygons will mean that the texture is not distorted too much. For example, if you have a overly stretched polygon, such as here, and then your lines are following closely to each other, that will just mean that this stretched polygon will have its texture distorted. The two major players in this area are of course the chest bone and the shoulder bone. Right now we're not even considering the neck bone, which will come into play later, when we're going to be focusing on the area of the vertices closer towards the center, somewhere here. But over here, it all should be weighed between the shoulder bone and the chest bone. Although there is a wound in here, it is still too big for a cavity. I think that some of the vertices from the top must be pulled by the shoulder bone, just to achieve this nice transition. When touching deltoid, be very careful, because interferences, if any, should be very minor. That is, I'm tempted to pull this vertex towards the chest bone, but if I do so, it should be very small. The change should be very small. The absolute effect shouldn't be great at all.
This is because it's the roll bone's responsibility to affect the deltoid. Let's not mess with it. Once again, notice how those vertices are weighed between the chest bone and the shoulder bone. Its area of influence descends like this on both of the sides actually. On the front side and on the back one as well. Its reddest part takes this place, then it descends in a kind of orangey style, like so. Then gets a fairly large area over the chest bone, some of the deltoid, and under the armpit as well. Of course, on the back side, the similar picture happens. You can even see some of the blue parts right there. You want to watch out because under the armpits right here, you want to ensure that you weigh this part between the shoulder bone, chest, and this spine. I also noticed that those two vertices in this area shouldn't be pulled so much by the shoulder bone as it extends backwards. That's why we have the chest bone. We can pull those two vertices towards it and the problem will be solved. On the other side, those two vertices are pulled too much by the chest bone. We need to give more power over them towards this spine bone. You can see some of the blue area in here. That's not correct. None of the vertices from this part should belong to this spine. If anything, those vertices must be controlled by this spine at most. We already know that those vertices are captured by many bones, so if we decrease the absolute effect for this spine, they won't be left behind because other bones will recapture this power, and it will be redistributed. We can safely reduce an absolute effect towards the spine bone. And actually everything above should be reduced down to 0 as well. Now let's focus on the vertices that are sitting closer to the middle. Those should be pulled by those two spines. Later on we will also focus on the neck. Over there, the weight of the vertices should be redistributed between the neck, spine bone, and the chest bones.
As you can see, when the character lifts his neck, or puts it backwards, notice how this vertex, the selected one, raises upwards. I don't want this. However, I don't want it to be tied to the chest bone either. Even though it belongs to the region of this spine, which actually raises it, I can pick the spine which is below it and actually pull it towards it, since I don't want it to be pulled by the chest so much. That will ensure that as the character moves this bone backwards, the vertex will not be affected as much as it is right now. Ensure that your yellow areas of influence are surrounded by blue. This smooth transition is very important for the chest bones. Having done this, work on the left chest bone. Also remember that this primitive movement of chest bones isn't exaggerated. This isn't the final look of how the character will roll his chest or arc his back. It's going to be slightly more exaggerated, and we'll still have to go back to skin at some point and readjust the points to flow nicer. Having built a skeleton, skinned your mesh, it is now time for a final step. We need to take our skeleton structure and rig it properly. That is, throw some of the relations and wiring from the previous tutorial to give it more fluidity. You want to create a nice doll for an animator to work with. It must have several of the controls, but the guy who is going to be adding motion to it later on, if that is you, then great. He shouldn't be worrying about moving each single bone. At most, he wants to grab several of the controls to pose the character as quickly as he can, being able to express the whole character and the style of the creature. There are 4 stages when building a rig. They can be done in different order, but the main parts are as follows. There are arms to rig, which can be the first part, or whichever one you want. You also need to focus on the body, as well as the head. Also, you need to do the lower part of the torso, that is the leg, and the feet. There are different types of dolls and rigs. This one is more of a humanoid. As well as that, there are also different levels of difficulty and complexity of the rig. On a scale of 1 to 10, this rig is going to sit somewhere at 7, maybe 7.5. This number just stands for how many formulas are we going to throw into the body. We are going to make use of the IK solvers, and I'll describe what it is later, FK motion, custom attributes, some of the parameter wiring, reaction manager, and of course usual linkage, using this simple tool. We are also going to use different constraints from an animation palette. To be fair, you're already familiar with all of those concepts, mostly from tutorial number 5, and as we go further, I'm going to describe everything new to you, so don't worry. We are going to start our workflow from the arms. When you have normal bones, there are 2 different types of motion that can occur between them. The first type of motion is the forward kinematics. That is a normal rotation of each bone affecting an incline or a rotation of its children. When we rotate this bone, we are ultimately changing the position of its children, respectively. With this system consisting of 3 bones, including an ending, you can modify the chain via the 3 rotations. One originating from this point, the second one from here, and the third one from here. The ending in this case is not used. FK is especially useful when you want to achieve a precise rotation. However, it is also time consuming. It is used to manipulate an object when it's in free state. That is, for example, a hand which hangs freely in the midair. The rotation and the motion of children with it originates from the main parent. That is this joint. This type of rotation and manipulation wouldn't be of any use to you if you would want to animate a character who is, for example, leaning against the table with his wrist. For example, at this point, you would want your hand to be glued, and any kind of movement within the shoulder area or the body as a whole should be regarded towards this position. In this case, that's the ending bone who is playing the most important role. It is the final position of the ending bone, according to which the positions and rotation of its parents are going to be calculated. That's the reason why it's called inverse kinematics, because everything originates from the child. Let's look at this chain now. It also has a parent bone, 2 intermediate bones, and 1 ending bone right there. The way the bone chain was created is interesting. The bones are geometrical objects with a hierarchy between them. Therefore, a chain knows which bone is the main parent of it. That's why we can either select the parent bone or the ending bone. Go to Animation, IK Solvers, HI Solver. Then drag on the bone that we want to be considered as the main parent. The solver is going to look at the hierarchy of the bones and is going to figure out which bone from the selection has the lowest priority. In this case, it figures out that it is an ending bone, so it places a so-called IK goal in this area. It also drew a line to the main parent on which we clicked. With repositioning this IK goal, we are going to force the chain to deform and adjust its angles so that the distance between the goal and the main parent is preserved. For example, if I select the main goal, when I translate it along the plane, you will see that the chain adjusts itself and its angles with it. Once it drew this line, we won't be able to flip this bone to this side. Even if we try to make it straight, as soon as we return back, those bones won't translate to this side. They're going to return back here. If there is something that's driving the main parent, for example the shoulders, the IK goal will ensure that the position of the bone that is controlling is going to be preserved and unchanged. For instance, if I'm changing the position of this main parent, you can see that all of the positions and the angles between the bones are adjusted. The rotation of an ending bone changes, but its position stays the same. Once again, this system is called FK, forward kinematics. This one is called inverse kinematics. If we go into the motion panel, we can adjust different settings for the IK goal, but this will be done later on as we make our rig.
As you might have suspected, we need to make use of both of the principles. That is, the IK and FK altogether should go towards this arm. We should be able to manipulate those bones using those two types of controls, since the character might sometimes lean against the surface, a floor or a nearby table for example, or most likely his hands are going to be in a free state. Then we're probably going to be using the forward kinematics. If we represent this chain with the green line, we can then add 2 different chains, similar to this green one. One will be an IK chain, and another one will be an FK chain. Both of them are going to be created and are going to be originating from the green chain initially, but the fact is, an IK chain can be moved separately by the control at the end. Having grabbed its tail, we can position it and fix it at the point of space, as if the character is leaning against something. Its bones are going to be having the same length as the green chain, so the overall length of the orange line is going to be equal to the green one. However, it only will have one control, and several of the custom attributes on the control to adjust the position of, say, elbow. On the other hand, an FK control has exactly the same length as the orange line, but has slightly more controls. It is also a chain consisting of 3 bones, an arm bone, a forearm bone, and a wrist bone, but its key idea is that you can rotate any chain the way you want to. If at some point of time you decide that your hand has to be hanging freely, and you should be only using an FK approach, since your ordinary green chain is going to be weighed between an IK and FK chains, you can simply wait to be following an FK chain by 100%. That's going to mean that the green chain is going to be translated towards the FK chain, and it is going to be aligned with it, since it's following it at 100% accuracy. After having used several of the controls of the FK chain to reposition the green one that was translated to it, we can then decide that we want to use an IK chain. In that case, we'll simply weigh the green chain backwards to the IK chain. Or if it is already repositioned, for example, if we moved our IK chain somewhere here, when we weigh it back to the IK chain, the green one will be translated to it, and we'll be following it like if it was glued, bone to bone. We can then use a control of an IK, the single one, to reposition it in space, for example like this, with this control, and the green chain will be following it like if it was glued to the IK chain. That is, we need to use this green chain to create other 2 chains. The orange chain will be an IK and will be carrying an IK solver from an animation palette, and also a red chain which will be an FK chain. Let's ensure that our body is frozen. I also want to point out that my roll bones are still there, but let's make their color more visible. They were transparent, so I pressed Alt-X to make them opaque. Let's hide them temporarily. Double-click on the main parent to select the whole chain, press Clone. You can now select the newly created chain, move it upwards like this. Get rid of the fingers and the palm straight away, you won't need them. If your bone did this strange movement in here, you can go into Animation Bone Tools, scroll down to Bone Objects and set the width and height to be negative. This is just for an aesthetic looks, so it doesn't really matter. We're not going to be using the wrist anyways, but we will use it to align our newly created object. For that object, let's go into Helpers, and of course let's create our most favorite point helper. Let's then align it to our wrist bone in position and orientation. I'm going to make the size to be 15. At this instance, I'm going to link my helper to the forearm bone, then select this newly created wrist and delete it. As you can see, the forearm flipped itself. Let's go into Bone Tools, Bone Objects, and invert its height and width. The newly created helper should be called Mutant Left Wrist FK. You want to rename those two objects as well by getting rid of the last 7 letters. Instead of them, let's put FK. Also, double-click on your chain to select it, and change the color to be red. If it's not bright enough, you can go into Add Custom Colors, then select the brightest red you can possibly find. Now we have 2 chains, a main, that is an ordinary chain, which is the green one, and we also have a red chain, which was created from the first one. If you double-click on the red one, you can right-click and clone the chain. You want to find a duplicate chain, that is the one that has a 001 at the end, then bring it down, and change its color to bright orange. Get rid of the last 5 letters and change them to IK. Having changed the name of a newly created chain to have an IK ending instead of an FK001, we need to align it correctly backwards towards the green chain. Let's also go ahead and change the size of an FK to be slightly bigger than the IK chain. This can be done using the bone tools, since remember that we inverted our bones. The FK chain should have a height of 3, the same thing for width. For the forearm bone, you need to enter a negative value. Working with the IK, let's make it 2.5. So slightly bigger than the green chain, but less than the red one. As for the wrist IK, let's make it slightly less than the FK wrist, so say 12. Since our pivots are following the same scheme for all of the chains as well as the green one, we can align them correctly. Let's select the main parent for the IK chain, then click Align, and click on the green chain. You only need to align via the rotation, since the way we duplicated the chain was via the cloning. We didn't move it anywhere, only rotated it. Align it in all 3 rotations, and press OK. We don't need to align any other further bones, since we didn't rotate them. It was only the main parent who was lowered. Repeat the procedure for the red chain. Perhaps orange color wasn't the best choice. Let's go ahead and select a yellow one. That is, our IK chain will be yellow. Repeat the procedure for the other arm, but remember that you don't want to be unlinking the main parents at any case, since as soon as you unlink either of the main parents from the chains, that's going to create an anomaly within the skin modifier of the mesh. Of course, at this stage you should have saved your work to a different file, so if something, you can always roll back to a completed skin stage. As for the point helper, its size should be 15. Let's align it to our wrist bone, in position and orientation. Click OK. Let's link our newly created helper to the forearm bone of the FK chain. Then get rid of the wrist bone. Change the color of an FK to be bright red, and get rid of the last 7 letters on the ending of each bone. Rename it to FK at the end. As for the helper, just like we did it with the left arm, let's rename it to Mutant Right Wrist FK. Double click on this whole chain, then right click and clone. And watch out, because if you are going to rotate it with a shift, intending to clone or duplicate an object, you'll once again create an anomaly within the skin modifier of your mesh. So it's only the option clone that works, and also you shouldn't be unlinking your main parents from the shoulder bone, because this once again will create an anomaly within the skin modifier. Find the chain that you created at the last instance, that is the one with the 001 ending, press E and rotate it downwards. Of course, the ending for each bone should be changed to IK. The color should be changed to bright yellow. In this case, we didn't have to invert the bones, so we can simply reduce their size from the modifier panel. But their units are different, that is centimeters here, and back in the animation bone tools, it was generic units. I'm just going to select bone tools to be consistent, then change the height for the IK chain to be 2.5, just like before, and repeat it for each bone within the chain. The helper should be 13 or 12, I don't really remember. Yeah, it was 12, so let's put 12 in here. As for the FK chain, each of the bones should have a height and width of 3 from the bone tools menu. With that, it's going to be much easier to select them later on. And the helper should be 15. Just like before, we now need to align the orientation of those chains, their main parents, to the orientation of the main parents for the green chain. Then align to the green chain's main parent. Only in orientation, because we didn't move it with shift click and dragging. It was only rotation. Pivot to pivot in rotation only, just for the main parents. Do the same thing for the yellow chain, that is our IK chain. Since red and green are already facing in the same direction, we can click on either ones. For example, the red chain, which is facing the same direction as the green one. Align in orientation only. Before we jump further on, I would like to step aside for a second and introduce you to a new topic. It is Max Script. With it, we will be able to create our own custom tool or panels to work with the character, modify its properties, etc. In order to achieve this, I need to introduce you to the way the 3ds Max script is working. Remember how we were working with the listener window in tutorial number 5? Well, now we can recall it. You can right-click in this area and open a listener window. It might have some messages for you in both of the boxes, or you might not even see the red box. In this case, you need to grab it by this border and drag it down like so. To clear whatever it has in those areas, you can select an area, press Ctrl D. There are two ways in which you can interact with the interface of 3ds Max. The first one is to create objects, modify them, do whatever you want in the viewport area. That's one way. Another way is to do it via this console window. You can use the red part to enter instructions to 3ds Max, and in the white area 3ds Max will be throwing any kind of errors that your actions have produced, or confirmations to your actions. For example, if I enter create geometry box, you can see that it straight away produced a line of code saying that we are about to create a box. Its default settings will be those, but we can alter them by creating them in the viewport, or creating it and then adjusting the settings. Usually after clicking box, we would start dragging in the viewport to create an object. With this line of code, we can simply press enter. This will produce a nice little box for us. As you can see, it said that we are going to create an object of type box. There are different types, for example, sphere, cylinder, whatever, with several default variables, for example, those three, who were assigned by default a value of 1. For example, using this line of code, we'll produce a box whose length segments will be 1, same thing for width and height segments. You can clarify this for yourself over here. Its width and length are going to have the same values, and this is going to produce a cube for us. Also, we're saying that map coordinates are going to be turned on. That way, this object will be able to grab a texture or a material. If it's off, then UV coordinates wouldn't be applicable to the vertices of this cube. Let's clear the areas by pressing Ctrl D in either of the windows. You can see that when I click on the cube, it produces a message which states select $box 01. In other words, we can use this message to tell Max, please select a selection which will contain an object with the name box 001. $sign stands for selection. If I press shift and drag my object to the left to create a copy, let's say 6 copies, we can now say select $box 004. Obviously, if we go into modify panel and inspect its name, it's going to say box 004. We can also use listener window to tell it to select all objects whose name begins with say box. For that, if I delete those upper lines of code, in this one I can say select $box and then little star. That is usually accessible by pressing on 8 while holding the shift button. As we position our cursor at the end of the line and press enter, that's going to execute the code and create a selection with the objects whose name begins with box. And 3ds Max threw a message to us saying that it done what we asked it to do. If we're going to create a sphere, for example, you can see straight away that it produced a line of code saying that the type of object is sphere, with a couple of default values assigned to the default variables, such as smooth, radius, etc. If you look further on, it also specified its position. Of course, it was done in terms of generic units, x, y, z, all separated by commas. Of course, those things are variables, just the same as position, and this
is the position's value, depicted in the square brackets. By saying position column, we're literally saying that please put this object at the following coordinates of the world. We're also saying that by default it's going to be selected. Obviously this variable can only take variables of form true or false, and currently it's on. That is, as soon as we create our sphere, by default it's going to be selected. If we copy this message from before and paste it into here, it's going to create a selection that will contain everything whose name begins with box. Making sure that you are at the end of this line, press enter. As you can see, it readjusted our selection, so now it contains the boxes. If we rename a couple of our boxes to be, for example, ABC, this one to be BAC, this one to be DAC. As you can see, all three boxes now ending with the C letter. Let's clear the content in the red area by pressing Ctrl D and writing select $*C. That's telling 3ds Max to create a selection with everything whose name ends with C. Since before we used a star after the letters, signifying that we only care about the beginning of the name. Right here it's at the end, so it's going to look at the last letter. As predicted, it selected 3 of the objects whose name ends with C. If we switch to a different object, for example this box, change the transform type to rotation, you can see a new line of code was produced. When we select one of the axes and rotate the object, you can see that it's saying rotate a selection via the function called angle axis, using 65 degrees as an input, true in X, but false in Y and false in Z. So it's essentially saying rotate this selection in X via the positive 65 degrees. If we enter 13 here, for example, then press enter, it's going to rotate our selection further on. If we manually draw the selection across the objects within the scene, we can copy this line of code, paste it into here, and press enter to rotate the whole selection by 13 degrees. If we want to rotate it by 13 degrees both in X and Y axis, we can put 1 into here. Then this will be rotating our selection by 13 degrees both in X and Y direction simultaneously. Well, the moral of the story is you can do different actions on the objects and simply look at the lines of code such actions produce. You can then grab those lines and reuse them later on by simply plugging different values into the variables. So, as you can see, the viewport color changed itself, signifying that you've advanced to another level. Yes, now we can actually dive into Max script. We've already become familiar with the listener window. Once again, listener window is a very useful tool if you want to understand which line of codes are going to be produced if you perform different actions, say rotation, movement, etc. If you create boxes, for example. Listener window is going to explain to you, in terms of code, of how it actually sees this action. That's why keep in mind that you can always use listener window to figure out the commands that you're looking for, by simply ensuring that you have macro recorder enabled. That way anything you do within the viewport is going to be recorded and thrown at you in terms of lines of code. We can go now to Max script and create a new script. I don't know how sophisticated you are within the scripts, but Max script is a language which is very simple to master. It omits almost any kind of technical implementations about which you have to think, for example, when working in C# in the more sophisticated languages. Here they are all omitted. We will be going over scripting later on as we dive into Unity, so right now I wouldn't want to go too far into it. However, there are some basic things to point out. Scripting is a set of instructions that advance downwards as your program progresses. There are several tricks to read different lines, to skip some of the lines, etc. But each of those lines represents an instruction that computer has to take in order to proceed further. Obviously, a program will be read from the top to bottom, and there are going to be some key points within the program. For example, you can use different types of lines that are going to be dependent on the ones before. And if, for example, a set condition within this line is not met, then this green line won't be executed and we jump to something else. First of all, save your script in the same folder where you place your character. Make sure to save it as Max script. As you can see, there are different extensions for you to use, but we really need this one, .ms. Do this because sometimes scripts tend to crash, especially if you do something wrong. If you feed a wrong instruction, for example, it might destroy itself. So it's always nice to have something to go back to. As you already know from the notes that were shown to you during the video in the orange boxes a couple of minutes ago, there are variables, values, and functions. The latter ones will be discussed by us later on. Right now we want to focus on the first two. Once again, a variable is like a simple small container in which you place information, that is the value. Each variable has its own name, and to declare a variable, to tell our computer that we have this variable in this little script, in our little white world, we just simply need to write its name. For example, my variable. Of course, you don't use spaces in the names, and if you want to use a space, you would be using underscore. But almost nobody uses underscore. Simply use so-called camel case. When you want to emphasize that those are two separate words, don't put a space, but simply put a capital letter of the word that's starting after. For example, my variable. It's a one word, but from this camel case, we can understand what I wanted to say. So we're saying there exists a variable, my variable. Initially, it has a value of 0. You also put a semicolon at the end of each line. I don't think that's necessary in Max script, but in all other sophisticated languages you gotta put your semicolon, signifying that this is the end of the line, the end of the instruction. Let's say I want to make use of it. For example, I want to increment this variable by 2. For that I'm gonna say my variable becomes equal to my variable plus 2, and then semicolon to indicate the end of the instruction. This sign right here is a little bit different from the mathematics point of view. It means becomes equal to, that is, the left side becomes equal to the right side, and not vice versa. It's not mutual equality or anything. It's precisely saying that the left side becomes equal to the right side. It gets the value of the right side. With that, we're saying that my variable, which has a value of 0 at the moment, becomes equal to this variable plus 2. For example, we can do something like print, open brackets and close brackets, and inside of those brackets, let's put my variable. After the brackets, let's put semicolon to indicate the end of the line. To run a script, you have to literally execute it. To do this, simply press Ctrl E, or go into Tools, Evaluate All. But Ctrl E is the quickest shortcut. And actually, let's right-click in here, in our listener window, and open it up. Now, notice what will happen as soon as I will press Ctrl E. The computer will understand that there is a variable, called my variable, which has a value of 0. After this is going to say we want to increment this variable by 2. Obviously, on line 4 and 5, my variable will be having a value of 2. And on the next line, line 5, we are saying that we want to print out whatever my variable contains. And obviously it's going to be 2. Because this window is used for debugging, it's going to tell you all the intermediate values, so you only have to care about the last one. As you can see, we were assigning whole numbers right here, that is, number without any kind of decimals. Those types of numbers are called integers. On the other hand, the ones with the decimal, with the dot, for example like 2.5, are called floats. There are different types which you can use, for example double and float, but think of the decimal as a float and a whole number as an integer. We can also say, for example, we want a second variable, such as second var. Doesn't matter which name we give it, let's give it this one for example. And then let's assign it a value of 5. Also let's say a third variable, let's call it some text. Obviously this variable's name suggests that we're going to be storing text in it. But how do we do it? So far we've been storing numbers, and to store some information in form of text, I want to store a string. I'm going to start my string with double quotation marks, and for example if I put 5 space bars, then another double quotation marks to end the string, everything inside between those quotation marks will be regarded as a piece of code. For example, it now contains 5 letters representing space bars. If instead of this I'm going to put Igor is, and then space bar, this piece of text now contains 8 characters, because spaces are also counted. Don't forget to put semicolon at the end of your line to signify the end of the line, the end of the instruction. We can also put some other text, and in between a pair of double quotation marks, let's put an ace, and then semicolon at the end of the quotation marks to signify that we finished our line of code. So now we have 4 variables. Instead of my variable at the end, I want to print out some different value. That is, I want to print Igor is. For that, I'm going to stick my variable, some text. That is, use this variable to execute this function. We'll talk about function later on, and especially in Unity, it's gonna get very hard, believe me. But right now, let's take it slow. We are feeding this variable into our print function, which will then print out a text. So as soon as I press Ctrl E or execute my script, the computer will say, okay, I was notified that there is a variable called my variable, and by default, it has a value of 0. So this variable stores a number, okay. On the second line, it detects that there is another variable which has another value. On the third line, it understands that there is a variable which contains text inside of it, that is a string, and it also sees on line 4 that there is another variable with different piece of text, with different string. As it goes down, it sees that the user wants my variable to be increased by the integer of 2 for some reason, and then he wants to invoke a function that is going to use some text to print out some text onto the console. And by saying some text, we really mean its value. So as soon as I press Ctrl E, everything will happen from top to bottom. Your program will print out Igor is. Here it goes. Now if I want to print out two lines of code next to each other, I have to do an operation called concatenation. That is when you add one string to another one. For that, we're gonna say some text plus some other text inside of the brackets for the print. That says, grab a value of this variable and to it add a value of this variable. Because it detects that those things contain strings, it's going to do a concatenation instead of addition. And as it prints out, it's going to say Igor is an ace. Also, since we have a space in here, when we add our lines, is and and are gonna be two separate words. Have a look at this. If we clear our window by pressing Ctrl D, returning back to our script, we can press Ctrl E, and it will say Igor is an ace. On the other hand, if we would remove our space from here and press Ctrl E, you can see that there is a problem because we removed our space from inside of our string. So let's return it back. This was very easy so far. Inside of code, you can use different functions. That is, you can have different instructions, 3 lines like this, and you can do a little check on the line that is above it. For example, right here. You can check if some condition is met, if it's true or false, and if it's true, you're going to execute those 3 black lines. If it's false, you're going to fall out in here and continue executing your code downwards. But those 3 black lines that depend on this check right here, that's a horrible arrow, those 3 lines depend on this check, little check in here, and if it fails, if condition is not met, those 3 lines of code will be omitted and we will continue from here, downwards. It's called an if statement. Let's get rid of print, and let's actually get rid of my variable as well, because we won't be requiring it. After we declared our variables and their values, let's say if our second var is exactly equal to 5, then, and after this you have to specify your code downwards in here. Your code begins as soon as you put round brackets like this in here, and it ends as soon as you put round brackets like this, in closing brackets. Let's give ourselves some space. So let's put enter a few times, and put in closing bracket. So all of the code inside of here will be depending on whether this check was true or not. This double equal sign means that we're checking for equality. If we would put this, we would say second var becomes equal to 5, and it would be always true, because it performed an action. However, if you want to check the values of the variables, you gotta put double equal sign, which is called exactly equal to, which is an operator, meaning that we want to check if the left side is exactly equal to the right side. And if it's true, then we will do this. If it's false, then everything in here will be omitted, and we'll continue reading the instructions further on, if there are any. So let's say if our second var has a value of 5, let's print out some text and concatenate on top of that some other text variable. Don't forget to close your brackets and put a semicolon right here. You don't need to put semicolon at your if statements, because obviously if you finish your colon right here, it wouldn't make sense, since those lines of code depend on if statement. That's why after such checks you don't put semicolon. You only put them at short instructions, such as those ones, do something. So in this case we want to print Igor is an ace, using those 2 variables, and let's try this now. Because our second var has a value of 5 by default, this check will be met as true, and as computer progresses down, it sees that it needs to execute this piece of code inside, so it will print out in our debug window, Igor is an ace. If you want to add something else on top of that, for example some kind of string which is not tied to any kind of variable, but just a random string, you can also put plus, double quotation marks, and say for example, and he likes chocolate. Don't forget to close your double quotation marks. And now we have 2 variables carrying the string, being concatenated next to each other, and we also concatenate another string on top of them. Remember that this piece of code is going to be executed because our second var is equal to 5 by default. Let's press Ctrl E to evaluate the program, and I actually had to double refresh those 2 windows. That is, double clear them with Ctrl D, because sometimes it doesn't respond properly. But in this case, it printed out Igor is an ace and he likes chocolate, and as you can see, we are lacking a space in here. So if in our string we add space after the opening quotation mark, everything is going to be fine. Let's double clear this, go into our script, press Ctrl E, press Ctrl D once again, and evaluate the script a second time. Now the problem is gone. You can also make a complementary statement. For example, if your if check fails, you can say else, and then within the brackets you can specify the piece of code that you want to do in case this if that is above our else fails. Let's say print, nah, just kidding, semicolon to end this instruction. Although semicolons are not really required in 3ds Max, but just to get used to them, let's start putting them here. Just to make us fail this first if statement, let's assign by default to our second var a value of 2. As the program is executed, it picks up that those three values exist. It's going to check if second var is exactly 5 and it's going to say no, because I got the value of a var at current state being equal to 2. 2 is not equal to 5, so we fall out from here and we are forced to do else. We got to do this, since our if failed. And we're going to say, nah, just kidding. Let's press Ctrl E and evaluate it. And you can see that straight away 2 was not equal to 5, so it produced not just kidding message. Let's get rid of those lines of code, and I want to explain to you one more tool. Sometimes you have different instructions in your code. You might have, for example, 3 lines of code, and you can do a little check over here. You can make it act as follows. As long as it's going to be true, whatever is specified inside of the instructions is going to be carried out over and over again until the statement becomes false. If it's false, we're not going to bother about executing those 3 lines once again. We're just going to fall out from here and continue doing whatever we want to. This statement, which loops until the check becomes false, is called a while statement. For example, you can say while and open the brackets and close them to specify your condition, just like an if. While second var is greater than or equal to, let's say 10, and then on another line, let's put our instructions within those brackets. If you would want to say less than or equal to, you would simply put less than before your equals to sign. If you want to check if the value on the left is exactly equal to 10, you would put double equals. If you want to check that it's not equal to 10, you would put an exclamation mark and then equals to. So that means not equal to. But in our case, we want to make it greater than or equal to 10. Do some piece of code in here. By default, let's make our variable to be greater, for example, 20. The way it's going to work once again is it's going to do a check in here to see if this is true. And if it's true, it's going to perform whatever is in here and then return back to the check. If it's once again true, it will do the instruction a second time. And so on, until it becomes false. You don't want to crash your program, and you can test it now. It's going to probably crash or throw you an error into here. You have to do something with this variable inside of the while loop. Because by default, it's going to be 20, and if you do something like, for example, print in here, it's going to be printing indefinitely, because your second var will stay as 20 and it's always going to be greater than 10. That's why we're going to do some function, for example, print a string saying we are inside of the while loop. Put semicolon to indicate that you end the instruction on this line. And then on another line, let's say second var becomes equal to second var minus 1, semicolon. Or to make it even simpler, you can put simply minus equals to 1. That's just going to say subtract 1 from whatever value you have in your second var. If you want to subtract like 2, put a 2 in here. Also, you can say plus equals to, and in the brackets you can say, for example, minus 1. That's just going to be adding a negative number to whatever you have over here. So let's say we're just going to be adding every time, every iteration of our loop, we're going to be adding to our second var a negative value of 1, so effectively subtracting 1 every time. And as soon as it reaches 9, the check will no longer be valid, so we'll continue doing whatever we have down there. It's going to print out this line 11 times. Let's press Ctrl E and evaluate our script. And in fact, I'm sorry, because you gotta use, instead of then, which you use with if apparently, with while you have to use do keyword. That's exactly what this error stated, so you can actually learn on my mistakes, and if this error is thrown at you, you know what to do. The error occurs at line 5, that is somewhere here, is exactly where our while happens, and it says that it is expected to see do, but instead it saw then, which it didn't know what to do with, because then is usually associated with if. So stick do with while. While second var is greater or equal to 10, do the following things. Let's press Ctrl E and evaluate our program. As you can see, we got several of the strings printed out. That is exactly 11, just like predicted before. Then you can see that it got terminated. The while loop was no longer accessible because the condition was not met. So it says that we fell out from it, which is a nice thing. We don't want to stay there forever. Otherwise, this will freeze the whole process and the whole program. This type of loop gives us a very nice potential to reduce the sizes of the boxes, for example, or do whatever we want with parameters. We can reduce, increase them, cause another loops while some condition is met. For example, we can say while our lovely selection, which is denoted by the $sign, dot height, and dot just stands for a next level. For example, if I have an apple, that's a very nice apple, but we can represent this object as having 2 parameters. That is a stick that is sticking out from the apple, equals to 1 because there is one stick, and there is also a leaf inside of the apple object, which is also a single piece. And of course there should be semicolons right here. There is also some type of object, for example an apple, which is of some type, but we'll go over this later on. There is an object and it contains two parameters, each of which has a value. If we have our apple selected, we can refer to it as a selection dot, and let's say we want to increase the number of leaves on the selection by 2. We would say $, which is our selection and stands for the selected object, dot leaf, and now we're suddenly looking at this particular variable which sits in this particular apple. And let's say plus equals to 2. This apple will have now 3 leaves. On the other hand, if there would be a size variable which would be controlling the size of an apple, for example like 2.5, which is a float value, we could say $dot size becomes equal to 0.1 semicolon here and here. We would suddenly get a very small tiny apple with 3 leaves. So you got the idea. You can access those particular variables belonging to this particular object via saying dot. Let's create a box with a height of 200, and just for the sake of it, let's go into customize, unit setup, and let's switch to generic units because it's going to be much easier for us. Let's make height to be somewhere 100, for example. So now we have this box which has a name box 001, and obviously if we have it selected, it's going to be our selection. This box has a parameter called height, width, length, and we can say while our selection's height is greater than 40, do the following thing. Open brackets and close them to signify that computer has to do something within those brackets. Let's access this height on our selection and decrease it by 30. To be fair, the correct way of referencing this variable would be to use a capital H, because its name begins with capital H right here. Nevertheless, it's still going to work, but let's just follow the proper convention. Let's put capitals in here. So what it will do is it will see that it has some of the variables declared on the top, which contain some values, but we aren't going to be using any of them, so we can actually get rid of them or keep them there, but they're taking space, so let's remove them. Because our particular selection contains a box which has a variable height being set to 100, it's going to do one check of while the height of our selection is 100, which is obviously greater than 40, so it will do this. It will decrease the height by 30, and let's actually put like 35 in here. It will decrease the height by 35, and now the value will be 65 on the height. That is after the first iteration of while. It's going to return back to the beginning of while and it's going to say, is the height of my selection greater than 40? Since it is 65, it is still greater than 40, so it will do the same set of instructions a second time, reducing the height even more by 35 once again. Now, as you can see, 30 is less than 40, so this condition won't be met, and it will say, okay, I'm not doing anything else what it's saying, I'm just gonna continue from here. And from there it's just empty space, so our program ends. But this will have a consequence in the real world. Because we were reducing our height variable, our box will shrink down in size. This will happen in a blink of an eye, because this whole check happens very quickly. We can actually capture this transition by just entering auto key or pressing N. Not a very good idea while writing the script, of course. So let's enter auto key in here, scroll down to the 100th frame, and with our box selected, we can evaluate our script. Let's press Ctrl E, and you can see that our box was shrunken down. You can see that it planted 2 keys because it detected a change. Since there was no key before the change, it planted 1 automatically at 0. If you right click on those keys, you will see what it stands for. It stands for box height. If you have a compound key, for example the one that stands for rotation and movement, etc., you can actually delete several of the parameters, or altogether if you want to. If you scroll backwards, you will see that the change was actually captured from frame 0 to frame 100. And if we press play, you will see that the gradual change occurs here. Also, the size of the box decreases. The change happens very smoothly. It accelerates at the beginning and then decelerates at the end. To change this, we can go into here, just like explained in previous tutorial, and maybe let's detach it and expand the window slightly. Within our selection, we can go down to box, and you can see that the object is highlighted with blue. So obviously it contains some kind of change. Let's open it up, and we see that the highlight is on the height. If we select our height, you will see that as soon as we switch to something else, the height is no longer highlighted, but the object modifier is still highlighted forever. Also, you will notice that the little icon right here differs slightly because it has a blue curve inside. If we select our height, you can see that indeed our height's value decreases as the time progresses, but it does so at an increasing rate first, and then it decelerates. If you want a straight line without acceleration, Then, just like explained before, you have to select your two keys and set the tangents to linear. Or, if you want to do it manually, you can actually go to set tangents to spline, then press shift and click on the little endings of the tangents that are going towards the point. Press shift and drag upwards or downwards to alter this particular side of the point. For example, you can have a very quick acceleration straight away burst, which then decelerates, and then a very small change happens as the time progresses further on. On the other hand, you can make it very slow at the beginning, but then a quick burst downwards. And actually, let's grab a tangent of this one, press shift, and alter it like this. Of course, middle mouse button allows you to pan across this graph editor. And if you press Ctrl Shift Alt, you can actually scale it with middle mouse button, and those three buttons pressed, you can actually scale it in all two directions, excuse me. So it's going to be a slow decrease, and then a short burst, and the box will become very small or squeezed in a very quick time. Let's check this out. You can either drag this slider, or press play, or press question mark next to the right shift on your keyboard to play. Boom! As you can see, at the end, it flipped to the first key, so you didn't see the change, but it happened very quickly. You can also add a key. For example, right-click on the curve, add keys, and then you can stick a key whenever you want, like two keys, for example, here and here. We want to move keys once again. Let's select this one, bring it down, bring it up, and actually let's add one more key in here. Switch to move keys, bring this one down. Let's bring this one up. I really want to achieve the same value on the same keyframe instead of this one right here. So I'm going to press shift to copy my key, and I'm going to hold Ctrl to lock it in the direction I'm going, that is the horizontal one. And that way I'm sure that this value is exactly the same as the one in here. So we're going to return back to the original place. As the time will progress further, our height will decrease at an increasing rate, then at a decreasing rate. It will increase its height at an increasing rate, then increase it at a decreasing rate. Well, basically, if you're good with derivatives and second derivatives, etc., you are pretty good at finding local minimum, local maximum, the way it accelerates and decelerates. So it's going to lower down the variable right here, raise the variable, lower it once again, and then raise it back to its original state. Then the counter will jump back to the beginning, and the whole thing will happen once again. By the way, let's turn off our auto key because we don't require it. Perhaps everything will happen very quickly, but let's try to spot it. As you can see, everything happens as predicted. Also with the tangents, if you select those tangents, for example over here on those 3 points, if you set them to linear, right here is going to be a smooth curve, but then this one is going to be linear, and you can notice the difference if I show it to you. So smooth change, and then abrupt change. Boom, boom, boom. Smooth change, boom, boom, boom. If you select the point right here and set the tangents to spline, you now have two lines, one pointing downwards like this, another one pointing straight away to another vertex. If you press shift, you will alter one side, and if you press shift on the other side and click the black line, you'll be altering another side. Also, you can go into tangents and lock the tangents. Now if you're going to be moving one of the side of the tangents, the other side will be adjusting accordingly. So watch out for that. However, with the lock tangents, if you press shift, you're going to be able to unlock them temporarily, and you can alter one of the sides. Then remove the shift, and since it's locked, you once again will be altering both sides. If you can hopefully see it on the right side, if it's clear enough. Basically changing the slopes and the rate of a change of a variable. Right now we're clearly working on the box, on its object modifier, and on its obviously height parameter. So really quickly using script, we've done a little change in the variable that we actually managed to animate and capture the change. And for example, if you have different objects, such as a line for example, and that's a horrible color on the green, so let's change it to a blue one. So we got line, a box, and let's say a cylinder. Obviously, if we draw our selection will now contain 3 objects. If we go to our Max script, and let's open the old one that I closed just a second ago, we can say for each object, and let's refer to it as a temporary variable, such as O, or anything like A, for example. For each object that we're referring to via the variable A, in our selection, do the following thing. Let's say A dot height minus equals 20, semicolon to end the instruction. Now, there are a few of the problems that might occur. In fact, 2 of them. However, you just have to understand that we use this A to reference a particular variable. For example, our selection has 3 objects, a cylinder, a box, and then a line. We don't know in which order they are positioned in our selection. So we will first look at this object, which we will be referencing by letter A. Then we're going to look at this object within our selection, which is also going to be referenced by letter A. And then we're going to look at the line, for example, which is also going to be referenced by letter A, by the variable A to be precise. We're going to say A, and by A we really mean the object, the current one that we're looking at. Its height should be reduced by 20. The thing is, let's say that our box's height is already 10. We're not doing any kind of check to see if the height can actually take this reduction, because it might become negative. And what do we do with negative height? Instead, we have to do a check to see first if we can actually reduce it down to this amount. So inside of this instruction that is done for every object in our selection, inside of it, let's say if our object that we're currently looking at, its height is greater than 20, or 21 to be safe, then, and then let's on the new line open the brackets for the if and close the brackets for the if. Then we can actually afford to do something. Otherwise, just fall out from this thing, skip our reduction of height, and continue doing whatever we did. A second problem is that, let's say, for some reason, an object within your scene intends to take a value inside of height to be as a text for some strange reason, but let's assume it does. If you try to stick a number variable, it's going to throw an error at you because it was expecting to get a text input. For example, a cylinder's height expects to get a number such as float, a number which contains decimal, and the same thing happens for the box. However, for some reason, a line has a height variable which, strangely enough, uses this variable to store its own name or some kind of value with text. Since it's in our selection, it's a valid member, and while going through this for each object in our selection, eventually we're going to arrive at the line and say, okay, access the height parameter of the line, which actually exists, so we are okay. If it doesn't exist, then it's just going to fall out. But we access the height and we try to stick a variable in here. Let's say we don't do any kind of check. We just say for each object in our selection, do the following instruction: decrease the height by 20. In this case, it's going to attempt to do some kind of numeric operation on a string, so it's going to throw an error at us. In such case, we can tell Max to do the following operation. We can say try, and then in the brackets, do some kind of operation inside of here, and then if it fails, catch. And we can just put some kind of operation that we want to perform if this attempt to do something failed. If we don't want to put anything, we just put empty brackets. Let's put semicolon to end the line. So we're going to try to attempt to change the height by -20 and catch in the case if it doesn't work out. As you can see, right now my selection was just this box. Having selected everything, if I execute the script once again, I will get an error. Because we gotta try for the height once again in here. Try this thing. And if it fails, catch. Obviously the line doesn't have a height, so it will throw an error. If we try to access the height, try to perform something inside of here, and it fails, then we're not gonna stress about this, we're just gonna continue our looping. We press Ctrl E, and both of our objects except for the line get decreased in value. If we try to do this once again, they're going to be decreased once again. And if we checked our height on the objects, their height is 41. So we can actually accept one more change. After this, the height becomes too small. We're going to try. This is fine. We can access everything in here, but the condition will no longer be met because our height is less than 20, obviously, for them. So we'll just continue from here. Our try finishes, and we continue from here because our try on overall succeeded for those two objects. For the line, of course, it will fail, so it will just catch and do nothing and continue further on, doing this for each object inside of selection. So if we attempt to do this once again, for the cylinder, it actually did it. And if we roll back, it was actually 21, so we could afford one more change. But if I attempt to do this once again, it will no longer be able to execute this thing. Let's say if it's greater than 0 and see what comes out. The height actually becomes negative, which is an interesting fact. And I'm not really sure if the object gets inverted or the normals get inverted, if you have to go into convert to editable poly and then select the whole object, flip its polygons. But apparently it's okay. I think it just gets flipped. Even its local axes are staying the same way with the negative height. But you gotta watch out for such things because sometimes a division by 0 might occur or whatever. So you're already familiar with for each, that is for each object in this thing. And it's actually reminding the loops which have the different meaning slightly in more sophisticated languages called for. But this one is for each. You also know while something is true, execute the following code over and over again until this is no longer true. You already know about strings and text. You clearly know about variables, at least to some degree, very small ones, very small one for now to be fair, but you can already use them. You already know how to decrease objects, do a check, and you also know about try and catch. Don't forget about semicolons, and you're good to go. You also know how to iterate through the selection with the for each. You know about how to reference different variables because there might be a variable inside a variable. Then, for example, you would be saying a height dot some other variable that sits inside of the height, that is a subvariable of a height variable. And of course, if it doesn't exist, you gotta take this into account and put this into a bracket saying try. If this is not acceptable, then it's just gonna fall out at catch and do some instructions or just catch empty brackets and continue further on.
Now when you got two separate chains, that is the IK and the FK, let's actually make use of our IK and throw a formula into it, the IK solver. To do this, let's temporarily isolate the yellow chain from the rest, so that we can focus on it easier. Let's double click on the yellow chain's main parent, press Alt Q or click on this light bulb to isolate the selection. Because our wrist is linked to the bone, it's actually considered part of the system, so double clicking on the main parent actually selects everything as well as the wrist helper. With our wrist selected, let's go into Animation, IK Solvers, HI Solver, and click on the main parent. We could have done it the other way, and the IK goal would still be placed over here, because it's placed at the lowest member of the hierarchy. Of course, by manipulating this goal, the bone will deform, but I think the goal is too big, so let's reduce its size. And it can be done by going into the fourth panel, the Motion, IK Display Options. You can actually turn it off, but I don't advise you right now. For now, let's reduce the size down to 14, maybe 10. You cannot change the color of the IK solver, so don't attempt to do it. As you could have guessed, we're gonna be manipulating our arm by adjusting the IK chain, then weighing the chain of our main skeleton to follow the one with our IK solver. To be fair, IK solver and the goal make it possible to manipulate the arm in the easiest way, because all you need to do is to reposition the goal, and the bone will adjust itself. However, there is one more setting to consider, that is the swivel angle, just to change the angle at which the elbow is raised or lowered. This can be done via the manager, the reaction manager, or parameter wiring, but we will do this as we create custom controllers later on for our chains. As well as that, there is also one option to consider, that is from which member of the chain a rotation occurs. By default it's start joint. However, you can always set it to be IK goal, and then the rotation at this area is going to be considered. This last setting might be useful if you have more than one joint in the middle. We don't want this bone to be here, so let's roll back our actions so that it's positioned as it was, straight. You want to rename this goal to signify that it's an IK goal, not just an IK chain member, as a mutant left arm IK goal. Repeat the procedure for the right arm, but right now we need to exit the isolate section mode to be able to focus on the other side. Repeat the procedure. Now we got two manipulators, that is two IK goals by which we can control the IK chains, which represent the IK side of our arm. Before you do anything else, make sure to select your bones by pressing Ctrl A with your mesh frozen, so in my case the head wasn't, I'm going to deselect it. Press Alt, right click, and then freeze transforms. Press OK. What this done is it created another controller for each of the bones, and we've been discussing controllers in the previous tutorial thoroughly, so you're pretty familiar with it. If you select each of the bones, you will see that now it has two controllers for position. It has the 0 position XYZ, that is the position that we can alter, and it also got a new frozen position of type Bezier. This controller right here just stores the information about where to relocate the bone if we want to return it back to the original position, the original state. The same thing happened for rotation as well. If we open it up, you'll see that there is a frozen rotation of type Euler, and there is also 0 XYZ Euler. In this case, any kind of animations, manipulations within the scene will all go for 0 Euler XYZ. If we select our bones and start tweaking them, we can always press Ctrl A, Alt right click, transform to 0, or rotation to 0 if you've been rotating. As you remember, transform is higher than the rotation, so setting transform to 0 will zero out both rotation and position. As well as that, if you try to freeze the transform and then continue linking the bones between each other with this tool, or doing any kind of parameter wiring, if you suddenly decide to transform back to 0, your bones will be relocated in an incorrect manner. So make sure that after linkage, you freeze transforms on those objects once again, because there shouldn't have been any kind of linkage after the transform has occurred. Usually it's done at the very end, but make sure to do it after any kind of addition such as linkage. Make sure to freeze the transforms. Having the IK goal, we now established a relation between the main parent and the wrist of the IK goal. To be fair, the red and the yellow squares should not be visible, because we won't be ever selecting them to manipulate the arm. If anything, we would be selecting our IK goal. However, let's make it more accessible, since the IK goal is too small or too narrow to click on it. Let's create a custom goal. To do this, let's go into Create, Shapes, and let's select Circle. Change this color to yellow, and we're making a controller, something to drag our IK goal, and also something easy enough to click. Let's right click and convert to editable spline. Avoid any kind of scaling on the object. You can only afford it if you go into the spline or vertex mode on a sub-object level. That's the only time you can scale, since otherwise your actions will void a transform matrix for this object, and any kind of linkage will be distorting any other objects later on. You can always reset X-form, but that's not really the way to do it. It's much easier to go into editable spline and then readjust the size of this spline in there. If you're experiencing some difficulties, try fiddling with local and different positions of pivot points, but something of that size is going to be just enough. From the spline editable mode, that is the third one, I'm going to press E and shift rotate from the center to create a copy. Rename this one as Mutant Left IK Controller. Click Align, then force it to be aligned with the IK goal. Pivot to pivot. This works fine because the pivot point for our circle was in the center, and since we were rotating and duplicating around the center, the pivot point stays exactly in the middle of the object, that is our spline. Make sure that its color is yellow, then go ahead and link your IK goal to this newly created spline. It's very easy now to manipulate your arm just by selecting this goal and altering the position. But first of all, we need to weigh the green bone to follow the red one and the yellow one. With that done, make sure to select your frontal part of the arm, alt-right click and freeze the transforms. With that, you can simply duplicate your controller to the right side and then align it to the goal. Make sure to rename it as well. Don't forget to link the IK goal to its new controller, and you're good to go. Also make sure to freeze the transforms on the frontal part of this arm. Save your work as well. 3ds Max uses several of the constraints that can be accessed by going into animation constraints, and you can see that there are about 6 or 7 constraints that can be used by you. Having applied this to an object, it's going to be added to the motion panel. We'll be telling the object how to behave in relation to something else. That is, we need to infuse our green chain with our custom constraints, and to be fair, the orientation constraint. Since there are 3 green bones right here that we want to constrain, there are 3 yellow bones and 3 red ones. Each bone has its own rotation. By raising the yellow chain upwards, we're changing the rotation of this object. By lowering the red chain downwards, the rotation of the main parent for the red chain is going to be changed. So we want to weigh each of the bones, for example the green main parent, to be weighed between the yellow main parent's rotation and the red main parent's rotation. To do this, let's select our green main parent of the arm, then go into Animation, Constraints, Orientation Constraint. With this you get a dotted line signifying that you have to click on something else to accept the change. Let's pick the red main parent of the FK chain. As an alternative, you could have applied this constraint via a more professional way. If I roll back my actions, you could have once again selected your green main parent to which we are applying this constraint, switch to the motion panel, assign controller, open up rotation, click on Euler XYZ, that is the controller that's going to be animated as soon as we do any kind of change within our character, as opposed to frozen rotation, which is used to return the bone to its original state. Pick Euler XYZ and assign a controller called Orientation Constraint. You can also assign Orientation Constraint controller for the main rotation, but that will void and consume any kind of frozen rotations. So you only want to do it on the sub-rotation level. With that said, if you go from position to rotation or from scale to rotation, this list will explain what kind of controllers are available for altering. Right now we need to pick Orientation Constraint. With that, let's switch to Orientation Constraint Rollout. Here we can pick as many targets as we want to direct our bone. And we want to pick both of the yellow main parent and the red main parent. When adding targets, let's add the red target first and then the yellow target, because we want to preserve the order where FK is the first in the list and the IK is the last. Make sure to right click to exit orientation target. Repeat the procedure for all other bones, that is the forearm and the wrist bone. Don't confuse it with palm bone. Forearm, wrist, and the main parent. After that, do the same thing for the other arm. As you can see, our arm became much cleverer now. If we readjust this IK controller to be somewhere here, for example, you can see that the green chain is pulled by the yellow chain in the same amount as by the red one. This relation is controlled by this weight parameter. It is specific to each bone. With the IK parameter selected, that's going to favor it in the 100% force. But if we switch to FK, you can see that its weight is still 50. So let's reduce it down to 0.
only then the bone will be favoring IK completely. We can repeat the procedure for other two bones. However, this is very challenging and exhausting. You don't want to bother your animator with going into technicalities and strange parameters because he might get lost and do something bad to the rig. You want to make it very obvious and straight away for him, that is, take the most essential controls and stick them out on some kind of attribute or custom attribute that we've discussed in previous tutorial, or use a script to create a custom panel from which you can control the bones and their relations easier. Now when we have a control for our IK chain, let's also throw several of the controls for the FK chain. In this area we're going to have more controls required, because by default forward kinematics is more flexible than the IK. We have to alter each of the joints, but animator wouldn't want to click directly on the bone and twist it. There should be something similar to the object controlling the IK, for example. Let's follow our convention and create a circle. However, this time let's achieve another look. Let's convert it to editable spline, and from the selection, make sure that you are in spline, press Ctrl A to select everything, press Shift and duplicate your spline upwards, like so, and do this once again. Go into pivot point, affect pivot only, center to object. You don't have to do reset X form or anything, because even if you're scaling object, you're doing this on a sub-object level. Directly scaling like this, once again, wouldn't be acceptable. You have to go into parameters, into modifiers, and from editable spline select and do this on a sub-object level. That's okay. This is not. Rename this one to Mutant Left Arm FK Controller. Align it with the rear end of the arm in position and orientation. Press OK. And if you see that, for example, your controller twisted like this, but now its axes are obviously aligned, to rotate it back, you have to go into the spline mode, and then in the spline mode from the center, you'll have to rotate your object by 90 degrees. That way, the axis will stay the same, and you'll be able to rotate your geometry visibly. In my case, it's all okay, so I'm going to leave my controller like this, and notice that it doesn't emphasize 3 axes all around. However, this joint can be raised upwards like this, can also be tilted like so, and can be rotated forwards and backwards. We have to emphasize this, so let's go into spline mode, select everything, and using the transform coordinate center and the parent representation of the axis, let's rotate it by 90 degrees. If we would be doing this from local, that wouldn't give us the correct pivot point location. It wouldn't be center. Now we've emphasized that the rotation can occur in all 3 directions. And with the triple line, we're signifying that this is an FK rotation controller. Perhaps it's too big, so let's go into spline mode, select everything. Using the transform coordinate center, let's reduce it down. After that, let's press Shift and duplicate the object. Align it with the rear end of the forearm bone, position and orientation, press OK. Go into the spline mode, and our forearm can only rotate forwards and backwards like this. It cannot rotate upwards and downwards. And in our case, in our skeleton, we can't twist it like this. The whole of the twist is going to happen from the wrist bone, supported by the roll bones, not from this area. So let's get rid of the 2 axes emphasized in here. Let's duplicate this once again, and now align it with the wrist. Actually, this one does rotate in all 3 axes, so let's get rid of this controller, and duplicate this one, the first one, into here. Align it with the wrist, position and orientation. Make sure to rename it correctly, get rid of the ending, and also change the middle name to wrist in this case. And for our forearm controller, get rid of the ending as well, and add a forearm controller. If you recall, we linked our IK goal to the controller. We didn't link any kind of bones to the controller. Right here, each of the bones is linked to its parent. And if we try to link it to the controller, that's going to break the relation between the bones. Since each of those controllers is a rotation controller, it's not used for positioning or anything. We can use orientation controller just like before. Select each of the bones, go into animation, constraints, orientation constraint, and for the main parent of the FK chain, put the target to its appropriate controller. Repeat the procedure for other 2 bones, that is the forearm bone and the wrist bone. Because you have this dotted line with which you pick the targets, there's already going to be one for you in here. In this case, since there is only one, the weight doesn't really matter, as long as it's greater than 0. Now by rotating this controller, you're able to rotate the chain, kind of. As you can see, because we didn't rotate any kind of other controllers, the direction of other 2 bones is kept preserved, because the direction of the controllers on which they depend is still unchanged. It's only this one who is pointing here, so its bone is pointed over here. This is the carrying bone. If we rotate it, we want to affect other 2 bones as well, to be moved in a straight line. For that we have to create a hierarchy, much like within the bones, by linking this controller to this one and that one to here. So having the bones constrained to each of their controllers, let's now link the controllers between each other. The wrist controller to the forearm controller, and the forearm controller to the main parent's controller. Now, as we rotate this one, it's going to bring the rest with it in this intricate structure. Let's say if you wanted to add a controller, the orientation controller for this bone, to be affected by the controller in here. However, instead, let's say you did it vice versa. So now the orientation of the wrist matters for this controller, and you need to reverse it. First of all, let's get rid of the orientation constraint from this one, from the controller, by going into PRS parameters, rotation, picking our incorrect orientation controller, and clicking delete. That's also going to remove it from here. And now we can switch for our wrist, go into animation, constraints, orientation constraint, and then click on the wrist controller. Select your 3 FK controllers, then freeze their transforms before proceeding. Now if you change the position of your bones, you can simply select your controllers, Alt right click, transform to 0. Exit isolation mode. Selecting our yellow IK controller, or the red one, I think that they're overlapping too much, so let's reduce their size. To do this we have to go into the modify panel once again, since we can't scale them directly. Go to the spline object mode, from the parent transform coordinate center, let's scale down the selected spline. As well as that for the IK, let's go into the spline object mode, select everything, and actually rotate it by 45 degrees, so that none of the controls are on each other's ways. Let's also tilt it like this. As you can see, there has been a snap, probably when I was aligning my controllers and freezing the transforms. So now the bone and the geometry is looking upwards. It may not have been the case with you, but if this happened to you, this is probably because our green wrist bone is grabbing the orientation from the red wrist FK bone. And in fact, we have to turn this wrist FK bone in opposite direction by the controller and freeze it once again so that the geometry is safe. Selecting our green chain's wrist, we can go into motion, rotation orientation constraint, reduce the weight of the IK down to 0, and you can see that actually it has been flipped 180 degrees. Now our green wrist is following the FK wrist completely. Having selected our FK controller for the wrist, let's apply a rotation of 180 degrees. Also, let's Alt right click, freeze the transform. Now everything is okay. Let's click on our green wrist bone, go into rotation, orientation constraint, and check if everything is good as we increase the weight for the IK chain. Everything is fine. If we go into local representation of the axis position from the pivot point, and compare the axis of the IK and the FK controllers, they are looking in 2 different opposite ways. This is bad, and you'll understand later on why. For now, we need to ensure that the IK controller is faced in the same direction as the FK's wrist controller. For our IK controller, let's go into Align and align it to our FK wrist controller. Position and orientation. This didn't do anything on the arm, since the rotation doesn't really matter for the IK chain. But now we have achieved the following thing. Our axes for the IK controller are aligned with the axis of the FK controller. And this is a good thing. Once again, we only care about the wrist area, since we only have one IK controller in this area. Repeat the procedure for the other arm. You need to create 3 of the FK controllers, put orientation constraints of their respectful bones to follow those controllers, and then ensure that you link your controllers in a nice hierarchy. Wrist controller to forearm controller, and the forearm controller to the arm controller. Also make sure that you emphasize the axes in which they can rotate. For example, this shoulder controller can rotate in all 3 axes, but this forearm can only rotate backwards and forwards. Make sure to freeze the transforms for your controller to fuse them in the right position. If this caused a snap in the wrist area, make sure to rotate backwards your FK controller to free this geometry from its deformation, and then align your IK controller on the wrist to the FK controller on the wrist. Just to remind you, IK is used for positioning mostly, and FK is the set of controls for a precise rotation on all 3 joints. Let's select our bones and controllers. With Alt right click, let's transform back to 0. Before we start throwing any kind of custom attributes or adding options for tweaking the parameters of our arm, let's return back to Max Script, since I want to show you how you can create those extra panels that can be placed wherever you want. To create a custom panel that's going to be floating in the air, we need to create its layout first. For that, we can go into Tools, New Rollout. That's a window for creating your own rollout. You can change the size like this, and if you want to have a snapping grid to make sure that you position everything in relation and precisely,
You can turn it on right here. Then whatever you do, it's going to be snapping to those points on the grid. That way you can achieve round and precise numbers in the spaces between the objects. You can throw anything you want on this rollout, such as buttons, spinners, drop-down lists, checkbox, entry lists for names, whatever. Let's reduce its size down to this amount. We don't need it to be too big. I want to stick this rollout into the parameters of the controllers, for example into an extra modifier, an attribute holder that we've discussed in previous tutorial. But first of all, let's come out with the layout of the modifier right here. We can use this one just so that we can access the weight options easier. So first is controlling the weight between the FK, IK, and the second option is to be able to bring the IK chain towards the FK, that is align it, or vice versa. That way, as we animate the character, if we reposition this IK chain, for example here, then we decide that we want to blend this green chain completely towards the FK. If we do this, the green chain will come back down to the red part. If we don't want to move this green bone backwards, we will have to align somehow the red chain to the yellow one, so that we can animate the red chain from there. A very hard task would be to animate it by hand to achieve the proper positioning, but that's a very complicated task, and you would want to simplify it by just pressing one button so that the bones do the work by themselves and align each other to the required position just on the click of a button. And that's what we're creating our buttons for. In our rollout editor, let's create a new button. Let's make it small and bring it somewhere to top. In the caption, that is the visible name, let's call it FK greater than IK. That is, we align all the bones from the FK chain with the bones of the IK one. We also need a code name, that is the one that we're going to be using in our script. It should be something simple, so let's call it FK_IK. By altering those parameters, you're going to be moving your button up and down, changing the scale of the button, or adding tooltips. For the tooltip, let's put align the bones of the FK chain with the bones from the IK chain. With this button selected, let's press Ctrl C and then Ctrl V to paste it, and paste it somewhere on the other end right here. This one should be called IK to FK, and its true script name should be called IK_FK. Let's also add a spinner. The type is float so that we can afford to increment the numbers by digits, and you can't really change the height of a spinner, only the width. So let's make it not too long. At the end we only need to see values from 1 to 100. Let's also add a slider. Let's make it long to take the length from the left button to the right one. Rename it to weight. The range should be from 1 to 100, type float, and default should be 50. You can make it vertical if you want to, but in this case, horizontal looks better. We also want to add a group box, just to position all of those things inside of one group box. For its name, let's rename the caption, the visible name, to something more sensible, FK and IK blending, and the script name to FK_IK group. Let's just double check that we have everything called correctly. For example, the slider isn't called properly. It has the caption set as weight, but the name is still incorrect. Let's make it SL_FK_IK. For the spinner, let's call it SP_FK_IK. Our button is called FK_IK. Next one, IK_FK. And we are on the safe side. Let's reduce the size of the rollout downwards to somewhere like this. We can now go into File, Save, and this pasted all of the clean settings for our rollout into this script. As you can see, all of the controls have their parameters set as we declared in our editor window, and if you want to, you can actually adjust them right here. Here are our buttons, spinner and slider, and the group box that unites them. To follow the convention, since on each new line we're declaring a new variable or new set of parameters, after it let's put semicolon just to follow the convention, although it's not required in Mac's script. With that we are indicating that we are ending our instruction for this line, and the new line begins. We will be tying the parameters of spinner and slider later on, but for now let's focus on the buttons, because those ones aren't done with the parameter wiring or reaction wiring manager. It has to be done with script. Having declared those buttons, outside of our rollout, let's specify what kind of action should occur when this button FK_IK is pressed. We're gonna say on FK_IK, that is our button, do the following set of instructions. Open brackets and close them to specify the action that's gonna be belonging to those brackets. On our button pressed, do the following thing. Since we want to align FK to IK, that is the FK rotation chain to the IK position chain, we need to align those 3 FK controllers to 3 of the IK bones.
since there is only one IK controller, and it's not going to be enough to align other 3 FK controllers. However, we can use the IK bones. We need to throw 3 of the try statements in here, because if we screw up and don't do something correctly, we don't want Max to freak out. So 3 of the try lines will go into here. On the first one, let's say try, and straight away let's put catch. Catch should be empty, semicolon at the end of the line. Inside of try, we need to put our instructions. Let's duplicate this code into 3 lines. And on the first one, we're going to search for the ARM FK control and make its transform equal to the ARM IK bone transform. For that, let's say grab a selection, and in here we're going to specify the name of the object that should be selected within the single quotation marks. Let's actually unhide our controllers. Select the FK controller and duplicate its name, paste it into here. So that's mutant left ARM FK controller. That's our selection. We want to access its transform, so let's put dot transform. As you already know from tutorial number 5, transform holds all the parameters and controllers for position, rotation, scale, etc. If our script cannot find this name, it will not stress about because it will catch. Also, we want to make the FK controller's transform equal to the IK forearm bones transform. That's why we'll select our forearm FK controller, and also on the second line of instruction, we'll try to find a selection with the following name, single quotation marks. Make sure to close them. After this, let's put dot transform to access this main parameter and equalize it to the selection. Let's put the name of the respectful IK forearm bone, its transform. As well as that, finally let's select our wrist FK controller, do a selection to find it, access its transform, and make this transform equal to the transform of the following selection, which should be our wrist IK controller, since this controller is oriented the same way as our FK controller. You could do the bone, and that way we know that its axes are aligned in the same way as the FK controller. So let's use the IK controller. Dot transform. Let's put a message box in our catch statement, like so. You can see that we're declaring a variable of type message box, and in its string we're saying what it's supposed to tell us. That's only going to happen if the catch didn't occur. Let's put it in all of the 3 catch statements. Also, just to make it more neat, let's put dot in our string and say error 3. And in here, let's put error 2, right here, error 1. So if it says error 1, we will straight away know that it's something to do with those names, with those 2 names. That is the ARM FK or the chains of bones names. This is what happens on FK to IK pressed. Now we need to specify what happens when our second button, that is IK to FK, is pressed. In here, there is only one piece of code in which we try to align our IK control's position to the position of our FK wrist controller. If you remember, on our attribute holder parameter, we have 2 buttons. One to bring the IK chain towards the FK chain, and another one to bring the FK chain backwards towards the IK. We also got a spinner in between of them, and as well as that, we got a slider below. Our slider is denoted by this variable right here, and its name is over there, and the spinner variable has got its name right here. I want to create it so that the change in spinner's value alters the change in the value of the slider, and vice versa. For that, before the rollout section, let's declare a parameters section called parameters, and let's just call them switch parameters. Open and close the bounding brackets to define an area for those variables. And we want to declare a variable that's going to unite both the spinner and the slider's values into one. For that, we're going to say SPSL, standing for spinner and slider, and let's say parameter para. That was its name, and now we need to declare its type. For that, we're going to put type, column, sharp sign, float, signifying that this parameter takes values with their decimal values, so like 1.5, etc. And for the bounding UI, we're going to put in the brackets the name of our spinner, and second parameter is going to be our slider's name. Of course, they're separated by commas, just like any arguments. Let's not forget to put semicolon, although it's not necessary, but following the convention once again. Now we know that by changing the value on the spinner, the value of the slider will be changed, and vice versa, because they are united via the UI unifier. So now, having thrown an attribute holder modifier on our IK controller, and it's going to stick this whole rollout into this area for the modifier, for our selected IK controller who has this modifier. But in order to force the script to stick this rollout into this modifier, we still need a couple lines of code. Let's inbound this whole script via the name custom attribute. Let's put equals attributes, which is a keyword, and let's put a visible name called fk_ik blending. Open the bounding bracket, close it somewhere at the very end of the script. So now everything is contained within this variable. Let's actually rename it to custom attribute 1, for example, doesn't really matter. And now we can refer to this whole piece of code by saying custom attribute 1. At the end of this custom attribute, we can actually put a comment by putting /*, commenting out, for example, end of custom attribute 1. Then to close the comment, otherwise it's going to continue forever, put a */, and outside of this custom attribute, put cast attributes.add our selections modifiers, modifier number 1 in the square brackets, and throw our whole custom attribute. With saying 1, we are referring to a modifier with an index of 1, since this one contains index of 0. The first one is always 0, since this can be considered as some kind of array, and so on. The third one would be 2, etc. So by saying that we want to access the selections modifier's first modifier, we are really saying the attribute holder of a selection. And we are sticking our custom attribute 1, whose name should be actually changed to custom attribute 1, since it's called like this in here. Otherwise it's not going to know which kind of variable to stick, because we didn't specify before what it was. Just to recap, in this script we've specified our whole new attribute. In it we specified the parameters, we unified the parameters between the slider and the spinner. We've specified a new rollout, the one that contains buttons, those spinners and sliders. And we also explained which kind of actions should be taken in case the two of our buttons are pressed. And we even supplied an error message to be thrown in case the object within the scene to which we refer to doesn't exist for some reason. Perhaps let's also put a message into here, into this catch. So we're going to throw a message box with the string and attempt to select a non-existing element from the arms IK FK chains, error number 4. After this attribute finishes, we specify just a single action to find a first modifier on the selection and to stick into it our whole code. Having selected our IK controller, having an attribute holder ready for us to stick modifiers on top of it, we can press Ctrl E on our script. This underline on the line says that we have a mistake in here. So the name of our variable, the type float, UI with the parameters, and we actually forgot to put a column in here. As well as that, we specified our parameters to be called switch parameters, and they contain parameters which refer to other two variables. However, we didn't relate it to any kind of rollout, and it doesn't know what to do. For example, if we press Ctrl E and execute the script, you will see that the parameter UI is specified, but no parameter block rollout is supplied. When declaring parameters rollout, we need to actually specify with the keyword rollout and explain where those variables, that is sp_fk and sl_fk parameters, are sitting. Of course, they are in our rollout unnamed rollout, which actually can be changed to something more sensible, such as main rollout. Let's copy its name, paste it into our parameters so it knows where to refer to. And now when we press Ctrl E, if we switch to our attribute holder, you can see that our rollout was applied to our attribute holder. In case it's too big, we need to get rid of it. To fix this problem, let's reassign our attribute holder. Let's dispose of this one, apply a new attribute holder, put the counter somewhere inside of the rollout, go into Tools, Edit Rollout, and it's obviously too big, so let's pack everything close together. The width is obviously too big, and I think 160 is the maximum that we can afford. Let's readjust everything. I even had to turn off the snap, because I need to get those last bits out of our space. We can actually bring this spinner downwards. Let's click Save and close our editor window. Once again, having selected our IK with our attribute holder, let's execute the script by pressing Ctrl E or going into Tools, Evaluate All. Let's not make our life harder, so get rid of the semicolons from here. Now when you press Ctrl E, you get a nice rollout that's called Untitled, so let's rename it once again. In order to have a nice rollout name, let's change it from Untitled to FK/IK, standing for FK-IK blending. Also, for the buttons to work, they have to be inside of the rollout where the button was specified or declared, so copy the instructions on button pressed do for both of them by pressing Ctrl X to cut it out, but to copy it simultaneously into the buffer. And then somewhere at the end of your rollout, but before it finishes, let's paste our code for instructions telling the buttons what to do when they are pressed. With our IK control selected, we can evaluate this script, and you can see that we can control our weight either with a spinner or with a slider. Now if we decide to animate our arm using the IK side of the solvers, we can position it like we want and then bring our FK chain to the IK1 by pressing this button. We can then quickly switch the weight in the favor of FK, then start rotating the arm from the FK. However, we didn't tie the weight yet, and that's another step to do right now. Let's select our FK controllers, all three of them, Alt-right click transform to 0, select our IK and press IK to FK to transform it back to 0 as well. We're going to parameter wire the weight. Remember that we have 3 chains, the green one, our main chain, consisting of 3 bones, and we also have an FK chain, as well as the yellow one, which is an IK chain. Since each one consists of 3 bones, and the parameter of weight belonging to the green chain is the only one we care about, we need to make sure that we fuse this weight or parameter wire with the weight of the orientation for each of the bones on the green chain. Once again, we're going to do this via the animation, via parameters, parameter wire dialog. You have been expected to work through the tutorial number 5, so you are already familiar with parameter wiring, which allows to wire the parameters via the boundaries. If we quickly switch to our green chain by selecting it and switching to isolate mode, by picking each of the chains and going into motion, rotation, orientation constraint, you can see that all of the targets are ordered. FK goes first in the target of orientation constraint for the green bone, and IK follows it on the second place. This happens both for the arm, so FK and then IK, for the forearm, once again FK, IK, and the same thing happens for the wrist, FK and IK. The same story happens on the other arm as well. So the order is preserved. Because of that, we can select our IK controller, refresh the window on the parameter wiring on the left, go down along the mutant left IK controller by expanding it. You don't want to be touching the goal, so leave it alone. Go into modified object, attribute holder, FK IK blending, which is our rollout, and our parameter, SPSL parameter. So this object contains a modifier, which contains a rollout with a slider and a spinner. By changing either the slider or the spinner, we're altering a parameter, SPSL parameter. We want to grab this parameter and via the parameter wiring make it influence all of the weights on all of the 3 green bones for our orientation constraints weight. That's why from our controller we've traversed down to attribute holder, our rollout, we found our parameter, and now let's select each of the green bones and sift down until we find a required orientation constraint weight parameter. Let's select our green chain as well as the IK controller, right click, hide unselected. So now we can focus directly on them. With our SP parameter selected, we now need to adjust the right side of our parameter wiring. On the right side we should have a weight from this arm bone. Let's refresh the window to plug in this bone into here. Go into transform, rotation, orientation constraint, open it up. And as you can see, we got 2 parameters right here, orientation weight 0 and weight 1. As you can see, our orientation weight 0 is our FK, and our weight number 1 is the weight towards the IK chain, or the IK bone. This is the case for all of the 3 green bones. The orientation towards their respective IK, FK bone is preserved in this order. If you recall, our SPSL parameter is from 0 to 100, including the decimals since its type is float. Let's say if this parameter is 0, we want to make the orientation weight 100, that is, favor our FK motion, but our IK should be 0 as well. I'll select my SPSL para, make it influence whatever is on the right, and on the right I'm going to pick orientation weight 0. Now I'm going to say 100 minus this parameter. That means as this parameter grows, this FK orientation weight is going to be tending to 0, since we're going to be subtracting the greater and greater amount in terms of SPSL para. And let's press connect. Now let's switch to orientation weight 1. In here, let's just say if our SPSL para increases, increase the weight as well. So it's a direct relationship. Because our weight is in between 0 and 100, and so is our SPSL para, all the range for our custom parameter will be utilized. Make sure to set the direction and press connect. Don't forget that you have to do this for all 3 bones, that is the arm bone, then the forearm bone, and then the wrist bone. So for the forearm bone, let's re-update this window, the right one. Go down into transform, rotation, orientation constraint, and this one will have now 2 weights again. This one will be an FK one towards the FK forearm bone. That one will be towards an IK forearm bone. Do the same thing for the wrist as well. If we unhide the geometry and everything with it, press F3 to get out of the wireframe mode. Let's now alter IK chain, switch into its parameters, and change the weight with either the slider or the spinner. If we right click on the spinner, that's going to zero it out, favoring completely the FK motion. We can also reposition our FK chain using its controls, and then returning back to our IK controller, we can blend it down to follow the FK completely. If we then decide that from this point we want to use IK, but exactly from this position, we can bring our IK towards FK easily and start manipulating it from there. However, there is a finishing touch, a minor adjustment to be done. Let's instantiate our attribute holder across to all of the controllers, because you don't want to be switching all the time to the IK controller in order to change the weight or to snap. For that, we can create an instance of this attribute by pressing Ctrl, left clicking on it, and dragging it down to other controls. So now all of the 4 controllers contain the same attribute holder. In fact, this one contains the original, and those 3 contain just the copies of it, the instances. They all share the same parameter and represent the same actions. With that, let's select all of our FK controllers, right-click and transform to 0. From our FK-IK rollout, let's bring our IK chain towards the FK. Let's actually select all the 4 of our controllers, Alt-right-click, freeze transform. Don't forget that when you alter the script for the right arm, you need to change the names in here to be the right arm, and also change the name of your parameter to be like SPSL parameter 1, for example. So watch out for this place, watch out for the names. You might want to give a hint to the user whether the error occurs on the right or the left arm, and also, just to be safe, change the names, the script names of your buttons. Of course, as you instantiate your attributes across the other 3 controllers, make sure that the attribute is not instantiated somewhere on the other arm, since you want to keep an instance for the right arm attribute holder on this side, but here it should be an instance for the left arm's attribute holder. The twisting on the arm still doesn't work since we didn't do any kind of roll bones yet, but very soon we will consider them. As we're working on the arm, go for adding one more additional setting. The controls allow for a very flexible adjustment of the whole chain, as long as we're working in the FK mode. For example, this angle is possible to be raised upwards or downwards simply by rotating this shoulder joint. But that's not the case with the IK. You can move the joint and force the arm to move the chain inwards, but if you are in the IK completely, you won't be able to control this up and down movement anymore. There is one more setting that is hidden in the motion panel, and if we select the IK goal, you will see it. It's simply called the swivel angle, this one right here. While favoring the IK motion, our arm will be bending upwards or downwards, like I've shown you with the FK. As we alter the swivel angle, for example, at -90 it will go like this, at +90 it will go up like so. That's one setting to consider. Another one is that when you are in the IK mode, you don't have the control over the wrist of how it bends, upwards or downwards. So you'd want to create a separate FK control that is independent from the arm FK chain. However, it has to be linked to the IK control or directly to the main wrist bone that is responsible for controlling the main palm bone, the green one. Let's work on the swivel angle first. As you could have guessed, we have instances of our attribute holder on all of our controllers. It's just a matter of adding one custom parameter via parameter editor. That way it will be redistributed to all of our controllers. Before we do this, let's transform our FK controllers back to 0. Then bring the IK chain to the FK. Now let's select the main parent's FK controller, press Alt-1 and go to the parameter editor. If that doesn't work, go to animation and find the window there. For the swivel angle, let's create a spinner. Of course, following the example of tutorial number 5, let's add a custom parameter here. We need to call it the swivel angle. Let's make it from -90 to 90. Default should be 0. Width of about 80 and position center. You can see how it's gonna look over here. Of course, if you want a slider, simply change it here. Let's make sure that it's selected objects modifier, not the base level. Otherwise, as soon as we apply the setting, it's going to stick our parameters down the spline modifier. Actually, the range of 180 would be too big. Let's scroll back and make it from -9 to 9. Otherwise, in order to get to bottom, you'll have to click and scroll down a big distance. So the range is 18, it is fine. Click Add to stick your parameter in the attributes of the modifiers section. Once again, ensure that it's selected object's current modifier, not base. In case you notice that there is a mistake, and you only spot this after you've added your parameter to the attribute holder, please refer to part 5, where I thoroughly explain how to change it. Look somewhere in the middle. Following the principle of the previous tutorial, we need to tie this parameter to affect the required variable, in this case, to affect the swivel angle from the motion panel. Having selected this, let's right-click. Choose Wire Parameters, Modified Object, Attribute Holder, Custom Attributes Rollout, Swivel Angle. Now we need to click on the object to set it as a target and pick a variable that we want to affect with it. Let's click on the IK goal. Select Transform Swivel Angle. Now we got the parameters window open with the settings already visible, so we don't have to sift down for them. Otherwise, you can always click on the binoculars That will search for a first modified parameter that was tied. In this case, the swivel angle. Of course, on the left hand side we have our FK controller, from which we traversed down to the swivel angle variable. And on the right side we have the IK goal, in whose transform we want to find the real swivel angle and then put some force over it. Because we want our parameter to affect the variable swivel angle for the IK goal, we have to put the rightwards direction. Remember that we are working with the centimeters to favor the unity's preference of measurement. However, the parameter wiring is still expecting generic units. That's why let's divide our swivel angle variable by 10. As the change is applied to this parameter right here, it's going to be expressed via this variable. And in the end, the result in this formula window will determine the value of the real swivel angle for the IK chain. I tested it before, but it was spinning too quickly, so I actually thought that just 1/10 of this input variable swivel angle would suffice. Press connect or update in this case, then bring your chain closer, making sure that your arm is favoring it completely, then test the swivel angle. If it doesn't go down the required amount, we can actually increase the factor and divide it by, say, 8. Press update. As promised earlier, let's add a custom FK controller for our palm bone. If we go into the wireframe mode, notice how the components of the green chain are positioned. Your green wrist right here, originating from this point, and you also see the palm bone, which is also coming from the same point, but is extending slightly further. It's linked to follow the green main wrist bone. That's why using the old FK controller and rotating it, we're going to be affecting the wrist bone, which in turn will be affecting the palm bone. However, when completely in the IK mode, we won't have control over this area. So let's add a custom FK controller that is going to be independent from the other FK controllers, won't be linked to them, but will be affecting our palm bone. That way, while in the IK mode, we will still be able to affect our palm bone to allow for a grabbing motion, for example. Click on our FK wrist controller, shift drag it outwards to make a clone. Double click on the green chain somewhere from the forearm bone, and then add a newly created controller to the selection. Press Alt Q to enter the isolation mode. Change the color of the controller to blue. Let's align it with the palm. In position and orientation, and also remember that our palm bone has to be linked to the wrist bone. But it also must be adhering to the rotation of the new palm FK controller. That can be done via the animation, constraints orientation constraint. Constrain the palm bone to grab the rotation of the FK palm controller. Click the palm bone, and you can also do it within the motion tool. Transform, open up your rotation, click on the 0 Euler XYZ rotation, assign controller, orientation constraint controller. From the PRS parameters, go into rotation, orientation constraint from the list, and click on the add orientation target button. Then click on the FK controller. Exit the add target mode. As you rotate the FK palm controller, it drives the palm in the same direction. But the palm is still going to listen to the green chain's change in position. Change the name of the controller to mutant left palm FK. Exit the isolation mode and repeat the procedure for other arm. You can copy the controller as a copy, then align it to the palm bone. That way, the axis will be aligned. Of course, if you press align in both position and orientation, pivot to pivot. Make sure you link your FK controller to the IK one. Make sure to freeze the transform for this controller as well. As you click the IK goal and bring the chain closer to the body, notice that now, while in the IK mode, you can control the rotation of the palm bone. Because this newly created FK controller for the palm bone is linked to the IK controller, it's always going to be located inside of it. But if we try to blend the weight to the FK chain, look what happens. Our palm gets completely affected by the orientation of our palm FK controller. The wrist cannot do anything about it with its linkage. Even though the main wrist gets aligned to the FK controller right here, the palm bone, which it holds and which originates from the same point, is told to follow the orientation of the palm controller. This is why we need to force this weight value to be affecting the palm bone as well. As it becomes closer to 0, we want our palm bone to exit favoring the orientation of its palm controller and instead listen to the orientation of the wrist. As well as that, notice that our attribute holder on the palm FK controller is not an instance of the main attribute holder on the other controllers. So changing the value or pressing the buttons won't do anything. Let's get rid of the attribute modifier from our palm FK controller, click on some other one, then control and drag it down from other FK controller to the palm controller. Now, as we got an instance of the modifier, the values actually refer to one single modifier and are shared between each other. If you remember, 3 of our green bones, that is the main parent, the forearm and the wrist bone, were weighed between their red and yellow copies, that is, orientation constrained weighed. We also need to constrain our palm. In the case if we are working in the FK mode, when we are favoring the FK motion completely, we want our green palm bone to be affected by the wrist, the FK wrist that the wrist FK controller is driving. On the other hand, while in the IK mode, we want the palm bone to listen to its palm FK controller. When I enter the isolation mode, I would like to show you the problem in more depth. When I move the IK controller downwards like this, and for example, let's blend our arm in between the FK chain and the IK one, somewhere in the middle. We got the FK controller for the red chain, which is affecting the wrist FK bone, our cube. The green wrist bone is weighed between the cube and the IK goal. The IK goal is in turn driven by the IK controller. But now, the green palm bone is affected completely by the rotation of its palm FK controller. Right now, it only has one target for this orientation, but we would like to add a second one, somewhere in the FK area. For example, this cube. However, the main problem with that is that this controller was aligned to the palm bone, and initially their local axes were aligned. But the cube's axes are already looking in a different direction. The cube was aligned to the wrist bone, and if you look closer, indeed, the wrist and the palm's axes are looking in two different directions. This is due to the top-side methods of chains creation when we were developing the skeleton. Of course, the local axis of the green wrist bone are looking in the same direction as the red FK's wrist axis. Due to that, we got a controversy. We got axes that are looking in one direction right here, and we got axes that are looking in completely different direction right there. However, we would like to weigh our palm bone between this area and that one. So what do? We're simply going to throw a helper into here. Let's first of all click on the IK controller, bring the weight down. Favor the FK motion completely, bring the IK chain towards FK, and make sure that our FK palm controller is in the correct state. Transform to 0. When this is done, and all of our 3 chains are aligned in one line, let's go to Create, Helpers, and create a point helper. Change its color to blue, click Align, align it to the palm bone. Pivot to pivot in position and orientation. That way, the axis of the newly created helper are going to be aligned with the axis of the palm bone, as well as the one of the palm FK controller. Take this IK controller and bring the whole IK chain outwards. Switch to the modifier and change the weight to be somewhere in the middle. We're going to link this blue helper to the wrist FK controller, and now although those two objects' axes are looking in different direction, the helper will be following the wrist controller. Inside of the palm bone, the axis direction is somewhere in here. In the helper, the axes are also looking like this, and the palm FK controller's axes are also aligned in the same way. Now there won't be any kind of controversy between the orientation target's direction. The palm won't be flipping in random ways. Enough talking, let's click on our palm bone. Go into the motion panel, orientation 1, and let's add a second target. Zoom in and add a helper as a second target. To be fair, we need to rename our helper so that it's more clear as what it is. Change the name to Mutant Left Palm FK Helper. With the palm bone selected, let's right-click, wipe parameters, transform rotation orientation constraint, orientation weight 0, then click on any controller that contains an instance of the modifier. For example, the IK controller or the FK1. Modified object, attribute holder, custom attributes IK FK blending, spinner slider parameter, which also stands for the input of the weight. As we change the spinner slider's value here, we want to be affecting our weight in here. So let's set the direction to be leftwards. And we will say on our orientation weight 1, this 0 weight is playing in the favor of the FK palm controller. The second orientation weight is going to be playing in the favor for the rotation from our helper right there, behind the window. As we favor the IK motion, that is increase the weight value, we want to favor the weight 0. Because as we increase the value favoring the IK chain, we want to favor more and more the palm FK controller in here. So that's a direct value. Click Connect or Update from right to left. Switch to orientation number 1 And as we increase the value, that is, favor the IK motion, we want to reduce and abandon the effect of the helper on the rotation of our palm. Since the SPSL para is from 0 to 100, we want to add 100 minus before SPSL para. As we will be increasing our weight value, we're going to be subtracting more and more from 100, getting closer to 0. Overall, we will get a result that will be tending to 0 as our input value increases, reducing the weight number 1 with it. Weight number 1 is belonging to the helper, weight number 0 is belonging to the orientation of the palm controller. Click Connect or Update from the right to left to ensure that you've locked your settings. Test how it's working now. If we go into the IK controller, we can then rotate our FK controller for the palm, and as we switch for the weight downwards, favoring the FK motion, we can now use the FK wrist controller. Wrist controller is going to be driving our helper, and in this case, the palm is favoring this helper's rotation since the weight is currently at 0. And because of that, the value is the greatest since it's 100 minus 0. However, here it's a direct relationship. It's simply 0. And in here it's 100. You might think that there are two cubes right there, two helpers. But in reality, one is a helper and another one is the wrist FK controller. The latter one's axes are looking in the different direction by default, from the direction of the palm bone. That's why we had to create a helper with a proper alignment of axes and align it to the palm bone. That allowed us to weigh properly between the palm bone FK controller and the helper without a flip in the palm's direction as the weight changes. That would be a problem if we would decide to weigh between this one and the wrist FK controller. It's really a preference of taste, but you might want to have your FK palm controller linked not to the IK chain, but rather to the green wrist. In that way, as you blend between the IK and the FK chain, you will still be able to rotate locally your palm bone. And you won't have to struggle with figuring out which direction to rotate this controller or whatever to rotate the wrist. Your palm controller will always be attached to the hand, and no matter where it goes, you can always rotate the palm from that point. When you relink it, make sure that the arm is completely following the IK chain, so that the position of the palm controller and the wrist is aligned at the same point. Simply relink this controller to the green wrist bone. Do the same thing for the other arm as well. By this point you've got already a pretty flexible structure, but there are still roll bones to focus on. That is the roll bones in the wrist area and also in the shoulder area. That's gonna be done after we do the spine, later on. Right now let's focus on the legs. In my opinion they require less flexibility, so in the contrast to the arms, we will only use one chain, that is the IK chain, and will not incorporate any usage for the FK chains on the legs. We would also want extra flexibility on the feet, in case the animator wants it to be tilted, raised on the toe, or pinched on the toe. All of that is going to be achieved by the controller that's going to be manipulating the feet, and the main IK chain with the leg as well. Let's go into the left view and focus on the leg from there. The thing is, when developing the bones, I deliberately placed this joint in a wrong spot. It is in the center of the leg. However, right now I want it to be somewhere here. Imagining that this is a foot and the toes begin somewhere here, this joint should be moved to the area behind the toes, somewhere in here. But keeping this in mind, there is already one problem. We've skinned our mesh to the bones, and even if we go to Bone Tools, enter Bone Edit mode, if we try to resize our bones, you'll see what happens to the leg. Its modifier gets distorted, and that's not the proper way to do it. You could have tried to remove this bone from the list of the skin modifier for this mesh, but instead you can take a more clever decision. Let's roll back our action before we started editing this bone in the Bone Edit mode, unfreeze our mesh, select it, and inside of the skin modifier, go into the Advanced Parameters section. Uncheck Always Deform parameter. And now you can switch to the bones, enter Bone Edit mode, select them from Local, from Pivots Point Center, readjust them in the X-axis to be sitting somewhere in here. That's the correct placement of this joint. Scroll down, reset the stretch on both the ankles, the toe ends, and the bases of the foot, as well as reset scale. Exit Bone Edit mode. Select your mesh, switch back to Advanced Parameters, and turn on your Always Deform option. Now you'll have to go ahead and adjust the envelopes accordingly, because the bone's position have changed. Your animation is still kept the same, that is, if you have been animating rotations of the bone, now they're going to be happening from this new point right here. So you shouldn't worry about this. Your animation is preserved for the bones. Having adjusted those bones, you now need to ensure that the mesh is deforming properly around those joints. Of course, if your mesh is symmetrical, you might want to do just one side, for example the right side, and then simply mirror the parameters of the vertices from one side to another one, just like I've explained to you before. With that positioning of joints and the skin modifier applied, your mesh is going to be deforming properly now. Right now it's all about setting up several of the IK chains for each leg and creating a couple of controllers for every foot. Let's hide our geometry temporarily because we won't need it. Let's close our bone tools and focus on the right leg. Let's select it, go into Animation, IK Solvers, Hierarchy Independent Solver. Then let's click on this bone. That places a goal on the rear end of our ankle bone. And of course by grabbing it we can manipulate the leg as follows. We can also do this for the left leg as well. Rename the IK goals correctly. You can call it as mutant right ankle and then goal with capitals. On the left side it should of course be called mutant left ankle goal. Select your foot base, go into Animation, Hierarchy Independent IK Solver, and click on the ankle bone. That will place a goal over here. Call this one mutant right base goal. Repeat the procedure for the left leg as well. Finally, plant a third IK goal. Select your toe and bone, go into Animation, IK Solvers, HI Solver, click on the foot base bone. Rename this one to mutant right toe goal. And of course do the same thing for the left leg. The foot hierarchy of the IK goals is a very intricate structure. You got 3 joints which you can pull around and manipulate. And in fact they're used for rotation mostly. We need a couple of helpers to rotate them around. For example, if we create a helper in this area, we can select this joint and link it to this helper. By rotating our cube, we will be moving this IK goal in an arc around the cube. However, because there are other IK goals in the foot, the area to which they belong will be held in place. Let's go to Create Helpers, Point Helper, change its color to yellow. Let's change its size to be slightly bigger, 15 centimeters in my case, and align it to our right base IK goal, in position, but not in orientation. This is because I prefer to have them aligned to the world, so that they are laying flat in regards to the grid. Rename it to Mutant Right Foot Motor A, with motor and A being as capital letters. Right-click and clone your helper as a copy, and let's change its name, Mutant Right Foot Motor B. Of course, it's overlapping with the previous one. Let's change its size down to 12. You wouldn't want to directly scale them, because that wouldn't be correct once again. You can now select your right ankle goal and link it to the bigger of helpers, the motor A. With rotating this motor, your leg will be changing its shape like so, creating this tiptoe effect. Select your toe goal and link it to the smaller of the helpers, the motor B. As you could have guessed, with rotating this motor, you're going to be raising your toe. Select the smaller of the helpers and shift drag it in the local y-axis. Rename it to motor C and align it to the toe goal. Pivot to pivot, XYZ position but not in orientation once again. Having a tiptoe effect, we now want our character to be able to stand on its toes. That is, somehow rotate this controller and make it affect other 2 goals. However, if we try to link those 2 goals directly to this helper, we will be able to achieve the toe lift effect, but we will lose the linkage to those 2 helpers, effectively losing the ability to use the toe tip effect in exchange for using a toe lift. That's not really the way to do it. With the motor A creating a toe tip effect, and the smaller motor affecting the rotation of the toe, allowing us to lift the toe, those 2 helpers aren't linked to anywhere, and this helper isn't linked anywhere as well. Let's open Graph Editors, New Schematic View. If it's not there, press Z to center on it, or if you have a selected object is going to be highlighted with white, you can press Z to center on it. If we look closer, the motor B, the smaller of the helpers, is affecting the right toe goal, and the motor A, the bigger of the helpers, is affecting the ankle goal. We can now use this one to stick motor B and motor A under it. We can now use this small helper, make them the children of the motor C. Let's select both of the helpers and link them to motor C. Now, as we rotate motor C, as you can see with the toe lift effect, while rotating motor C, we are forcing this joint, this IK goal, to be moved in an arc. Also, the IK goal right here is affected as well, but its main purpose is to rotate a joint around this area, around this point. So rotation, local rotation of this goal doesn't matter. We can afford to have it rotated. But we still didn't make use of this goal. Although the helpers are being lifted, the base IK goal doesn't follow them because it's not linked to any helpers. That's why as we try to rotate the motor C, effectively trying to achieve a toe lift effect, you see a bend in this area, since the IK goal, the base IK goal, demands this joint and pulls it down. Let's roll back our actions and achieve a pose where none of the bones are lifted. We can now select this base IK goal and link it to motor C as well. So at the end, motor C is carrying three objects: IK goal, motor A, and motor B. Those arrows aren't very clear, so here's the general direction. This guy is motor C. It is this one. Motor B is the smaller of the helpers, and motor A is the bigger of the helpers. Ankle goal is over here. Toe goal is this one. Base goal is over here. Study this relation because it's very interesting, and in fact you only need base goal just to have this joint pulled upwards along with this IK goal as we lift our toes. This is our foot structure. We now need to create a controller to control the foot and the rotations of those helpers. Following the instructions of tutorial number 5, we're going to be using reaction manager and parameter wiring to wire the rotations in regards to the parameters of the feet. For that, let's go into create, and as always create a shape in a form of a line. Let's make it in the form of a horseshoe. Make sure to click on the first of your points and close the spline. Right click to exit the line creation mode. Go into the top view, center on the object, go into modify, vertex, and readjust your vertices so that they're sitting nicely. At the end, the shape doesn't matter, you can create anything you want, but I prefer to have this one. We want to extend it further. Go into the hierarchy, affect pivot only, center to object, then align it with one of our IK goals, for example the base goal, in position, but not in orientation. We need to readjust its size, and you might want to unhide the mesh in this case. Go into properties, and adjust the points, or scale using the parent, transform coordinate center. But once again, never scale your controllers outside of the sub-object regime. If you do, always do this in the sub-object mode. You want to make it easy to select, and also avoid the clash within the controllers when they are overlapping each other, when the parts are too close. For example, the frontal part, the outside part, can be extended further, and the inner side can be shrunken down. If you want to, you can add an extra fancy look by going once again into Create, Splines, Text, put down your max text, perhaps straight away let's reduce its size down to something very small, and call it Foot Controller. This one should be called Right Foot Controller, so let's put R in the front. You can enter rotation, rotate it the way you want, or keep it flat. You can also play around with the fonts. I'm pretty sure that if you go into the control panel, fonts, you can download any font and throw it into this folder. Then restart your 3ds Max and you'll have a new font to use. For example, some kind of futuristic font. Let's also copy this text and change it to left. Go into hierarchy, affect pivot only, center to object. Do the same thing for this one. And let's align the right foot controller annotation with the right foot controller in position but not in orientation. Bring it outwards and maybe tilt it slightly like so. Then go into world, transform coordinate center. In this mode, let's mirror this controller as a copy, and perhaps let's change the color to something more bright because it's not really visible. Let's change it to yellow. Now if we select one of our controllers, go into modifiers, sub-object regime, we can attach our text spline. Exit the sub-object editing regime, switch to another spline, and repeat the procedure. It's now just a matter of sticking an attribute holder, filling it with required parameters from our parameter editor, and then just wiring them via the reaction manager. As said before, let's select each of our controllers and stick an attribute holder to them. We need to hide our mesh to be able to focus on the chains correctly. For now, you will need 6 variables to stick into this attribute holder. By pressing Alt-1, go into parameter editor, or simply go into animation, parameter editor. The variables that we will require are as follows: toe tap, toe lift, toe tip, toe turn, and the last two are heel lift and heel turn. It's up to you whether you want them to be sliders or spinners, but personally I prefer spinners. Their width should be somewhere about 100. You can test it right here. The first one should be called toe tap. Let's make it from -10 to 10. Default should be 0. It is a float and a spinner. Selected object's current modifier. Click Add to add this parameter to this controller. For the toe lift, everything is the same except that the range is from 0 to 10. Click Add. For the toe tip, the range is from 0 to 10 as well. But its name is very similar to toe tap, so let's make it just in capitals. Toe tip. Toe turn has the range from -10 to 10, with the default being 0. As for the last two parameters, they don't really belong to the toe, because we need to create two controllers for the heel movement. For that, I want to add a custom rollout in here, just with those two parameters. Let's recall our script from before. We can copy everything, file, and create a new script. Let's paste everything into here, and from it we only need the rollout and the custom attribute, which should be called custom attribute 3, for example. We're going to be sticking it to the modifier, so let's change it in here as well. Put your counter somewhere inside of the rollout, go into Tools, Edit Rollout. We can click on the button or the spinners and delete them, and change the name for the group to be heel group, and the visible name should be heel. Select the spinner and create a spinner somewhere here. Also create a label. For its visible name, put heel lift. You might want to use the grid to align it correctly. Let's copy this label and paste it into here, then change the name to something else. Heel turn to be precise. Copy the spinner, paste it into here, readjust the positions, and you're good to go. As for the rollout, we don't want it to be too big, so cut out any unnecessary space. Make sure to go in File, Save, then check your new reapplied rollout. We don't care about this name too much, but to be clear, let's just change it to heel. Change the name of the rollout as well. Don't forget to change the range for your spinners. Here for the heel lift it should be from 0 to 10, default should be 0. The same thing should happen to the heel turn. With a slight adjustment, it starts from -10 and goes up to 10. Let's rename our spinner to sp_heel and then add an underscore lift. Our second spinner shouldn't be called that. Let's call it spinner heel turn. Our labels don't matter, we only care about the spinners. In order to make it possible to tie the parameters with parameter wiring later on, we need to feed the set of parameters that are adjustable by the program. So let's add a parameters into here by saying parameters, switch parameters. Let's call rollout main rollout and declare a variable, let's say sp_heel_lift of type float, and for the UI column, let's put in the brackets the variable that we want to be controlling. That is sp heel lift. For the second variable, we can copy this, paste it into here, and change lift to turn, and also change the variable which we are looking at in here to be this one. Because our rollout is specified to be main rollout, it's going to be looking at this one and trying to find the variables in here. It's going to say, okay, this variable belongs into here. That one, the second one, is a representation of this one. Press execute. It throws out an error because I forgot to add a bracket here. Our custom attribute 3 holds everything between those two brackets, and I just forgot about this one. Select your controller, select your script, and from your script press Ctrl E to evaluate it. Now we got a nice set of controls. Just to avoid the hassle, let's repeat the procedure and add the parameters to the left controller as well. And having done this, we can return back to our max script, select our left foot controller, make sure that we are in this attribute holder modifier, otherwise if we are somewhere else, it's going to stick this rollout into another modifier. So make sure that you are in attribute holder, select your script, press Ctrl E to stick this rollout into here. Make sure to save your work regularly as different files. Let's copy all the helpers at once. Select all 3 motors, press Shift and drag them to the side. Let's unlink them temporarily, and then link them between each other. Motor C to motor B, and the B to the A. Select your B, click Align, and align it to the left foot base IK goal. Pivot to pivot, not in rotation. Press OK. To be safe, you still might want to go into each of the helpers and align them specifically to the required IK goals. As always, change their names. You can do this one by one, or go into Tools, Rename Objects dialog, as we did in the beginning of this lesson. Don't forget that if you were linking them and then aligning, you now need to unlink the helpers from each other. So click Unlink button. Then, as before, let's link our IK goals to the respectful helpers. Click on the ankle IK goal, link it to the bigger of helpers, the motor A. Now, as we rotate it, the motor A will force an IK goal to go in an arc, creating a toe tip effect. Select the toe end goal and link it to the smaller of the helpers, the motor B. Rotating the B, we will be able to create the toe tap effect. Finally, let's select both of the motors and link them to helper C. As we rotate it, we now have almost nearly completed the lifting of the toe, but the IK goal that's below it doesn't move. Let's select the center base IK goal and link it to the motor C as well. Now we got a proper toe lift motion. As well as that, select both of the C helpers, the C motors. From the world representation, selection center, let's press W, shift click and drag them outside, like this. Unhide the geometry, and reposition your helper to be somewhere on the breaking point of the heel, so that its center sits on this angle. Change their name to motor D. For each of the foot, link motor C to motor D. And now you got full range of motion that you can use. You got a heel turn, toe tip effect, toe lift effect with motor B, toe turn effect, and also toe lift effect. Selecting your controllers, go into Hierarchy, Affect Pivot Only, then align their pivot point to the ankle IK goal. Do the same thing for the other foot controller. Affect Pivot Only, and while in this mode, align it to the IK goal of the ankle. Pivot to pivot, in position. There is one more minor adjustment to be done. Notice that when you select motor D or motor C and try to locally rotate around them, have a look what happens to this ankle bone. It gets twisted around its axis. The same story happens when rotating motor C. It is especially clearly seen here. To remove this problem, let's select our IK goal, go into Motion Panel, IK Solver Properties, change the parent space from the start joint to the IK goal. As you rotate the foot, now the problem is gone. Do this once again for another base IK goal on another leg. To complete the hierarchy, select each of the D motor and link them to their respectful controllers. The D motor from the right leg should be linked to the right leg's controller, as opposed to the left D motor that should be linked to the left controller. The feet of the character are already very flexible, however the settings to alter them are not. That's why we will be tying those parameters to make them affect different ranges of motion or rotation for each of the helpers. Wait. Before you go any further, there is one more thing. If you unhide your geometry after setting the IK goal parent space, notice that your mesh twists in an unnatural way around the ankle area. As well as being funny, this is not really realistic. So let's select our base IK goal and apply a swivel angle of 90. Do the same thing for the other leg. You can now proceed further on with tying the parameters of the controllers to be affecting the rotations of the helpers. 3ds Max is not as cruel as you might think, and if you have done all of the parameters for this controller, for example, you can simply copy it into here, but not as an instance, just copy and paste the parameters from this controller to a new one. To do this, simply select the one that you've been working on, go into Modify, Properties, and before that to create an instance and just to add a pointer to one attribute, for example attribute holder, we were pressing Ctrl and then just were spreading the instances of this attribute holder across other controllers. However, here, let's just click and drag to another controller. That's going to create another modifier, exactly the same one as we were working on before. However, it's detached, it's not an instance of that one sitting here. That way you've saved yourself so much work. And you got parameters which just belong to this controller. Let's hide our body temporarily. Make sure that you link motor D to your controller, since now you can modify the controller and it's going to be driving your motor D. In turn, everything else depends on motor D, because motor D is nearly at the top of our hierarchy for each leg. There is one additional setting we need to consider. It is the swivel angle of the knee. To do this, let's select our controller, press Alt-1 to go into parameter editor, and then stick a knee swivel angle. Its range should be from -10 to 10. Width of 160, slightly larger than the previous modifiers, just so that it's easier to distinguish between them. Spinner, float, selected object's current modifier, and maybe let's align it to the left to make it more distinct. Click Add. Once again, just so that you don't have to do this a second time, you can select this controller, get rid of the attribute holder in here, and then just select this one, left click and drag without control, just to create a copy. Now it's time to tie the parameters using the reaction manager. Assuming that you have the knowledge from the previous tutorial, you're probably familiar with it and it's not something scary to you. Let's go into Animation, Reaction Manager. Obviously our master is going to be each of our controllers. First this one, and then the second one will be this one. We will have to do reactions for them separately, we cannot copy them. So that's the downside of that process. However, it's necessary, so let's do it. Right now let's focus on the right foot controller. Before we go any further, make sure that you've frozen your controllers, so select both of them, and press Alt right click, freeze transform. Now we can proceed with the parameter wiring. We're going to be working with the right foot controller. Let's click here to add a master, select our right foot controller, and let's add a master to be from the attribute holder of our controller, custom attribute, toe tap. So effectively this first thing is our first master. We want to add a slave to it, so that as we change this parameter, something happens to another object. To do this we can either click Add Slave and then click somewhere in the viewport, or if we are afraid that we're gonna click on something incorrect, we can simply click here, Add Selected. But obviously we need to select first the object that we want to add. If you remember, for toe tap, we need to rotate the motor B, the smaller of our motors, in the X-axis from the local representation of gizmos. So with it picked up, let's Add Selected, Transform, Rotation, X rotation. If you recall, the state 1 depicts the state at which our toe tap variable is currently at. For example, the default one is 0, so at this value our rotation at X is going to be 0 as well for our slave. Now we're going to add a second state at which our toe tap variable is at maximum, and feed the rotation to be maximum for our slave as well in the X-axis. Once again, if you're not using 3ds Max 2013, you might have to close and open your reaction manager to refresh the page. But if you established your shortcut to be Ctrl-R, just like explained in the previous tutorial, you're gonna have an easy time doing this, since you just have to press one combination of letters. If you click and then click again after a second, we can actually rename the state. For example, toe tap minimum. So with line 1 picked up, toe tap. Line 1 is our controller that I didn't rename, sadly. With that line 1 selected, toe tap, click Create State. Let's rename it to toe tap maximum. The maximum value is 10, if we remember. At 10 our motor B should be rotated by -90 as it was viewed here. Since we entered two intermediate states, it drew a line in between, and all the values between those variables are pre-calculated for us and are saved in the Reaction Manager controller. Now if we select this motor B and go into Motion, Assign Controller, traverse down to Transform, Rotation, you will see that the X rotation is obviously now tied, and its controller is Float Reaction. If we would be using parameter wiring instead of Reaction Manager, following the principle of tutorial number 5, of course this would be the float wire type. If you did a mistake, you can always untie it by assigning a Bezier float type in here to your X rotation. Select our foot controller once again, add master, click on our foot controller, modified object, attribute holder, custom attributes. Now we did toe tap, let's do toe lift. Select the toe lift, let's add a slave. Since I didn't click add selected, we now need to click on one of the objects inside of the viewport, and that's going to be our motor C. Transform, rotation, X rotation. Let's add a second state. At the value of 0 for our toe lift, the motor C is going to be at 0 rotation as well, just as it is right now. but as we approach the border, for example the maximum 10 for our toe lift variable, we want our toe to be lifted by 90 degrees. Let's pick our foot controller, go into its properties, and test what we have right now. Our toe tap, our toe lift. The next one is going to be toe tip. Add master, click on the foot controller, modified object, attribute holder, custom attributes, toe tip. Click add slave, and for the toe tip, it happens as we rotate the bigger of our motors, the motor A. So let's click on it, transform, rotation, X rotation. At the value of 0 for our toe tip, it should be at 0, but in a second state, when it's at maximum, obviously the rotation should be greater. The maximum allowed variable is 10. For the rotation, let's put 90 degrees. Test the attribute now. That may be some kind of extreme, so let's change it down to 70. That's better. For the toe turn, let's add our motor C, transform, rotation, and not the forward and backwards rotation up and down, which is around the x-axis, but toe turn demands us to be turning the toe. The twisting motion should occur around the z-axis, the vertical one. At value 0, it should be at 0, just as it is right now. At the second state, when it's minus 10, let's test it out now. So this direction is going to be going negatively. Let's add minus 17 to here. At state 3, when it's at maximum, it should be at plus 70. So the range is 140 degrees. Test it out now. If you want to reverse the direction, you need to put different values into minus 70 and 70, effectively just switching them in places. Finally, the knee swivel angle is going to be altering the swivel angle for this IK goal, the ankle goal. Let's add our master, click on our controller, modified object, attribute holder, custom attribute, because our master is sitting inside of it, and select knee swivel. If we scroll down, here it is, let's pick it up. With it selected, let's pick our IK goal, the ankle one, add selected, transform, swivel angle. Remember that our swivel angle parameter specified in the controller goes from minus 10 to 10, so we have two directions at which it can rotate. Let's bring the camera up so you can observe what's happening better. If our variable is at 0, that is in the middle, it should be in the middle as well. When our variable is at its minimum, for example minus 10, the swivel angle should be minus 90. Or maybe that's too big, so let's put minus 60. On the other hand, when our variable is at its maximum, the swivel angle, the real one, should be at 60 degrees. So that's the range of 120 degrees. You can try it now. Of course, I love the spinners because if you right click on them, that's gonna put you straight to 0. Very easily. Now you got a very flexible structure. There are just two more settings left. Those are the two ones controlling the heel lift and the heel turn. If you remember, because we've had parameters in our script when we were declaring the heel rollout, to be specific heel attributes, under the name main rollout, the script name, it is the SP heel lift, which is looking at this variable inside of our rollout, which is exactly this one. And it also looked at the second variable, this one, which found out that it has to look at the SP heel turn, right here, which is exactly this one. In fact, just the spinner one, because that's a label. But the moral of the story is, because we have those parameters declared, we can now use reaction manager or parameter wiring. We're going to be able to see it as we traverse down the hierarchy trying to find the required parameter. Without those parameters, those spinners wouldn't have any purpose, for the computer at least. They are there for us to tweak, but we wouldn't be able to grab them because they didn't have any kind of hooks or connections towards them. Parameters is exactly what allows us to grab them and to establish connection to those variables. But I will spend my time and will show you how to do one variable. Of course, add master, click on modified objects, attribute holder, and you see we have two rollouts. Custom attributes, which is right here, and also heel attributes, which is over there. Select our heel, and we can either select the first spinner, the heel lift, or the heel turn, the second one. For now, let's do heel lift. If we scroll down, it planted a master into here, which awaits for its slaves. That is, we've picked up this variable, which is currently this one, and it requires some kind of slave within the scene. For the slave, let's pick our heel and add selected. Transform, rotation, X rotation, because we want to rotate around the X-axis, up and down. When our variable for heel lift is at 0, our heel controller should be as it is. Let's create another state, and let's say if we're at minus 10, we should be at 90 degrees. And if we're at plus 10, that is the maximum of our variable, we should be at minus 90. Let's select our controller and test out our heel lift. Both of those spinners go from minus 10 to 10. Having done this, you need to parameter wire or reaction manager wire the parameters inside of your left foot controller. You'll need to do some of the testing, since what happens here can be different for the other leg. For example, as we do the toe turn, at positive 10 we extend outwards, but the axes of those helpers are aligned on both of the controllers, so you might need to flip several of the variables with minus or plus, just to make it so that on this controller, as we increase the variable, the controller rotates like this, counterclockwise, but for this controller, as we increase the variable, it rotates the opposite direction. Having done this, let's now focus on the spine. We will be doing our roll bones later on, as well as the fingers. Those are going to be our finishing touches. Let's hide the body along with the head. We want to create one major controller that's going to be driving the whole body, the whole structure, forwards and backwards. For example, if you select our pelvis, now because the IK controllers are grabbing the feet, if we drag our pelvis up and down, you will see that the feet doesn't let it to go. They are like glued magnetically to the ground because of the IK chains. The same thing happens with the yellow arms representation for the IK. Also, there is one more problem because the FK chains are detached, and the controllers, the helpers for the arms, are detached as well. That's why before we do anything, let's go into the front mode, center up on our shoulders, press F3 to go into the shaded mode, and link this main parent helper for the FK chain for the arm to the shoulder. Do the same thing with the right FK controller, link it to the respectful shoulder. If you try to move the pelvis now, the FK chains will be following it. However, the IK are still in place. Let's go into the top mode, create a controller, the major controller for the whole body. For that, go to create splines, create a rectangle from center, change its length to be 80, and position a text. Change the size of the text to be small, then put a description to this controller. Let's say main rig drive. For the font, I'm gonna pick my favorite one, Good Times, and reduce the size down so that it fits into the rectangle. I'm going to go into perspective mode. With my angle snap turned on, I'm going to shift rotate my text to create a copy. I'm going to shift drag it and then rotate it 180 degrees. Having selected my rectangle, I'm going to convert it to editable spline, then attach all of my texts. Let's go into Effect Pivot Only, Center to Object, align our huge controller to the rear end of the pelvis, in position, but not in orientation. To do the next step, you need to transform everything to 0, and sadly our legs have to be transformed to 0 as well, so Alt right click, transform to 0. To be clean, let's go into Properties as well, and zero out any kind of changes that we did. For example, the swivel angle should be zeroed out. Because we linked our controllers, we need to select them, Alt right click and freeze their transforms. Let's inspect our situation once again. We need to move the whole rig with this blue controller, but if we move our pelvis, our IK chains are staying behind. To fix the problem, we obviously need to link their controllers, the IK controllers, the ones that control the IK chains, to this blue drive to be moving along with the pelvis bone. The same story happens for the legs, so let's Control Z everything, select our IK controllers, as well as the feet controllers, click on our select and link, then link them to our main rig drive. Do the same thing for the pelvis as well. Now as we translate our rig, everything is gonna move with our main rig drive. This is true for rotation and translation. We will freeze transforms on this controller later on, because we're still not done linking everything to it. There are still a few controllers that we need to create. There has to be a controller which affects the rotation of our rear end of the pelvis to create a rocking motion of the pelvis. Don't mind the spine as it moves. It's gonna be fixed later in a vertical position. Let's create a rectangle. Change it to square. That's too big, so let's make it 10. Then shift drag it upwards. From the world representation, let's change the Z position to be 10. Select both of them, right click, convert to editable spline. Select one of them and attach its copy to fuse it into one single object. Let's right click on this option, deselect grid points, but select vertices. As we turn it on, we're now going to be able to stick to the vertices, to the points. Let's zoom in closer on our rectangle, that's soon going to be a cube, and click Create Align. Because we're snapping to the vertices, we can now create a line from this point to here. Then right click and create another line from here to here. Double right click to exit the creation of the lines. Go into hierarchy, effect pivot only, and of course center to object. Duplicate your object to the right. You might want to turn your point snap off. Once again go into modify and attach those two boxes together. Change their color to red. And again go into hierarchy, effect pivot only, center to object. Change its name to pelvis wave. Grab it and align it to the rear end of this spine, the lowest one, in position and in orientation. It is very important that you align it to this bottom spine, not to the pelvis, because you want to preserve the axis direction to be the same one as of the bottom spine. That's gonna be handy later on. Select your pelvis, go into motion, and from the rotation tracks, let's click on available and assign a controller to be an orientation constraint. Pick orientation constraint and set it active if it's not yet active. Add orientation target to be this new controller. Make sure to keep initial offset on. Right click to exit Add orientation target mode. As you rotate this controller, you are now able to create a rocking motion. Don't mind the upper body, later on it's going to be stationary. This effect is used in very small portions, but it adds realism to the walk cycle or to the movements of the character. We also need to create a controller for the chest, so let's go into create, splines, and create a circle spline to be our controller for the chest. Its interpolation can be smooth or not smooth the way you want to. I'm going to put it back to 5. Let's change its color to bright red. This one is not too bright for me, so I'm going to add a custom color of the brightest red that I can possibly find. Press OK. Align this chest controller to the upper spine, this one, in position and in orientation. Go into modify, convert it to editable spline, pick up spline subobject mode, press Ctrl A, and from the parent selection center, press Ctrl A and rotate with the angle snap by 90 degrees. You can observe the changes that happen here. Once you have this, exit the subobject regime, and now you got two controllers. You got this one, its axes are aligned with the axis of the spine, and you also have this controller, whose axes are also aligned in the same direction. We can now play with the spines and set them to be stretchy, follow the movement of the shoulders, for example, as they are turned, but in different degrees. Select the chest spine, go into motion, and in rotation, click on available and add orientation constraint controller. Click on it and set active, then add an orientation target to be that controller. Keep initial offset. As you locally rotate this controller for the chest, the hands and the shoulders move with it. However, there is a big snap in here as soon as I rotate it like this. We also want to constrain the orientation for the lower spine and the lowest one as well. That way we're gonna have a smooth arc. That's why let's click on the spine, go into rotation, let's click on the available Euler XYZ controller and change it to orientation constraint. It's already active by default, but if you want to, you can set active. Add orientation target to be that controller for the chest. Keep initial offset, and also add a second controller to be the pelvis wave controller. By default, the weight is distributed by 50-50%. As we exit add orientation target and rotate this chest helper, you can see the changes that occurred. Now we have a smoother arc in here. If you want to, you can change the ratio of weight. For example, let's make the spine listen to this controller with a percentage of 70, but the pelvis should be 30. And let's also add another constraint for this spine, the lower one. Let's transform this Euler into our orientation constraint controller, set it as active, and add orientation target to be that controller. Keep initial offset, and the second one, of course, the pelvis. This spine has only one orientation target, that controller. The second spine has this controller as a target, and that one. Here it goes for 70%, towards here it's 30. That's a very strange percent sign, but that's what it is. The third one should be 30 towards here, but 70 towards here. And so let's switch back to this one. It's 70-30. This one should be 30-70. As we rotate this controller for the chest, like so, you can see that we get a very nice arc. Depends how rigid your back is. Make sure that those numbers add up to 100. As you try to achieve a rocking motion, those bones behave correctly. They are looking at the rotation of this controller, as well as the rotation of the wave controller. Also notice that you have a very flexible joint in this area, because as this pelvis rotates, the bone that's above it, the spine, rotates halfway. It depends which weight this bone received via the orientation constraint. It listens to pelvis by 85% and to this controller by 15%. Just to make it more neat, let's go into text and create a description for our chest controller. Let's call it chest turn and align it to our chest controller. In position but not in orientation. Let's bring it outwards, turn it by 90 degrees, then apply a bend modifier to it. Change the axis to be X, change the angle to be of that much. Click on the chest, attach, and attach a newly created text. Make sure to save your work. Select your chest turn controller, link it to the main rig drive, select your pelvis, and link it to the wave controller. That way, as the letter is brought down, the pelvis is translated downwards with it as well, and it also listens to the wave effect. Make sure to select your IK goals and unlink them, because they shouldn't be listening to the chest turn. That way, as the chest turns, the IK goals are serving their purpose. They are staying stationary. However, they should be linked to the main rig drive, because that's the most important controller. With it, we're going to be able to translate the whole rig. Select your main rig drive, your wave controller, and the chest controller. Alt-right click, freeze transform. Make sure to save your work. Having done such a sweet job for making our rig, let's focus on our neck, since this is the next stage. Let's also create a controller for it. Create, splines, circle. Grab your circle, freeze the body geometry. Grab your controller, rename it to head controller. You want to align it to the head bone, the biggest one, in position and in orientation. As always, go into modify, right click, convert to editable spline, and do not rotate it openly by 90 degrees. Just go to the spline subobject mode and then rotate the geometry in there. From parent, selection center, representation of gizmos. With the angle snap turned on, rotate it by 90 degrees. It's just a matter of weighing via the orientation constraint those two bones, the neck and the head. Select the head, switch to motion panel, open up assign controller, and open up rotation. I want you to pay attention to those tracks. That is the frozen rotation of Euler XYZ. That's the one we have if we want our bones to return to their original frozen position. There is also 0 Euler XYZ, a flexible controller which allows movement around the scene. Depends which kind of variables are sitting inside Bezier or maybe parameter wire, then it wouldn't be moving so easily. But pay attention to those two things. Right now we have frozen and 0 Euler XYZ and one available track in here for the rotation. If we select the head, go into animation constraints, orientation constraint, and click on this controller, notice that we've added one variable in here, orientation constraint, of type orientation constraint obviously. This is equivalent of selecting available, going into here and assigning a controller. For example, orientation constraint right here. We could have also changed the Euler XYZ into orientation constraint, but first of all we would have to inspect if any kind of variables are already tied. That is, if they are in a float wire or reaction wire, then we wouldn't be touching the 0 Euler XYZ, otherwise that would void any kind of wiring that we've done on this 0 Euler XYZ. However, there is nothing of that type, so we could have easily changed the 0 Euler XYZ into orientation constraint. Instead, the program decided not to touch this track, but to add another orientation constraint. If we go into rotation, you can also see that we have frozen rotation right here, 0 Euler XYZ, and orientation constraint in here. I'm pretty sure that this list is executed from top to bottom. That is, as you add more stuff, when you rotate or perform different actions on the object, it's going to look first at the top one and then traverse downwards. But I'm not totally sure, so don't really trust me. The matter of fact is that we have orientation constraint in here. We can set it active and it's going to draw an arrow in here. To be fair, it already was active. So select it, and because we already added the target, it's all good. We got our controller. And as we rotate it locally, look what happens to the head. The head moves with it. But we also would want the neck to rotate halfway between the head bone and the lower spine to create a lifelike movement. Let's select our lower spine, go into rotation, click on available, and assign a controller. In fact, let's open up our 0 Euler XYZ instead, and just like I've told you before, all of them are Bezier floats. They're not highlighted with bold, signifying that they are affecting something, and none of them are of float wire or reaction wire type. All of them are Bezier float, non-highlighted, so we can actually change this 0 Euler XYZ into orientation constraint, just for performance. Select this track, 0 Euler XYZ, and assign an orientation constraint instead. Make sure it's active in the rotation panel. Add orientation target, a controller, keep initial offset, and also a bone below it. you wouldn't be able to add for orientation target a head bone for this spine because head bone already is constrained to something else. That doesn't make sense for 3ds Max to orientation constraint, say, the first object to the second one, whereas the second one is already constrained to the third one. Instead, it makes sense for 3ds Max to constrain both of them towards this object, instead of this option. That's why, working with this spine, we wouldn't be able to orientation constrain it to the head, because head is already orientation constrained to this controller. Instead, the spine should be orientation constrained to this controller as well. It's halfway and it's good. Save your work as a different file. As you can see, when I rotate this controller, the FK1, making sure that I'm in FK motion, the FK weight completely, you can see that the roll bone rotates completely with its green parent. That's not what we want. We want it to be rotating halfway between the shoulder and the main arm parent. To do this, we need to do two things. First one is we're going to be using orientation constraint. Second one is we're going to be using look at constraint. You might already think that we need to orientation constraint this roll bone between the shoulder and the main parent, and then put a look at constraint for this roll bone to be looking constantly towards the forearm. That's a good direction of thought, but those two things do not work together on one object. However, there is one way out of it. Let's first of all create a helper, for example a dummy, and align it with our shoulder roll bone, in position and in orientation, pivot to pivot. Having done this, we can now apply an orientation constraint to this dummy and constrain it between the shoulder and the main parent for the arm. Go into motion, rotation, and we got Euler XYZ type of rotation in here. Let's go into animation constraints, orientation constraint. For the first target, pick your shoulder bone and keep initial offset. This is very important. Add orientation target and add a second one to be the main parent of the arm. Right click to exit add orientation target mode. As I rotate the FK controller, while favoring the FK motion completely, notice that as I rotated, the dummy object rotates halfway. Select our roll bone, click on available, and add look at constraint. Make sure it's set active, add look at target, and add the forearm bone. Click keep initial offset. For the up node, select your dummy object, and because their axes are aligned, this is great. For the up node control, do not select look at, but select axis alignment, that is axis reference. Our roll bone is going to be referencing the rotation from this helper. And that's the way out, because we couldn't stick both look at constraint and orientation constraint together. That wouldn't have worked. That's why we've stuck orientation constraint into here and simply are referencing the rotation from this dummy object node. As I rotate my FK controller, the roll bone rotates nicely, halfway of the rotation of the FK controller. And it also keeps looking at the green forearm bone, as we rotate upwards, downwards, forwards and backwards. This is due to the look at constraint for our roll bone. Let's turn off our shaded mode view and observe how geometry deforms. Obviously, it's going to be slightly harder to rig this area because you have two roll bones in here, but there's going to be a piece of cake to you if you follow my instructions. There are two areas between which we want to orientation constrain those bones. That is, each roll bone should be weighed between this area and that one. Just as with the shoulder, we would want to use a helper for each of the roll bones because we won't be able to make use of the orientation constraint and look at constraint within one object. As well as that, we will need two helpers that are going to be positioned in the areas of blue circles. Those two helpers are going to be aligned with the roll bones, and their orientation of axis is going to be slightly different to the one of, say, forearm bone or the whichever bone we pick in the right area in here. So let's go into create, helpers, and create a point helper. Create one here and another one right there. Change this color to bright pink. Let's call this one left forearm and then underscore H to signify that it's a helper. This one should be called left wrist underscore helper. Take the first one and align it with one of the roll bones. For example, this one, in position and in orientation. Let's actually change its size down. Then align it a second time to the forearm bone, but only in position, not in orientation. Repeat the procedure with this one. Align it to the roll bone in position and in orientation. Change the size down as well. And actually, before we do anything else, let's get rid of the extra helpers that we don't require. Let's deselect our bright yellow IK controllers, as well as the IK goal, all kinds of wrists and helpers that we don't need. And let's hide them. Let's also get rid of the palm controller. Now let's return back to our helper, and after being aligned to the roll bone, pivot to pivot in orientation and position, we can now align it to the palm bone, in position but not in orientation. That way, what we've achieved here is we have two reference points between which we can weigh our roll bones, and their axes are looking in the same directions, so we won't have any troubles when weighing between those two objects. For each of our roll bones, as told before, both of them are going to be relying on their helpers, and that's the helpers who are going to be weighed between the two areas in terms of orientation. Let's change the color of those new points to bright pink as well, and change this one to left RB2 and then underscore helper. This one should be left RB1 underscore helper. Align this one in position and orientation to its respectful roll bone, pivot to pivot. Click on this one and also align it to its respectful roll bone in position and orientation, pivot to pivot. Then for those two helpers, let's go into motion, rotation, and actually grab this Euler rotation and change it to orientation constraint. For this helper closer to this area, let's add a target to be our wrist helper, and then a second target should be our helper at the forearm area. The weight towards the wrist should be bigger for this helper, something like 70. For the forearm it should be 30, just that those two numbers add up to 100, and then repeat the procedure for this helper. Let's add orientation target 1 to be our wrist helper right here, and the second one should be this forearm helper. Once again, because their axes are oriented the same way, we won't have problem when blending between those two rotations. As for the weight, because this one is closer to the forearm should have greater influence, such as 60 for example, and towards the wrist helper, this one, we should set something like 40. Now, as we select our wrist helper, let's link it to our palm, and as we rotate our FK controller, while our bones are favoring the FK motion, you will see that the FK controller is driving the wrist, which in turn drives the palm. The palm drives this helper, which serves as one of the targets for our two helpers. And obviously you see that this one rotates more vigorously, it listens more carefully to the rotation of this helper, as opposed to this guy right there. Of course, they're grabbing not only the X rotation in which we are interested, but also up and down movement. That's going to be solved as soon as we select them as up nodes, while looking towards this direction for each of the roll bones. Let's select the roll bone, go into rotation, and assign a look at constraint controller. Do this for both of the roll bones. As a look at target, select your helper for the wrist. Keep initial offset. As an up node, obviously select the respectful helpers. Axis alignment. Let's pick our roll bones, go into editable poly, pick them, and from the parent selection center, scale them down on a sub-object level. After that, link those two helpers that are helping the roll bones, link them to the forearm bone. Also make sure that this helper is linked to the forearm bone as well. Link this guy to the palm bone. We don't link it to the wrist, because wrist drives the palm via the FK goal. However, when in the IK mode, we only drive the palm, we don't drive the wrist. By linking this helper to the palm, we ensure that we achieve this flexibility and that those two roll bones are going to be rotating even if we are in the IK mode and are rotating the palm, but not the wrist. After that, change their size down to something like 2 centimeters. Pick your roll bones once again and change the view line length downwards. So go into motion, and the view line should be something like 5 for both of your roll bones. Let's pick our mesh, our IK goal, right click and hide unselected. Rotate our FK goal to an extreme amount, something like this. Then select the mesh, edit envelopes, and adjust the roll bones. As you can see, we've removed the crush from this area, but we want to extend it outwards like so. And we want to achieve nice curves in here. Remember that everything originates from those 2 points, this one and one at the bottom. We want to make it look like the rotation is occurring from this part and extends outwards towards there. Let's select this roll bone, and because we have a nice topology, we can pick loops. change the absolute effect, that is, steal some of the power from the forearm bone over those vertices. For the roll bone, let's grab those vertices and grant some power over them as well. Select this roll bone, closer one to the wrist, and increase the effect on this loop. Let's select our palm bone, select a loop of those vertices, and increase the absolute effect to be greater. For the forearm bone, let's increase the absolute effect over those vertices, and also those ones. We've achieved a very nice transition of the bones. It looks like the motion is originating from those points, and the curves are going outwards like this, following the muscle flow. And it also works in the IK motion. If we select our palm helper, if we are in the IK motion or in between, it also works with the palm controller. Let's add something to control our shoulder's rotation. We can do this by our lovely point. Let's align it to the shoulder bone, in position and in orientation. In local representation of the axis, pivot point center, let's bring it outwards like so. Change its name to left shoulder control. Let's duplicate it as well. Call this one right shoulder control. Make sure to align it with the shoulder bone, not in position but just in orientation, with the right shoulder bone. If you want to, you can align it in the position to the first shoulder controller, in position, but not in orientation. Then in the world representation of the axis, reverse the X direction. If you remember, at the early stage, via the orientation constraint, we weighed our shoulders to be following the chest bones. Let's go into the motion panel, pick our orientation constraint controller, and get rid of the chest control target. Instead of it, let's add another orientation target, our helper to be specific, the controller. Make sure that keep initial offset is turned on. Do the same thing for this shoulder. Now the shoulders listen to their controllers. With the chest turn, you may now control the chest area. You can turn it to the left or to the right, as you wish, forwards and backwards, and also twist it leftwards and rightwards. With the shoulder controllers, as you rotate them, you can lower or raise your shoulders, because the rotation of the shoulder bones is constrained to the rotation of their respectful shoulder controller. The rest of the arm simply listens to this shoulder because they are linked to it as children. But if your artist would rather prefer to work with the position controls for the shoulders, for example, he doesn't like rotation or he's not used to it, you can instead use IK solvers on the shoulders, and that way, to lower or raise it down, move it backwards and forwards, all you'll have to do is to reposition the IK goal for the shoulder. This is an alternative, and let's do it now. In that case, let's ensure that our shoulders are linked to the spine below it. Select both of your shoulders, then link them to the spine that's under them. Because our forearm bone, the green one, is the child of the shoulder, and this shoulder is the child of this spine bone, and the same story happens here. Because of that, we can now put the IK goal between this main parent and its parent, the shoulder, exactly in this area. We can also put an IK goal in here, because this arm is the child of the shoulder. If you apply the orientation constraint for your shoulder bones to be affected by the rotation of their controllers, you'll now have to get rid of the orientation constraint for your shoulders, if you want to use the IK approach. Select each of the shoulders, go into the motion panel, and traverse down from the transform into rotation, find your orientation constraint, ensure that it's indeed in there, and get rid of it from here. Now we got frozen rotation, and also available track in here. The same story happens for this shoulder. Just so that the shoulders can be animated later on, let's click on available and add yet another controller. Euler XYZ, the one that can contain Bezier or float wire or reaction wire parameters. Repeat the same thing for this shoulder as well. Now let's select our arm bone, go into animation, IK solvers, HI solver, that is hierarchy independent solver, and click on your shoulder bone. That placed an IK goal into here. Let's repeat it and do it between the right arm and the right shoulder. Now those controllers won't have any effect on your shoulders because the shoulder's rotation doesn't depend on the one of those guys. But now we can select our IK goal, then lower it or raise it upwards or downwards, move it front to back. We can also select both of them simultaneously, then move them backwards and forwards at once. If you try to turn your chest rotation controller in any of the directions, you'll notice a strange behavior. This is because those joints in this area and right here at the end of the shoulders are staying behind because they are fixed in position due to the IK goals. In order for them to travel with the chest controller, you'll have to link those IK goals to the chest controller. That way their rotation is going to be calculated after the rotation of the chest controller, and they will be moving in an orbit around the chest controller, creating an illusion that the shoulders follow with the middle spine. If you want to return them to their original position, select each shoulder and then align it only in rotation to the old shoulder controller, the respective one, just to its rotation, not in position. It won't matter how you will align it because it's just rotation, doesn't matter center or pivot point. Repeat the same thing for this shoulder. Align to its respectful old shoulder controller, only in orientation. Instead of linking your IK goals straight away to the chest turn, let's first link them to the controllers of the shoulder. That way, we won't have to search for our IK goal in order to bring the shoulder down. We can quickly grab the controller for the shoulder and then manipulate it instead. Let's also grab this IK goal and link it to its respectful shoulder controller. Now, as you move your shoulder upwards or downwards, everything is going to be moving with it. However, if we link those two controllers to the chest turn, you will notice a problem that will occur. The IK goals are controlled by the controller, which in turn is linked downwards to the chest turn. At the start, everything seems okay. But as you approach the more critical rotation, notice what happens to the arm below it. It gets turned. Instead of linking those two controllers to the chest turn, let's relink them to this spine right here. Select both of them, then link them to the spine under the neck. To fix the chest area, we can straight away get rid of this helper because we won't require it anymore. Let's delete it. We'll need two helpers right now, one for each of the chest bones. Let's create a point helper, change its color to bright red. Let's rename it to mutant left chest lookat, and then _H for helper. Let's duplicate this one and rename it to mutant right chest lookat helper. Grab the left lookat chest helper, then align it to the left shoulder bone. Here's the trick. It should be aligned in rotation and position, but the current object should be aligned via the pivot to the center of the shoulder bone. Do the same thing for the right lookat chest helper. Select your chest bone, go into Animation, Constraints, Look at Constraint, then constrain it to be looking at the arm bone, the main parent for the arm, the green one. Constrain it towards it. Keep initial offset turned on. Add a second lookat target, then add the red lookat helper, and do the same thing for this chest. You may want to reduce the view line lengths. If we grab our shoulder controllers and move them backwards, the chest bones will be moving halfway due to the lookat vector that is positioned in the center of our shoulder bone and the second lookat vector which is positioned at the end of our shoulder. Let's grab both of our shoulder helpers simultaneously, then move them backwards in the world representation. As they're raised upwards or downwards, the chest behaves correctly, but it won't respond to the twisting of the arm. A quick and final adjustment for the chest area would be to unlink this IK goal along with that one, temporarily, from their controllers. Grab this controller, then align it to the chest turn, only in rotation. Pivot to pivot, but it doesn't really matter because it's rotation, and press OK. Do the same thing for the other shoulder helper. Now we can link each of the IK goals to their respectful controller. As a final touch, make sure that those two helpers are of course linked to the spine that's under our neck bone, and you're good to go. Just make sure that you freeze the transforms on them. The thing is, if you select each of your controllers and scroll down to position, for example, you'll see that the frozen position is above of everything else. That's because first thing we did was that we froze our tracks. Then we can add wiring or whatever, and that wouldn't mess anything up. If we wouldn't establish our frozen transforms before we would do any kind of wiring for any of the controls,
then as soon as you start to do wiring and try to freeze the transforms for the first time after the wiring, that's gonna screw everything up. Just make sure that you freeze before you do wiring, because that's gonna put a track, and then any kind of freezing that you do after you've been wiring is gonna go for this track, and it won't be touching anything under it. Because we did linkage on those controllers, right click and freeze transforms. Do the same thing for the chest turn as well. For the chest turn, go into motion, and following the principle of the 5th tutorial, go into link info, lock all the movement axes. Along with that, lock the scale. Do the same thing for the main rig drive, but only for the scale. Don't touch the rotate or move. For the FK controller, lock all the move axes, and lock all the scale axes. For the one that's controlling the forearm motion, lock only X and Y rotation. We need to leave the Z, the local one. Lock movement as well, and get rid of scale as well. For the forearm FK controller, get rid of scale and movement. For the IK controller, get rid of rotation and scale. For the palm FK controller, the little blue one that is used by our IK motion, get rid of scale and position. As for the pelvis rocking wave controller, get rid of the scale. You want to be able to move the pelvis with it, and you also want to achieve the rocking motion. As for the feet controller, just get rid of the scale. For the head controller, get rid of the scale and get rid of the move as well. Finally, for the shoulder controllers, get rid of the rotation. They're just for moving. With that, we emphasize to our animator what the controllers are intended for. You might want to change the color of the shoulder helpers to yellow, because that's the scheme we've been following through. For the IK, for example, and the legs positioning as well. There is one final thing that our rig lacks. It is the finger controls. You can use any shapes you like, but I'm gonna use text. I'm going to create letters that initiate the name for each finger. For example, for the thumb, I'll put T. I'll grab it and will align it with the first phalange of my thumb finger, in position and orientation. If it got flipped inwards, don't worry, you can fix this, but you cannot directly rotate your object like this. Instead, we're gonna press Shift and we'll rotate it outwards to create a copy that faces in the direction that we want it to be. We will then go into Hierarchy, Effect Pivot Only, and we'll align this pivot to the pivot of the old T. Then, let's exit Effect Pivot Only regime and discard our old T. As you can see, the new axis of the local T and the first phalange for the finger are exactly the same. Do the same thing to create 4 other controllers. Obviously it's gonna be I, M, R, and P. Make sure to change their color. I prefer to have color of the rainbow for them, since that's gonna make it easier to distinguish between them. For the P, I'll put bright red. For R, I'll put bright yellow. For M, bright green. For I, I'll use bright blue. And I'll use the same color for thumb as well. We need to link our controllers to our palm bone. We have to do this before we add our custom attributes to each of our controllers. Make sure to select them and freeze the transforms. Then select each of the first phalanges for the fingers, put orientation constraint on them, and then constrain them to respectful target, that is to their controller. You might want to keep initial offset in the motion panel, rotation, right there. Do not forget to rename your controllers. The first one can be called left pinky controller, the second one left ring controller, and so on. You want to achieve a nice curl of those 2 joints. When you say, for example, curl the thumb, only those 2 joints. This one can be adjusted by manipulating the T controller. Add master, click on the T, modified object, attribute holder, custom attributes, thumb curl. Double click on this chain to select both of the joints. Add selected, transform, rotation, 0 Euler XYZ, Z rotation.
At state of 0, that should be at 0, but there should be also a state of minimum when the variable thumb curl is at minimum, -2, and also at maximum, +10. During state 2, when it's at -2, the right thumb 2 bone, this one, should be at about -25, -30 maybe. Thumb 3 should be at -15. Click on T and test it out now. Something like this. Perhaps this value is too big, so let's make it -7. Or -10. It depends which kind of character you are rigging. If this is a cartoony character, you would really want to exaggerate this arc. But if it's a realistic character, you only need a minor movement. At state 3, when our thumb curl is at maximum, such as 10, we want the thumb bone to be bent by 50 and the third one to be bent by 60. Test it out now. Perhaps third one should be at 80. Repeat the same thing 4 times, and like this affect all the chains for the fingers. Do this, and then we'll talk about the spread parameter. Because we were working just on the T, none of the controllers have this attribute yet. Look what I've done. I've got the thumb curl, I've got the index curl, and all other 5 fingers adhere to the changes as well. If you don't like something, for example this finger outstands too much, and you would want to bring it upwards, this is obviously index, so let's search for index right here. Middle, index, select it, and you can see which bones it affects. It affects 2 bones, F2 and F3. And actually this is not index, this is a middle finger. So let's pick middle, state 2, F2 should be at 20. Like this. Let's select our attribute holder, press Ctrl, and left click and drag to spread it to other controllers as an instance. That way, being on any of the controllers, you can affect the parameters for the finger just as if you were on T. As well as that, in local, pivot point center, you can rotate the finger joints at the knuckles area. Finally, let's consider the spread attribute. You can argue whether the spread should affect the thumb. In our case, we're just gonna focus on the 4 fingers. Let's pick our T, or any kind of controller that has attribute holder instance on it. Add master, add this controller, modified object, attribute holder custom attributes, spread. Because our bases of fingers have orientation constraint on them, we won't be able to parameter wire the rotation axis for them. However, we can do this for controllers. Because we froze the transforms of the controllers, we are on the safe side, since we won't have to freeze them after we've done our parameter wiring. Select 4 of the controllers and add them as a slave to the spread. Transform, rotation, 0 Euler XYZ, Y rotation, around the vertical axis. Let's start with the index finger. At maximum value, it should deflect by about 7 degrees in a negative direction. Let's bump it up slightly, -12. The middle finger will stay unchanged. The ring finger should be rotated positively, because here it was a clockwise rotation. For the ring finger it should be a counterclockwise one. Let's put 12 in here. As for the pinky, its deflection is greatest. Let's put 24. Or actually, 30. Maybe the middle finger should be rotated slightly, by about 4 degrees, in a negative direction. With that, you've achieved a very flexible structure, a very flexible doll. You got clear controls that can be accessed easily, they got parameters that are arranged neatly, and are always at hand.
Well, that was an interesting lesson. Sir Thompson, did you understand everything we were talking about?
Yes, I did. But when is the next tutorial gonna be out, Mr. Aherne?
Huh, I like your spirit, young man. Give me a little bit of rest. We'll be gradually mastering this wonderful subject. Today you've tackled a huge milestone of 3D for games. Congratulations. We covered mesh overview and assessment, building a skeleton, watched over the wide variety of skinning techniques, did parameter and reaction wiring, covered mech script and custom panels, animation hints, IK and FK, as well as blending between them. We were manipulating with variables such as transform via the external tools. We used different sorts of constraints, learned about limitations of linking, and we're working with different parameter types of transform. The next part will be on character animation for games. I really hoped you liked this tutorial. If you'd like to thank me, please put a like and subscribe. Throw a share if you enjoyed it especially. Let's bring more like-minded people together. My name is Igor Aherne, and you've been watching part 6 of how to create a horror game. Thank you once again. I hope to see you next time. Goodbye.